Yo, folks, we're about to get started.
Connect cord, 1 second. How important is that?
Here, hopefully in like 10-15 minutes to get started.
Hey folks, we are about to get started. Just stay tuned and the workshops will start momentarily. We are very excited to have you on Local Hack Day. Join the Gitter channel at gitter.im/mlh/local hack day. See you soon. Okay. Sorry.
Allergy medicine not working? There could be a simple scientific explanation. Your symptoms aren't caused by
Give him a hand. I'm not prepared. I really am not prepared at all. It's so damn hot. Milk was a bad choice.
Hey! Where did you get those clothes? At the toilet store?
Rick, where'd you get a hand grenade?
I don't know.
It's called Sex Panther by Odeon. It's illegal in 9 countries. Yep, it's made with bits of real panther, so you know it's good.
It's quite pungent.
Oh yeah.
Ooh, it's a formidable scent. Stings the nostrils. In a good way.
Yeah.
Brian, I'm gonna be honest with you, that smells like pure gasoline.
They've done studies, you know. 60% of the time, it works every time.
That does make sense.
I love carpet. I love desk.
Brick, are you just looking at things in the office and saying that you love them?
I love
Good morning, local hack day.
Hey everyone, how are you all doing?
This is Swift and Shy coming at you live from New York City, from the anchor desk here at Local Hack Day. Morning, Shy, bright and early. Good to see you.
Excited to do this. This is our first ever distributed hackathon. It's been in idea form for about 11 months, and we've been working on it for 4, so we're really excited to bring it all to you today.
So how many people are tuned in right now?
I don't know, John, how many people are tuned in right now? We have John right behind us in our production area.
Say hi, John.
We're at 26 schools.
26 schools tuned in live right now.
Awesome.
Nice.
We should have 10 more coming in once noon hits. We have a lot of schools in California, and we have a couple schools in Texas on different time zones, so that'll be exciting.
Of course, sometimes I forget that there's other time zones besides EST.
It doesn't make sense. We should just all be on the same time.
I agree. So how many people are we expecting at Local Hack Day this year?
We're hoping to get 2,300, which is the single biggest collegiate hacking.
Well, it's not just collegiate, it's student, right? So it's
Students,
single
yeah.
biggest student hacking day.
We have a third of our schools are high schools. I know Cupertino High School is in there. We have BCA, who's kind of a stalwart of the hackathon scene. We have all sorts of people, and we have a lot of new events that have never hosted a hackathon ever before. Fordham is a big one that I'm really excited is here. Vassar College, Vanderbilt, a lot of schools that have never done a hackathon before, and we're really glad to be able to make that happen for them.
Wow, that's awesome.
Yeah.
So tell me, what's the point of Local Hack Day? Why are we here today?
So it's the end of the semester. It's finals week, leading up to finals week, or finals week is over. We really want to celebrate all of you hackers that
All
have
of
been
you, every one of you.
all of you hackers that have been phenomenal this season, building really cool projects, making awesome things, traveling all over the world, all over the globe, building communities, sharing communities, and coming together. This is really for you, and we want to make sure that you guys all feel like you're going out of the season with a bang. So, and what better way to do that than by coming together and hacking together?
This is for you, America.
And Canada.
And Canada. And didn't you say we had somebody from like South Africa?
We have a South African school, and yeah, hopefully they're tuned in. They might be getting tired by now.
Yes, of course. Well, I'm glad to hear that we're doing this for the hackers. So now I know that there's quite a bit of content we got lined up today. Tell me about what we've got in store.
So we got some phenomenal workshops coming up. We have a close friend to MLH, Randall Hunt, will be giving a GitHub workshop.
Randall, just so everybody knows, it's Randall's birthday. So when Randall is giving his workshop, make sure you tweet at him. His Twitter is @JRHunt. Just tweet happy birthday to Randall. It is his birthday. He's giving up his birthday to be here on Local Hack Day to give you guys a workshop about Git.
Yeah.
So make sure that you spread the love to Randall.
And we have our very own Jason is going to give a Hubot talk. If you're in the chat rooms right now, I hope you're trying out MechaSwift. We've open sourced the internal MLH chat room bot, so you guys can hack on it, and we want to see some really exciting stuff come out of that by the end of the day.
What I want to know is, how does MechaSwift have like a really nice mustache, and I don't get that.
So we actually used MechaSwift to make that picture of MechaSwift with a mustache. There's a function in there called Mustache Me. So I'm betting everyone in the room now is trying this. If you do @MechaSwift, mustache me, and then import a URL, so we imported your sticker, it'll automatically put a mustache on him. And we went through at least 2, 3, or 4 until we found the one with the swirls.
The right one, the swirls.
Yeah, we'd like to encourage you to grow that out.
I will work on that for next November. Interesting. So
we should also probably thank our phenomenal sponsors.
We wouldn't be here today without them. So,
so we have Keen, we have Order In, and we have DigitalOcean, and thanks to all 3 of them for helping us.
Absolutely.
Out. And we'll have talks and workshops from all 3 of them later in the day.
You know what I love about those 3 sponsors?
Yeah.
They are always out supporting hackers.
They are definitely always doing
frequent
that.
bases at hackathons.
Yeah.
Wouldn't be here without them. Good for them.
A lot of hackathons are definitely dependent on them. And I've seen the best part about them is they're phenomenal at mentoring people.
Yeah, that's true.
I've seen both, Sam, Kaushal, and Tim do fantastic mentorship at events, and really thankful that they're with us.
I agree. So what are you most excited about for today?
So I'm really excited to see what people do with this Hubot. I think that's going to be cool. I think we've got some great talks. We have Bonnie Eisenman from Code Academy coming in for an Arduino talk. We're having a guy who's driving here from Boston, really excited to give an Oculus Rift talk.
Nice.
We have a Lady Storm Hackathons virtual meetup, which is going to be super cool. I'm really excited to see how that turns out. What about you?
Well, so hang on. How are these virtual meetups?
Between workshops, we'll call into every school. We'll try and feature every school. We'll call them in over Skype, and we'll do an interview. We'll talk to you guys and see, what are you building, what are you making, what are you most proud of accomplishing over the season. Seeing the crowd wave to everyone.
Nice.
I want to see people in their hats. If you have a hat,
yes.
you have to wear it. It's
I'm telling you, this is going to give me the worst hair day ever. You guys are not going to want to see me after I take this hat off.
But you're definitely not going to get cold or lose heat through your head, which is a definite problem in the winter.
That is true. It is winter time finally.
It's Major League Hacking mitigating hypothermia for the community.
That would be Major League Hatting, right?
Hatting.
Major League Hatting. That's funny. So yeah, if you have something that you'd like to share in the live stream, definitely let us know. Happy to feature you. What's the best way for people to get in contact with us? Twitter, Facebook, Gitter?
Twitter would probably be the best way to get a hold of us. Tweet at MLHacks. With hashtag Local Hack Day, or you can Gitter us directly. But Twitter is probably the fastest way to get a hold of us.
Yeah. We'll also be monitoring Local Hat Day in case you want to show off your
hat selfies. Yeah, Local Hat Day.
That's great.
So I've seen some really great selfies actually up until this point. Someone created a Hackathon Hatters.
Oh, wow.
Subgroup for Hackathon hackers, and it's you're not allowed to post anything but the word hat in the group. I got in trouble. I posted a sentence.
Oh, wow.
I got a stern talking to.
You gotta make sure you read the rules before you talk, man.
You've got to do that. Follow the code of conduct of the subgroup.
Speaking of the code of conduct, this seems like an appropriate time to transition to our code of conduct. Why is the code of conduct important?
Oh, the code of conduct is important. Something you always say, and that I find really encouraging, is that every hacker has the right to hack. And that's really important to us all here, that making sure everyone feels like they're in an inclusive environment that's friendly and welcoming to everyone. And part of that is making sure that we have standards that we adhere to, and that if those standards are violated by a fellow hacker, an organizer, or even us as MLH staff, there's a way to report that. So if you Google our code of conduct, and just Google MLH code of conduct, I think it's also mlh.io/code of conduct.
Yes, I'd probably. If not, we should make that.
But Google it. Google will take you right there. It's also on the link, actually, on the Local Hack Day website, and every Local Hack Day event has a link to our code of conduct, so everyone should be following it.
Also, we sent out an email that has a code of conduct in it,
We
too.
sent out 2 emails with our code of conduct, yeah.
Good. I think John has a video he's going to queue up here for us with the code of conduct, so
Fortunately,
we'll pass it off to John.
Good surprise.
Hello, I'm Nick Quinlan, and I'm the Commissioner of Major League Hacking. I'm here to talk about a code of conduct. We want every Major League Hacking event to be a welcoming environment for everyone. Please, be respectful. If somebody asks you to stop doing something, it's probably worth stopping. If you're in a situation that makes you feel uncomfortable, please report it to Major League Hacking, no matter who's involved. That includes participants, sponsors, mentors, organizers, and even Major League Hacking employees. The easiest way to report an incident is by simply emailing incidents@mlh.io. Full information on how to report, including information on how to report to specific Major League Hacking employees, is available in our Code of Conduct, which is available on this event's website as well as the Major League Hacking website. Thank you so much, and we hope that you have a safe, fun, and welcoming event.
Oh, hello, America.
I didn't know Nick was going to be a part of this. I thought he was in some, foreign, not New York place right now.
Yeah, I'm pretty sure he is. Knowing Nick, he is probably actually awake right now. He is an early riser, so, well, thanks to Nick for that wonderful introduction to the Code of Conduct.
You know that bookshelf he has? I really want that bookshelf. I really like the bookshelf he has in there.
Yeah, well, you'll have to ask him where he got it.
It's definitely not an IKEA bookshelf. It's much nicer than that.
All of my furniture is IKEA, not gonna lie.
So is mine. I actually don't have a bed right now. I just have a model train set. It's pretty excellent, not from IKEA.
Okay.
I encourage other hackers to... actually, that was one of my favorite hacks that I saw this season. There was a group of students, Rutgers students, and a student from Louisiana Tech who's actually organizing the Louisiana Tech Hack Day, built a Internet of Things where they took a Intel Edison, the new Intel Edisons, they mounted it to a model train, and they had it running through rooms with sensor data and pointing that onto an iOS app live, so you could be out and about and log into your model train and see,
awesome.
What's the air pressure and the humidity in multiple rooms of your apartment. Definitely my favorite hack of the season.
That's really interesting. What hackathon was that at?
That was at Hack and Y.
Really?
Yeah.
I always love a good hack where somebody takes a random device, like a remote control car or a train or a fan or a microwave, and then they hook it up to an Arduino or an Edison or some kind of microcontroller, and they can do something cool with it. It always blows my mind because I have no idea where I would even start with that.
I don't know either. That's how I feel about all the power gloves we've been seeing this season.
Yeah, right?
There have been so many different executions of that same concept. I've seen people that have taped wires to their hands, people that have actually built sensors.
Well, my favorite one was from HackerU, where the guy actually cut the elastic off of his sock to make the power glove possible.
That's dedication.
That is
right
dedication
there.
right there. Yeah. So, what kind of things do you think hackers should be expecting or working on today? What do you think people will be doing out at the local hack days?
So so it is finals week. So I expect a couple people will be studying.
Yeah.
Hopefully they'll ace their classes. I expect there'll be a lot of people finishing up projects that they've started earlier in the season that they just hadn't had time to polish. I know back when I was a hacker, I certainly built a lot of projects that I wanted to get back to and just never found the chance. So today is actually the perfect time to do that. If there's that thing in the back of your mind that you just want to build, you should do it. But it's also really important to note that we have a lot of first-time hackers on our stream, and for a lot of people, this might be the first time they're introduced to modern technologies outside of their classes. And so I really hope people use this as an opportunity to learn something new, try something new, and expand outside of their technological comfort zone.
Yeah, I think that's pretty fair. I think that you should take Local Hack Day as an opportunity to like go out and try whatever new thing that strikes your fancy. I mean, honestly, nobody ever got an F in class because they went to a hackathon and tried something new. Nobody ever lost their job because their hackathon project didn't work out in the end. But like, you know, push the boundaries, try something new today. It's definitely a good opportunity for that, for sure. Cool. So, what else? So obviously this is the tail end of the fall season, and we're gearing up for the spring now.
Yeah.
Looking back, what's your biggest takeaway from this fall season? Like, what surprised you the most?
Oh gosh, that's an amazing question. So this has been a really special season for me. This has been my first season as a member of the MLH team. And,
That's true.
And something I didn't realize was how much fun it is to get out there and like mentor people and like instead of hacking, like really working with other students and how like rewarding that can be. And that's something I'd encourage actually everyone to try. When you're at a hackathon, take a moment to find a new hacker and really try and mentor them and really help them come, you know, take their first project from this idea, from where they're kind of, you know, a little intimidated by being at their first event surrounded by people, and really making sure that you can do as much as you can to get them to the final demo so they can give their demo at the science fair or give their demo on stage, and that's absolutely the best part of every hackathon, and I didn't realize how much I would like that.
Yeah.
And I'd encourage everyone to try it.
Well, finding a way to give back is super important, right? Like, you don't have to be an expert in order to help somebody get started, right? Like, there's tons of novices out there who don't even know the first thing about HTML or like Python, or like pick your language, framework, tool, whatever. Certainly, there's a lot of opportunity for people to give back, and especially at Local Hack Day, where a lot of these people, it's like the first time they're using these technologies. So, great opportunity to practice your mentoring. Great opportunity to give back to the community. Great opportunity to get new people excited about hackathons and all the stuff that's going on this season. So there's 33 local hack days going on? 34 local hack days, pardon me. That's awesome. There's 34 local hack days going on right now.
Across the US and Canada.
Across the US and Canada. How many of them are in Canada?
I think 3 of them. We have McGill, we have the University of Toronto, and then we have McMaster's.
Okay, I'm going to challenge you. Do you think you can name every single one of the local hack days?
Let me try that. Okay.
Right, I'm going to count.
So we have the University of Cincinnati, my alma mater. We have Stony Brook, John's alma mater. We have Rutgers, yours. We have UCLA, Cupertino High School.
Is that 1 or is that 2?
That's 2.
Okay.
We have the University of Texas at Austin. We have Louisiana Tech. We have Vassar College. Then the 3 Canadians, McGill, Toronto, McMaster's. We have Fordham, which is a new one. We have the high schools of New York. We have, oh gosh, this is hard. This is where it gets difficult. Boston, we have Boston College. We have Purdue. Purdue is joining us. Penn with Albert Go running that. Gosh, this is hard. I didn't realize how hard this is. I have this long document with all this list.
Well, you're more than halfway. You're almost halfway through.
Halfway through.
Princeton?
Princeton is a part of it, yeah. There's a couple more high schools. BCA is part of it.
Yep.
Tino, well, I said that one.
Yep. Lots of high school students as well.
Lots
That's
of
good.
high schools, yeah. We're about a third high school, which is surprising. We have a middle school in there actually as well.
Middle school, right?
Well, yeah, run by, I think he's 13.
13?
The organizer of that hackathon is
Wow.
is 13.
Dude,
So
I wish I was organizing hackathons when I was 13.
I wish I
That's
knew
crazy.
about hackathons when I was 13.
That's amazing. What about in the South? Georgia?
We
Or-
don't have Georgia Tech, no. I think they're out.
Yeah, that makes sense.
But yeah, the big South ones are UT Austin and Louisiana Tech.
Interesting.
This is kind of like naming all the states.
I know, right? Yeah, I can name all 50
You
states.
can name
I'm
all
pretty
50
sure.
states.
You know, yeah, I think I can.
Are you going to sing
I'm
to
not
us
going to do it
right
right now. No. I don't want to subject the listeners to that. That would be pretty bad. Interesting. Okay, well, so that's a lot of schools out there. That's it's quite a list. And do you know how many of them are first-time like hackathons? Like their school has never organized hackathons?
About half of them, actually.
Really?
Yeah, I took a look the other day. Someone was interviewing me, and it turns out about half of them. It used to be a third, but then it grew. The later into the season we got, it grew. University of Wisconsin-Madison, that's another new one.
Madison, true. Well, they're having something in the spring as well.
Yeah. Well, a lot of them are upping to the spring. So this is a good event for them to take to their administration and be like, this hackathon thing, it's not about what you think it is, and we've done it before.
Right.
Like it's just an extension of something natural that we've been doing.
Interesting.
So
Well, that's cool. Yeah, it seems like there's a lot of interesting stuff going on today. Cool. So, what is our first workshop that we have coming up after we're done?
So we have Randall Hunt coming here in a few minutes. He'll be giving an intro to Git workshop.
Right. So this is an interesting one. Okay, so like we have all these introductory tutorials.
Mm-hmm.
Like, what are the ones that like everybody should know? Like Git is a good one. Like everybody should understand how to use version control. That's a really good thing that's universal that everybody should get. Like, what else do we have coming that's like...
I think if you have... So I think a really important one is if you have a smartphone in your pocket, you should know how to do at least something on it.
Yeah, definitely.
If you've been carrying around an Android, you should definitely tune in for our Intro to Android talk. And if you're carrying around an iPhone, you should definitely tune into your iOS workshop.
Yeah.
I think that's one of those inexcusable ones where you've got to know how to build on top of that thing you have with you.
Well, I've definitely been noticing a trend where it's like there's more and more iOS and Android development going on at hackathons for sure. Like mobile, has always been a thing.
Yeah.
I mean, if you think back to like the start of student hackathons, like mobile development has certainly been around since then. But I've definitely been noticing a trend of like, first we had all of this web development, and then like we had this like dawn of like mobile being a thing, and like now we're kind of in this hardware realm, but like mobile is obviously still on the increase as well.
Yeah.
So yeah, mobile is a pretty good one. Also, it sounds like we have like an intro to Arduino talk, right?
We do. Yeah, hardware is definitely really important to learn. We have a Mayo talk. And for anyone that's tried to use the Mayo in our hardware lab, definitely tune in, or wants to use the Mayos in our hardware lab, definitely tune in. And then we also have the Rifts in our hardware lab.
That's true.
It's another great place to start is the Oculus Rift talk.
What else in that hardware lab? It's let's see if I can do this. It's Oculus, Mayo,
Yep.
Tessel, Arduino, Pebble, SparkCore, Leap Motion, Alienware, the Dell monitors. What else do we have? That might be it. There's a lot of things in there.
We actually have Unity in that hardware lab too,
Unity
even though
too,
it's not
yeah.
hardware.
That's true. Well, you need Unity to do
Yeah.
Oculus development in a lot of ways.
We have a lot of great stuff actually in the GitHub student bag.
Oh yeah, that's right. Never
There's Unreal is in there.
That's true.
You get DigitalOcean credit.
That's true. Also a sponsor of Local Hack Day.
Yeah. There's definitely a lot of awesome things in there. So if you don't have the GitHub student pack, I'd recommend checking it out and getting it set up before you get to a hackathon.
Yeah, man, that's ridiculous. Like, I wish I still had an EDU email address. I would definitely do that.
We've got to get mlh.edu.
Yeah, right. We definitely should get that authorized, 100%.
So just so that we could get the email address.
That's great. Okay, so say you're a student hacker, and you're out there at Local Hack Day, and you run into a bug or like a problem, and you're stuck. Like, where do you go for help today?
So the best place to do that is to jump into our chat rooms. We have a bunch of chat rooms set up. So we have a general one, which is Local Hack Day. It's all on Gitter, which is a GitHub-powered chat service.
Oh, that's interesting.
Which is really cool. It's really polished. It's really nice. And they're divided into subcategories. So we have a room for new hackers. We have a room for web development, mobile development, hardware hacking. Definitely get in there and post in there, and someone will respond. Tweet it out. Or even better, look around the room. If there's, yell at people in your room and
Just
ask
yell.
someone in your room to help you, and hopefully someone does.
I need an adult.
I need a grown-up.
Nice. Okay.
So.
Interesting. Yes. I'm excited about the chat room. So I remember back in the early days of Hack and Y, we used to have that IRC thing. I don't know if it's still
We
around.
still have that IRC,
That's still a thing. Yeah, it used to be a lot of fun to hang out in IRC and chat with everybody. So this one is a little different. Gitter, not IRC. It should be a little easier to get started with. But yeah, it'd be fun to hang out and chat. You can obviously the Hubot is in there. People can hack on that. That'd be great. Very cool. And so I think we also are providing pizza too, right? So everybody should have a pizza meal at some point.
Covering lunch for everyone. We're bringing pizza for all of you. So
awesome. So look forward to some delicious pizza. Lots of hacking and workshops. What else should we talk about? Oh, you know what we didn't talk about? Where are we right now?
So we're in a fantastic co-working space called Q Labs. Q Labs has graciously given us this space for the full day.
And what is Q Labs exactly?
Q Labs is the co-working space for Quotidian Ventures, which is a venture capital firm based out of New York.
Yep.
So most of the companies here are part of their portfolio. And there's a couple other ones. Hack and Y, the Hack and Y Fellowship. First ever collegiate hackathon is actually based out of this office. My desk is right there.
You better be careful, man. There's some people on this stream who don't agree with that statement.
Oh man, I'll fight them over that. So not the first student-run collegiate hackathon, but the first collegiate hackathon.
Getting into technicalities here.
Oh, man.
So I think that's actually something interesting to talk about too. Like, what is Hack and Why, and why should people in the viewership care about that? Not the hackathon, obviously. I mean, I think they should know what the hackathon is, but.
So I feel like I should go put my Hack and Why sweater up now
Yeah,
and
right,
start.
there
So Hack and Why is a nonprofit based in New York. We pair students up with awesome startup companies. Actually, weird thing. So the Hack and Why Fellowship, where you get paired up with a startup, the alumni network is really strong. I'm a member of the alumni network. You're an unofficial member of the alumni network, so is John.
Sure.
And about half of our speakers today, actually exactly half of our speakers today, are alumni of that network.
Very interesting.
There's some great speakers. Randall, who will be up first, is a Hack and Why alumnus, which is exciting. So if you're interested in coming to New York and working at a startup, definitely check out the Hack and Why Fellowship.
Yeah.
At hackandwhy.org.
I don't even think Chai is doing this justice here. It's like, not only like do you get hooked up with one of the most badass jobs in all startup land, we also get free housing in the greatest city in the world, New York, of course. And not even in just like some random burb of New York, but in the heart of it in Union Square. Yeah. There's a series of talks from some of the best people in technology. Like, who are some of our highlight speakers from
Gosh, we had Richard Stallman last year. We had Fred Wilson of USV. We had a whole bunch of people. We had the CTO of MongoDB.
Of course.
We had some people from Chartbeat. We had the CEO and CTO of Codecademy, Zach and Ryan.
Yeah. And it's not like a 300 or 400 person lecture hall. This is an intimate fireside chat with like these people.
30 people at most, and you get fed during those too. So
wow.
with some of the
free
best
food,
New York
free
cuisine.
housing.
Yeah.
Wow. It's a good deal.
It's
definitely worth checking out. Where do they go to?
Hackandwhy.org. Apply.hackandwhy.org.
Apply.hackandwhy.org.
The deadline actually for the second round is the 15th. So if you want
January?
of this month,
of
December.
December.
So
Oof, it's coming
gotta
up
apply
quick.
quickly. Yeah.
Yeah. That's a good one. Cool. What else should we talk about? We could talk about next season. When does the 2015 spring season kick off?
It kicks off January 7th, right? Or January 10th.
9th or 10th, maybe. I don't know. I don't know.
With Dragon Hacks, right?
Yeah, Dragon Hacks.
That's such a cool sounding hackathon.
Dragon
I really
Hacks.
want to go to Dragon Hacks.
Well, I'm sure you'll have the opportunity.
Where is that?
It's at Drexel University in Philadelphia.
Philadelphia, that's an easy one to get to. Nice convenient Amtrak.
Yeah, very true.
Just stay there for a week too afterwards, and then go to Penn Apps afterwards.
Yeah,
or maybe fly to Michigan.
That's true, or Michigan to MHAX. Yeah, MHAX and Penn Apps coming up early.
Their admittance actually just went out last night.
Really?
Yeah, so be sure to check your email if you applied to either of those hackathons.
That's a big deal, yeah.
I think it's really exciting actually that we have, because of that weekend, we'll have 2,500 students being able to hack, and so that'll be phenomenal.
Almost as many as local hack day,
right? Almost as many as local hack day.
Yeah, slightly more in person, but yeah, it's interesting.
It'll be great. So many people that have been wanting to hack will have the opportunity, which I think is fantastic.
Yeah, well, it's really interesting because I do think that. I mean, what was the number for this season? Like 25,000 people participating in hackathons all over the world?
Across 38 events for us.
Well, 38, and then if you include local hack day, that's what, like another
39.
So it's like 60 something, and then the UK is another 10. So, yeah, lots of demand for student hackathons. I think that obviously the more events that go on, and the more that people hear about it, the more people will want to get involved. So
we also actually started MLH Mexico this season too.
Yeah, that's true. They joined the North American League.
That's really exciting.
We had I think one event, and then coming up this coming season, it looks like we'll have like 5 or 6. So that's pretty exciting.
And then we had an event in Shanghai too, didn't we? In Puerto Rico.
We had one in Puerto Rico. There was an event in Shanghai that we sent some hardware and swag to for sure. It sounds like there's also going to be a couple events in like the Philippines, South Korea, all over the world really. Like student hackathons are
exploding.
Yeah, exploding. Literally, can't tell you how quickly it's growing.
I hear there's some interesting ones coming up on. I don't know. I'm always excited for BitCamp and like Brown, and there's some really exciting ones coming.
Yeah. Well, so we've been doing spring sanctioning interviews. And speaking of which, if you're an aspiring hackathon organizer who would like to be a part of the spring season, if you go to the Major League Hacking website and you click on the spring 2015 season, you can apply for sanctioning for the spring, which is great. I think Nick Quinlan and I have spoken to something like 45 or 50 different hackathons in the U.S. alone for the spring, which is absurd and awesome, and I love it. But lots of awesome events coming up, lots of really interesting hackathon organizers that I had never met before, lots of stuff in the Midwest, which I'm really excited about.
Yeah, we're starting to expand there. You can kind of see if you take a look at our local Hack Day map. It's very similar to our actual MLH map, and the middle is kind of.
Well, I think we need a little bit more in like the Pacific Northwest going on, that kind of in the Southwest for sure.
Definitely the South, yeah.
One of the events I'm really excited about is the Arizona Hackathon.
Yeah.
Yeah, that's pretty cool.
That's March 6th and 7th, right?
Yeah, I think so. Which is pretty exciting. I spoke with those gentlemen at length. It sounds like a really cool event. That one seems like it's pretty neat.
It'll be nice and warm too.
Yeah, well.
March.
Yeah, anything. I hope I only get to go to the events in the Southwest where it's nice and warm. I remember what it was like going to like Detroit and Purdue last winter. It was.
Man, I was so sad. I wasn't actually able to get to Penn Apps last winter. I got stuck in flights. I had a bag of. I actually had a box of dry ice filled with ice cream that I was going to bring to Penn Apps, and ended up having to eat 30 pints of ice cream over the next 2 months by myself.
Oh, dude, no. So much lactose. Oh god.
Yeah.
That's brutal.
We had some fun things planned involving potatoes that might come back for this Valentine's Day.
A hack involving potatoes. Wow. Yeah. Well, I look forward to seeing whatever that hack is.
Actually, interesting fact about potatoes. Did you know that when potatoes were first introduced into the United Kingdom, they were used as a dessert item?
Really?
Yeah, and they were also illegal in France for a period of a couple years.
Why?
I have no idea. My research wasn't that thorough, but it was definitely illegal in France for a small period of time. I want to say around 1913.
Interesting.
Yeah.
Wow, I had no idea. I learned something new today.
Yeah. So I did a lot of research actually. All of the organizers have these like personalized note cards. So if you're at a hackathon, make sure to bother your organizer to take a look at it. See what unique and interesting facts we sent you.
Yeah. Do we have any programming jokes?
No, we don't. We do have a couple programming facts in there. Okay. Something about the size of the internet. I think the internet actually only weighs about a strawberry.
Really?
I have no idea how they came up with that. Came up with that answer, but
interesting.
Yeah.
Wow. The whole internet.
The whole internet. If you I guess put it in like SD cards or something, would probably weigh about a strawberry.
That's really interesting. I know we alluded to this before, like some of those trends that we'd seen in hackathons and hacking and like all the hacks that we've seen. What are some other trends that you've seen over the last couple of months?
So, I mean, we've definitely seen the Power Gloves. Seeing a lot more people trying hardware out for the first time, which is probably because of us bringing hardware labs. Seeing a lot of really interesting... Oh, sorry.
Switch papers.
Switch papers?
Yeah.
We have a lot of really thorough notes on here.
Lots of notes here.
Seeing a lot of Internet of Things stuff coming.
Sorry, passing notes to John in class. I think that I definitely have seen a rise in hardware. Like obviously, us bringing the hardware lab to events has been pretty helpful for that. I actually think there's multiple classes of hardware hacking too, which people don't. This is interesting, right? Like, well, so there's hardware where it's like microcontrollers and circuits and like people with like literally like soldering and like building things in hardware land. And then there's like software hardware, which is like Oculus hacks or Leap Motion or Mayo or Pebble, right? Where it's like you're not actually like doing anything with hardware. You're like interacting with some kind of hardware device. So I think it's really interesting. I'm not actually sure whether those qualify as like software or hardware.
Yeah.
It's interesting. So people are obviously you're hanging out in the chat. They're always going to be following along in the live stream. Where else can people get updates about Local Hack Day? Like, we're tweeting?
We are definitely going to be tweeting. Okay. We'll be shooting out a lot of tweets, so definitely pay attention there. Always like and subscribe to the MLH Facebook page.
Yep.
We'll be pushing out information there, and pay attention to your email. If you haven't gotten an email, you can subscribe. If you click on the email that we've sent out over Twitter, you can subscribe right there. Or if you bother your organizer, they'll they'll be able to get your email address to me, and I'll be able to add you to our email feed. And so definitely pay attention to your email.
Yeah, actually, that's another good thing. Big shout out to all the organizers of local hack days all over the world. Like, obviously, as a hacker who became an organizer myself, like, I know exactly how much work goes into putting on an event like this. So, big shout out to all the student organizers at all the different universities and high schools and middle schools who put on local hack days. So there's a lot of effort that goes into it. It's not nearly as easy as it looks from the outside. It definitely is a lot more chaotic on the other side of the table. So big shout out to all of them.
Fantastic job, guys. Keep it up.
When did you start contacting organizers about local hack day?
About 4 months ago.
Okay. Well, give us a rundown of the history of local hack day. Like, how did this play out?
So the history of local hack day actually, I think, goes back to when I was a hacker.
Okay.
So about a year ago, I got hooked into the organizing scene at Hack MIT. Hack MIT recruited a couple of us to rewire their network when the Wi-Fi went down.
Okay.
They refer to us as their wire bitches. So myself, I think Brynn, Russ Frank, Albert Go. And I got tapped into the organizing community, thought it was awesome, wanted to organize. You and I hopped on a call, told me to come to HackCon. I came to HackCon. And that's where the idea for Local Hack Day happened. Was at HackCon with just talking to organizers. I brought it up. You and John were both on board, and then we started working on it. And so Local Hack Day has been, I guess, in the pipeline since February.
Interesting. Okay. Well, it looks like we're gonna take a break. It sounds like we're gonna have a slight change in our schedule. We're gonna have a
Hubot talk.
Hubot talk. We're gonna talk about Hubot. That's great. So we'll kick off the day with that. We will update the schedule on the website so you can follow along, but we will be back in a few minutes, guys. Thanks for watching.
Strong is a guy that thinks he's right, is also known as a buster. Always talking about what he wants to just sit on his broke ass. So, no, I don't want your number, no. I don't wanna give you mine, and no, I don't wanna meet you nowhere, no. Don't want a little time, and no, I don't want no scrub. A scrub is a guy that can't get no love from me. Being on the passenger side of his best friend's ride, trying to holler at me. I don't want no scrub. A scrub is a guy that can't get no love from me. Being on the passenger side of his best friend's ride, trying to holler at me. Look at me, but this game is kinda weak, and I know where they cannot approach me. 'Cause I'm looking like that, and it's looking like that. Can't get with a baby ass. So, no, I don't want your number, no. I don't wanna give you mine, and no, I don't wanna meet you nowhere, no. Don't want none of your time. I don't want no scrub. A scrub is a guy that can't get no love from me. Being on the passenger side of his best friend's ride, trying to holler at me. I don't want no scrub. A scrub is a guy that can't get no love from me. Being on the passenger side of his best friend's ride, trying to holler at me. Hey, car, and you're walking. Oh yes, son, I'm talking to you. If you live at home with your mama. Oh yes, son, I'm talking to you. If you have a shorty that you don't show love. Oh yes, son, I'm talking to you. Wanna get with me with no money? Oh no, I don't want no son. No, son, no, no.
We spy and told was the only one.
Uh-oh.
All the small things, true care, truth brings. I'll take one lift, you're right, best trip, always
You're live.
Morning, I'm Jason with Major League Hacking, and I'm here on Local Hack Day to talk about using Hubot, an open source hackable chat robot for small teams that we have live and running in the Major League Hacking Local Hack Day Gitter chat room. So Hubot was released by GitHub about a year ago, and it's their modification of their campfire robot, which allows them to do things like ship code to production straight from their chat room. Hubot released this to the world with a set of scripts that they found useful, and they asked the community to write their own scripts for whatever they found useful. So people have written scripts to send pictures of cats into chat rooms, ship code on the varying environments, and all sorts of random things that are useful, entertaining, what have you. There's a massive repository of these scripts living on GitHub. It can be found at github.com/HubotScripts, and Hubot is very extensible, very easy to hack on, and I'm going to walk you through building something for Hubot right here. We have MechaSwift, our Hubot bot, running in Gitter today, and we invite all of you to hack on it. The repository is open source. We invite you to submit pull requests, and we will review them and deploy right to production. So you're all welcome to play with that, and let's jump into a demo. So I have here our Hubot repository. So I'm going to create a new script for retrieving Bearcat facts. Hubot scripts are simple module exports. So we export a module in CoffeeScript that describes how the robot performs a certain interaction. That interaction can be a number of things. It can respond to people entering a chat room. It can respond to people sending specific messages. So we're going to respond to anyone who types the word Bearcat in any case. It could be uppercase, lowercase, doesn't really matter as far as Hubot's concerned. Our good friend Shai, who you met earlier on the live stream, has this great website called bearcatfacts.info, which gives you, as you'd expect, Bearcat facts. So this one, you should own a Bearcat as a pet, is absolutely true. They are adorable. So we're going to have our robot call out to Bearcat facts, and when it gets a response, we are going to do nothing fancy, and we're just going to echo that response out to the chat room. We can do really fancy things. We can reply directly to the person by changing the send call to reply. We can append things to the response, so we can say, instead of just spitting out the Bearcat fact, we can say, hey, your fact is, and output that. We can do whatever we want to this response, and we can send whatever we want to the chat room. We could bomb the chat room with it if we really wanted to. So we can then run our bot. It takes a couple seconds to start up. Hop right into our testing room, which we have specifically allocated for people testing Hubot functionality. And send MechaSwift 2, which is the MechaSwift version running on my local machine, not on production. We can ask him for Bearcat facts. And he'll respond right away. So in addition to this, Hubot comes with some built-in functionality, which lets you do things like play Cards Against Humanity, which we have built in. You're all welcome to have a massive game of Cards Against Humanity in the Gitter chat. You can do seemingly useful things like assign roles to people in the chat. You can ask it to mustache you images. So if I say, MechaSwift mustache me Swift, that will apparently mustache Taylor Swift, which I guess is funny when you have internet, which apparently I don't. And it does all sorts of things. It's extremely customizable. It'll do basically whatever you tell it to. Yeah, that's Hubot. Feel free to contribute to our repository. We'd love for you to hack on it throughout the day. And enjoy. anyone has any questions about Hubot or MechaSwift or anything, feel free to ask them in the chat. I'm here for a little bit. I'm happy to answer them live, so go right ahead. I'm monitoring the local Hack Day room, so if you have questions, just ask them right there. Anyone? Questions?
He's still on. Okay, I guess there's no questions. Tell him, we'll be available.
I guess there are no questions, so if
I have some questions, jump in here.
Hi, Shai.
I'm excited for this. So, have you talked about our continuous deployment?
Yes.
People know that you can just push. Did you do that live, or?
People know that if they send us a pull request, we will merge it, and it'll go live the second we merge it.
Okay, so what are some cool things we can do with this Hubot right now?
You tell me.
All right, let's. How do we find out what kind of commands we can do?
So we can ask MechaSwift for help.
Okay, let's do that.
Let's see. We can.
Oh, and as a heads up, you can find this in. You can find this link at github.com/mlh, right? That's where
You can find it at github.com/mlh/MechaSwift.
Okay. So, all right, let's see what some of these things are. Pugs. Pugs sound amazing. Let's see what pugs look like.
For anyone who wants to follow along, we're doing this in the MechaSwift testing room, so we don't pollute the main room.
Yeah.
Just pug me.
Pug me. It's copyrighted. We can't do that. You've got to do it again. I
There
like
we
that
go.
one. That's cute.
That's better.
What about if you're a cat person?
Do we have cats enabled?
I
we
see
have cat
kitten
facts
me.
enabled. Okay, kidding me. There we go. That's adorable. So many of them. I kind of want more.
And then, I don't know, would Nick Quinlan be happy by this chat?
He might be, but we can make him happier. Maybe we can make him happier. Oh, it's just Loon. Maybe. So Quinlan's not going to be very happy about this. We can fix this for him though, and we'll be looking at that in a couple minutes. What else can we do? We can. What do you want to do, Shai?
Oh gosh, so is Bearcat Facts in here now, in this list?
Yeah.
We redo help?
Wait, we have a question in the chat room here.
Hey, we do. Do we have a question? What are some practical uses for Hubot? So, like I mentioned, GitHub uses this to grab statistics into their chat room from their production environment, so they can pull like average load times for their pages. They can pull user counts. They ship code to production from here, rather than having to push code with Git or whatever your deployment strategy is, Capistrano, FTP, whatever they're doing, and then notifying people manually in their chat room. They actually deploy inline from chat and make it nice and easy.
What if I was hungry?
You could use, I think Sam Agnew wrote a order in client for Hubot. So whatever your company, whoever you're working with, if you have a chat going, you can all order food inline in your chat room.
I think he just demoed that at New York Tech Meetup, actually. The video is probably online if you want to check it out.
Is it?
But also, like, if I wanted to monitor my deployment, or could I trigger a build, or?
Yeah, you can trigger a build the same way that you can trigger a deploy. Once you trigger the build can then talk back into your chat room and give it.
So it can pipe
give you
errors and
statuses.
stuff?
Yep. There are integrations that exist for. I think Bugsnag exists, and you can actually have it listen on a webhook for various notifications that come in and pop whatever you want into the room.
Mm-hmm. That's awesome.
Yeah.
So I think we're going to take a little break.
Skyping one of the schools.
And, or we're Skyping one of the schools. Okay.
But I'll take a second to set up.
All right. I'm excited for this. This is our first call of the day. You get to be here for this, Jason.
Awesome.
Hopefully they're all wearing hats, and I'm excited to see their hats.
If they're not wearing hats, we're going to hang up.
cost to be the boss. Paid the cost to be the boss. I paid the cost to be the boss. Look at me. You know what to see. See a bad mother. Look at me. You know what to see. See a bad mother. Paid the cost to be the boss. Paid the cost to be the boss. Look at me. Know what to see? See a bad mother. Huh. Huh. Told you so. Told you so. Having fun, got money fun. 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 'Cause paid the cost to be the boss. Paid the cost to be the boss. Paid the cost to be the boss. Cross the tracks, turned my back. Cross the tracks, turned my back. Paid the cost to be the boss. I'm a bad mother. Huh. I'm a bad mother. Head for the turnaround. Head for the turnaround.
on and stuff. We have stuff going on all day. But I'm so glad you came out. It's awesome. Yeah. Awesome.
Sure.
Yeah.
Hey, can you hear us?
Yeah, I can hear you.
Yeah.
What were we talking about?
So you're supposed to put a hat on. Give me your hat.
Oh yeah. It would be awesome if like high schools had.
Wow, your head is warm, Chad.
All high schools had that. They should. They should take away. They should take away U.S. history.
Hey, can you hear us?
Yeah, I can hear you.
You're live now. We fixed the audio.
Oh man, I'm nervous. How many people are watching? Do you know?
Well, theoretically, there's like 30 schools tuned in right now.
Oh, okay, cool.
There's 60 people. Like, so some of those are to this stream or the schools though. So
Awesome. Hold on. I have to greet people and stuff, so I'm gonna be in and out. Okay.
Okay, you're good. But like,
Yeah, 'cause
introduce
people
us to a
are
hacker.
coming in.
We want to hear about something somebody's working on.
Hey, how's it going?
Have bananas and fruit.
It's like fun over there.
Yeah, this is in the Pivotal office, right?
I think so.
Nice. It's a great office. Great place for a hackathon.
That person's like see-through. I think they forgot about us.
Hi, guys.
Hello. Okay.
This is,
Let's go back to you.
You gonna come back to us?
And then we have like
Okay, we're back to us. Well, so NYU forgot about us.
So I feel a little slighted.
I know, right? Well, yeah, I wanted to talk to some hackers and hear what they were working on.
I was excited.
There's a lot of people there, though. How many people do you think are in that room?
In the camera frame, probably 25.
Nice,
30.
not bad. NYU. So that's our first event that's Skyped in. We've ironed out the kinks on it. If you have an event that you want to Skype in from, let us know in the chat. We'd love to have you on the air. We'd love to interview some hackers about what they're building so that we have a good idea of some of the things that people are working on at Local Hack Day.
We'd also love to stare at baskets of fruit. We really like that.
Yeah, if you just want to have the stream from your event, we'll play that too. It's pretty cool. Cool, so that was an interesting talk about Hubot. It's a technology that you could use for Local Hack Day, and you could use it at Hackathon too, I guess, right? Like anybody can build like Hubot scripts in the wild, and now they know how to do it, right?
Yeah, and it's really easy to get started. It's just JavaScript under the hood.
Yeah, that's nice. I mean, it's always good when something has like a good JavaScript SDK to use. I always hate it when I'm like opening up a library and it's like, oh, C++, and I'm like, oh, sorry about that.
Oh, I need native threading, and wow, things got ugly fast.
Yep, no, exactly. So, what is your, what if you had 1 million hours to spend right now, you can just build whatever you want, what's the Hubot script that you would build?
I would probably build a Hubot script that takes pictures of you and juxtaposes Ryan Gosling on top of them.
Wait, you mean just photos of me? I am Ryan Gosling, right?
Well, yeah, there you go. But I want to prove that to the world.
So it would be great if so somebody, when I was at our EU summit, suggested that I should start applying for stunt double jobs for Ryan Gosling, and then I could have in my Twitter bio that I was like Ryan Gosling's stunt double.
Could be interesting.
I know, right? Well, that'd be a good job for me.
Could write a Hubot script to apply for those jobs.
Yeah, there you
Send
go.
the emails.
Let's see. If I had 1 million hours and I was going to build a Hubot script, what would I build? I would build a Hubot script that... Oh, you can make one that like pulled in random videos from Local Hack Day or something like that, right? Like you had a bunch of streams. You could be like, Hubot, like stream me like NYU, and then we can see what's going on at NYU. That'd be cool.
And then like even after Local Hack Day, you could have a Hubot script that pulls like a Hubot talk and streams it right to your team.
Oh, that could be interesting. You could also do like... if you had like remote offices, you could do a whole thing where like you could pull the stream from your office. Oh man, we should do that for MLH. That's cool.
Yeah.
Yeah, I'm getting all these crazy ideas now. Yeah, I think we're actually going to have an internal hackathon in January, so maybe that'll be a tool that we'll build.
That'll be exciting.
We can hack on Hubot. That's cool. What other technologies do you think are exciting that people should be looking at today?
So I think that first-time hackers should look into using Rails to get started on their projects. I'm giving a talk later today on Rails, so getting started, building a really simple application. It's a great prototyping framework and a great way to get started on most projects.
Interesting.
that's where I would look first.
All right, well, let's get into a little bit of philosophy here. Oh, NYU's back.
Hi, NYU.
Wait, they're back?
They're back. Bring us back to
Oh,
NYU.
yeah.
Hang on.
Hold on.
We can hear you. Give it a second. Are they on the stream? All right, you're on the stream again. Wait, introduce us to some hackers. We want to talk to some people and hear what they're making.
All right. Yeah. Sure. Hey, would you guys like to introduce yourselves to like some people on Skype, on like just what you're working on and stuff? Yes.
Hey, what's up, guys? How's it going? You're on the local Hack Day stream right now.
Hello.
So, introduce yourselves and tell us what you're working on.
My name is Simon. You know, my group Joe, Dan, Chris. So we're working on his idea to make an AR game using Unity, and like he actually has a lot of the models already. It's great.
Nice. What's the game like? Describe it for us.
Basically, what's gonna happen is like you're gonna be you take your phone or something, you're on the screen. There's a button that says shoot. You just push it, you shoot. It's kind of
Nice. Awesome. How did you guys come up with this idea?
His idea. Yeah. Yeah.
Nice. How do you guys know each other?
We actually just met. I knew him from high school.
Nice. That's awesome. What do you guys think about local Hack Day so far?
The event you're at today.
Yeah.
Nice. Cool. Well, good luck, guys. Happy hacking.
Thank you.
Yeah. Yeah. Also, this space is really awesome. Like, check this out.
Wow, that's a beautiful space.
Yeah, I mean, they have like so much. Like, are you kidding me? They have like pistachios.
Wow.
Right? That's crazy.
Dude, you guys got the life of luxury over there.
Is anyone...
Wait, take us by the drink cooler. I want to see what drinks are in there. Oh, damn.
Yeah.
Wait,
The beer cooler. Hopefully not too much of that.
They've always stocked their offices very well.
What office is this? Pivotal?
This is Pivotal, yeah.
Labs.
Nice.
Is anyone from Pivotal there?
Someone is. She's at the front.
Wait, let's go introduce her.
Give her a hat.
Give her a hat and put her on the live stream.
I think she already has a hat, but. Hey. Hi. How's it going? Okay. Hold on. Yeah. So that's right. That one. Feel free to fill in like whatever you want. Hack. You can hack. We have
The
like.
suspense is killing me here.
Yeah, we started a little bit earlier.
Yeah, I know. No.
Yeah.
Oh, hang on. Hold up. It's gonna be great.
Okay. Feel free to chill and
So
talk to us.
maybe I come back later for the demo.
That's 100.
Best stream ever.
Demos.
Get a nice view of the cooler.
Yeah. I mean, like, look at that drink cooler. It's amazing.
It's an awesome cooler.
Eight
It's
people
branded
said
too.
Is it?
Yeah, it says Pivotal right on the top.
Wow.
Okay, cool. Awesome.
With that beer.
Yeah, what's up?
Yep. Club soda, sparkling water.
Clear
all that.
liquids only.
Yes. All right.
Do you have any idea of like what you want to work
Okay. Wait. Nope. All right, we're going.
on? Okay, cool.
Cut back to us.
Yeah, I mean, do you have any?
You cut where?
Yeah, let's go just go.
All right, we'll cut back to us. We'll introduce you. Hey, all right. Well, we'll go back to the NYU stream in a little while and hear from Pivotal. In the meantime, we do have the introduction to Git Talk coming up in just a second. Remember, it is Randall's birthday. Be sure to tweet at him and say happy birthday to Randall.
Tweet him twice,
tweet
three
him twice,
times,
10
just
times.
keep tweeting at Randall.
Write a Hubot script that only tweets happy birthday to Randall.
There you go.
All right.
Send us a pull request. We'll have it live while he's talking.
Good. All right. Catch you soon. Happy hacking, everybody.
Hey guys, my name is Randall Hunt. I'm a developer evangelist over at Amazon Web Services. We are, of course, hiring, blah, 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 lots of stuff like that. I am very, very passionate about Git. I think it's one of the coolest pieces of technology that we work with in our day-to-day workflows. And to that end, I've created a small talk to walk you through the things about Git that I think are very, very cool. This is somewhat of an intro-level talk, but at the same time, it has a lot of miscellaneous ideas and features that might be useful for people who are more familiar with Git. So we'll see what you guys like. I'm talking into a camera and facing John, so I have no idea how many people there are, and I'm not going to be able to do any audience participation or anything, and I apologize for that.
We can do Q&A from the chat room if you want.
Q&A, all right. Well, I'm going to take the hat off for now so I can continue presenting without my head getting hot. Okay, so first of all, I'm going to ask the assembled room here, what is Git?
Version control.
Git is not revision control software. Git is a content addressable file system. Git is a content addressable file system that happens to have some version control features. So as we go through the rest of this talk, I want you to keep that in mind. Git isn't just version control. It's not even version control as a first level citizen. It's a file system with version control features. And I'm not trolling you, I promise. What is a file system? A file system is something that controls how data is stored and retrieved. And Git really just does that. It controls how data is stored and received. And it does this with a content addressable file system. And when I say content addressable file system, your probably eyes are glazing over and they're like, well, who the hell are you and why are you still talking to me? And well, I'm this guy. I probably know more about Git than you, but I always like to check, so just in case, 1 second here. Are any of you on this list? Okay, well, I'm the next name down, so all of these people know way more about Git than me, and probably all the people underneath me know way more about Git than me, but for the purposes of this talk, we'll just continue assuming I know the most. I work at AWS, I tweet at JR Hunt, please do not wish me happy birthday, it is not my birthday, it will never be my birthday, it's just this ongoing joke. I wrote Git Shots with this really, really stupid plugin and you don't need to look at it. And I write really fantastic commit messages. I'm world famous for these commit messages. I like ginger ale. I have 8 major patches that I've submitted to Git, and all 8 of those were rejected. So it's a pretty great background I have here. And a lot of you at this point are asking, okay, well, what is this 3-letter command that I keep hearing so much about? So Git is like magic. It's going to allow you to easily switch context between different branches that you're working on, different code execution paths, things like this. And you have these role-based code lines where you can have developed a master branch, or you can develop a development branch, and you can have different people working on these simultaneously. So if you have bug fixes that need to go out live immediately, it's very easy to push those. Whereas if you have development features that are more long-running, you can have those in their own branch where they're not going to be disturbed by constantly having to rebase and merge all of these bug fixes into them. The feature-based workflow is very important, and I'll get to that a little bit later, but that really enables you to do some amazing stuff in Git. And the other really amazing thing is the ability to experiment easily. When you lower the cost of experimentation to virtually nothing, then your ability to innovate increases dramatically. And enabling that innovation in your code base and within your team is vital for having an agile workflow or having a better development team that's able to adapt. The other very important part about Git is that it is distributed version control. If you worked with other systems in the past, things like CVS or SVN, those aren't distributed. You have a central repo that has the whole repo in its canonical form stored. Now, GitHub is a central repo for us, but the other thing to point out is that just because you check something out from GitHub doesn't mean somebody can't check out that same code from your laptop. So to demonstrate that, I have this picture. I can check out, where it says server computer, just imagine it says GitHub. So I can check out from GitHub the entire database, and then somebody on computer B, if we're on a plane and we don't have access to the internet, can just create an ad hoc network with me and read straight from my computer. Or I can check out from another place on my file system. The Git protocol doesn't really care what network you're using. It just wants to be able to access the repo. There are all kinds of different organization features. You can have lieutenants who review things and then send them up to the dictator who approves it. This is somewhat how the Python model works, and even though they don't use Git, they still use distributed version control. This is how the Linux kernel works. And this is how many patches get approved and very large software projects operate, open source software projects. The typical workflow is you have your working directory, and then you git add the files that you are interested in committing and interested in putting into a commit. And when you run git add, these files, they go into something called the index, or more commonly referred to as the staging area. And the reason there's a staging area is because you don't always want to add everything that you've changed in a single commit. Sometimes your brain works faster than what other people are going to be able to consume. So you'll set things out into separate commits so that they're logically consumable by humans. Version control only really exists for humans. If we were computers, we'd have perfect memory and we wouldn't need any of this mess. So keep that in mind. The reason you're doing version control isn't for yourself. It's for other humans. And it's not for the computer, it's for other humans. So you have this working directory, and you get add-p files, and the -p, by the way, is very, very important. Do not ever, and if I get nothing else across in this presentation, this is the one thing I want to get across. Do not ever type git add star under any circumstances, or git add dot. Those are the most dangerous things you can ever do, because recovering from that heinous error is very difficult. So if you have something that you want to add, you do git add -p, which initiates an interactive patch mode. And that patch mode will ask you to stage interactively each part of the file that you've changed. So then we've added these stages to the index, to the staging area, and now we want to actually commit these into the Git database. So we do git commit -m and then our message. Holla is not an appropriate commit message. You should write, there's a lot of different formats for commit messages. Every project has their own. Follow the project standard. The other thing that's very important, and I can't sort of be enthusiastic enough about this, Git saves you from yourself. Humans are stupid. We make tons of mistakes all the time. Git stops you from making those mistakes. So long as you commit early and commit often, you will be able to move back to any state of the code that you possibly had. So the life cycle, one more time before we move on, and I'm going to tell you how Git works and some cool stuff about Git, is you have your unchecked files, you add those unchecked files. You have your unmodified files, and you edit those. You add all of this in to the staging area, and then in order to get back to the unmodified state, you commit those files. And that is when everything is in the database, the Git database, and Git agrees that your working directory is clean. We're not going to do a demo just because time doesn't really permit it. So, we are going to do a demo?
Yeah, why not?
Okay. So is my screen still visible? Okay, so I've created this Git repo called test repo, and all I'm going to do is I'm going to run git init, and that's going to create an initial repo for me. Am I good? Okay, that's going to create an initial repo for me, and you'll see that all that's been created here is this .git directory. Very simple. It just has some hooks, some objects, and some refs, and I will explain more about that later. But now I need to create a file, so I'll say vim readme.md, and I'll say hello world, and then I've created that file and I've closed it, and now I'm just going to add that file, and then I will commit that file, and I'll write a detailed commit message that says added readme.md. And you'll see that's it. It's done. It works. And that's what Git does. So what actually happens when I do that, right? What actually happens when I commit something? So if we take a look at .git directory and we go and we look at objects, you'll see these 3 things that exist there. And if I go git hash object readme.md, you'll see that it starts with 2b. So I just want to say cat, well, I'll do git cat file .git objects, and then 2b, or not 2b. Guess that's not working. But instead,
I want to know what shell you're using.
This is ZSH, and this is my own theme from ZSH. It's called Randman. If you download Oh My ZSH, you can get that theme.
What's it called?
Randman. So, what we're going to do instead of trying to cat the file manually is we will go into Python and we'll import zlib. So all of these blobs are zlib compressed blobs, and I'll tell you a little bit more about that in a second. And I'm going to say f equals open. And you'll see this is the file, right? That blob that's been stored is the file. And the way that it's detailed is the first part of it says blob, the next part is the length of the content followed by a null byte, and then I have the actual content of the file, which is a hello world, a hashtag, and a new line. And that is all Git is. That's how Git works. It's just zlib compressed blobs, trees, and other objects. And I'll get back to my presentation now, which might make this a little bit clearer for you guys. But first of all, do your working branches. So, back when I was talking about a content addressable file system, what exactly does that mean? I gave you a brief demo of what that means a second ago, but to understand what it really means, you have to take a look at what Git itself is doing under the hood. And when you understand this, it's going to enable you to move things around in Git and to make operations in Git make a lot more sense. You'll grasp at a fundamental level what's happening when you run these higher level commands, and it will allow you to reason more about what you're doing. So here I have this C file, which is the refs.c, which is part of the Git source tree. And if you go git hash object refc, I get this SHA-1. What is a SHA-1? A SHA-1 is a hash, and I will explain slightly more about that in a moment, but a hash is essentially your address. The content that you have becomes the address by which you look up your content. It seems circular, doesn't it? So a SHA-1 is 160 bits of unique address space. And I say unique because it's mostly unique. You can generate collisions purposefully if you'd like, but the chances of a collision happening in real life are very, very slim. Now we're going to go through the math for what a SHA-1 is. I hope you guys are ready for this. Okay, so no, we're definitely not going to do that. I'm sorry. That's only one piece of it. The way you can think about a SHA-1 is this, right? You add data, you add more data, you mix it all around, and you get a magic number. Essentially, you have this bucket into which you're pouring data, and then when you're done pouring in data, you say, okay, bucket, I'm done, and the bucket gives you a magic number out. And if you do that exact same amount of data the next time, and the exact same order of that data the next time, you'll get the same number out. So, everything in Git is a SHA-1. Just keep that in mind. Every Git object that you know about is a SHA-1. So, branches are references to commits. Commits are pointers to trees. Trees are pointers to trees and blobs. So let's go through that one more time because it's important. Branches point to commits. Commits point to trees. And trees are pointers to other trees and blobs. And blobs are just zlib compressed files. So here's another example of that. You'll see the tree at the top is just the directory listing. Then you have the blobs, which are readme, rate file, everything like that. And then you have another tree and another blob. So I heard you like directed acyclic graphs, so I put some directed acyclic graphs in your directed acyclic graphs. So a DAG is a directed acyclic graph. And if you're a computer science nerd like me, you're probably pretty interested in that, and I encourage you to go look it up. But I'm not going to talk any more about it right now. This is the code in Ruby that would allow you to, roll your own Git. Basically, it would take the content of a file and it would SHA-1 hash that and then put it into the Git database. I mean, this is very simple stuff that's very, very fast to do, even for larger files. And it's the reason Git is such a different type of version control system than everything else that you've experienced. So a commit object, there are 4 object types. There's a commit, there's a tree, there's a blob, and there's a tag. Ignore tags because tags are useless. But commits, trees, and blobs are all very much interrelated since commits point to trees. And a commit has another piece of metadata, which is a pointer to n number of parents. So unlike humans, commits can have 10 parents, 20 parents, as many parents as you want, so long as it's a directed acyclic graph. The other thing that they have is the date, the author, and other metadata like that. Trees are pointed to by commits and have a tree only is allowed to exist in Git. The defining feature is that every leaf node of the tree must be a blob, which is why if you've ever tried to commit an empty directory in Git, it doesn't exist. And then blobs are just zlib compressed files. And the other thing that I should point out is all the commits, the trees, all of this is all zlib compressed. So zlib is a type of compression that uses run length encoding and Huffman codes for those of you guys who are total algorithm nerds like me. And it basically takes data that has common structures in it and reduces those structures into one character and only stores those long strings once rather than 50 times. And a lot of processors have instruction sets that will allow you to decompress those and compress those very, very quickly. zlib has been around for a long time, so people are pretty smart about how you can move this stuff around. If you're interested in it, you can just Google zlib and you'll get a lot of good information. The final thing to note is that Git is separated into 2 sets of commands. You have the porcelain. This is not a toilet, by the way. This is a metaphor. And then you have the plumbing commands. So the porcelain commands are the things that you're used to using: commit, branch, log, diff, add, etc. The plumbing commands are things that you probably don't ever see, which are hash object, cat file, list tree, and unpack and pack. These are the things that bind Git together. They bind the universe together. The plumbing keeps everything running, even if it's sometimes done with duct tape. All of the commands that you're used to using in Git, which would be commit and things like that, these all rely on these underlying commands, these plumbing commands. So if you ever truly wanted to understand Git, you should check out the plumbing commands. And if you don't think that's cool, then I don't know what else to tell you. Because when I learned this and saw how beautifully designed it all was, this is my face when I finally learned all of this. So if you guys have questions, I have, I get answers, but otherwise, I just want to show you one last thing that you should do in your Git workflow, which is TIG, which is an incurses, which is a command line front end for Git. So with git log, you can go through and you can look through all of the commits with -g. You can do a regex search. And I froze my computer, I'm sorry. But then I can pipe that into TIG, and TIG will give me a front end for browsing all of that information without ever leaving the terminal. So I really suggest you check out TIG, and that's all. That's all I have to say.
So the first question is, why is git add star a bad idea? Like, what does it actually do?
So git add star will go through, and it's relying on the shell, which everybody uses a different shell, and you're not sure it's going to be the same behavior all the time. It's going to use the shell to add every file in that directory and every directory in that directory to your project. So if you're using a Node project, for instance, and you do git add star, and you don't have a correctly set up .gitignore, what it's going to do is it's going to go in and add those node modules into your repo. So now when you push things over the network, every single person is having to grab those node modules every single time. And that's a lot of excess that's not needed, because that same stuff is always available through npm install or something like that. It's the same thing with Java and committing your build artifacts.
And the last question is, why should someone use Git rather than like a traditional like version control like SVN or CVS?
For the reasons that I stated in the beginning around distributed version control, there's a really funny anecdote told by BuzzFeed. Back during Hurricane Sandy, their entire website went down as the data center flooded. And the only reason they were able to bring back a working version of this, because their code repo was hosted in that same data center, is because they had recently switched from Subversion to Git. And so by using Git, every single person who was a developer had a recent copy of the data, had a recent copy of the working code. And they were able to push and pull from each other rather than having to rely on some central repo. That's just one of the benefits of Git. The other benefits are performance and easy experimentation. SVN doesn't enable these things.
Awesome. Any other final thoughts there?
I hope you guys check out Git, and if you have any questions, you can shoot me an email, randhunt@Amazon. Sorry, let me put this up really fast. You can shoot me an email there, and that's it.
Awesome. You are off.
I'm back. I'm back. I'm back. I'm back. I'm back. Get up off of that thing and dance to you better. Get up off of that thing and dance. you. Sing it now. Get up off of that thing and make you feel better. Get up off of that thing. Try to release that pressure. Ha. So on me. So good. Ohio players. Get into the sunshine. Check this out. Get up off of that thing.
So hi everyone, my name is Bonnie Eisenman. I'm a software engineer at Code Academy. And today I'm going to do a quick intro to Arduino workshop for you. Arduino is a great way to get into hardware hacking, so if you're at a hackathon, this is a great place to start. So real quick, I'm just going to go through why you should be using Arduino, what makes it awesome, what you can do with it, and then how to get started and how to do your own projects. You can also see I've got a link to this presentation if you want to refer to the links here later. So yeah, let's start with what the heck is an Arduino. I know it's a funny name and a lot of people who've never used it before look at me kind of funny when I mention it. So the important thing is basically that it's a family of microcontrollers or mini computers, however you want to think about them. You can program them and you can use them to interact with the real world. They have input and output, which is very useful if you want to do hardware hacks. So the reason why you should be using it, it's an easy way to get started with hardware. It's open source, which is useful because it means that you actually have access to resources. There's a really big community around it. There's a ton of libraries and tutorials, and the community has made, I think, a real effort to be very beginner friendly. It's very mature at this point. I'm not sure exactly how long it's been around, but long enough that most electronic suppliers now, you can find them, and you can find a ton of great how to get started guides. It's also relatively moderately priced. An official Arduino board will go for $30. To get started, you'll need about $50 worth of supplies to really get started making your first project. Of course, that's if you buy from official suppliers. As I'll discuss later, there are other options to bring the prices down. So it's also worth discussing, I think, why you shouldn't use it. It's not, just because you want to do a hardware hack does not mean that this is the solution. It's, like I said, it's moderately priced, but that doesn't mean that it's always going to be economically feasible. There are alternatives. You can buy much simpler microcontrollers for like the $2 range instead of the $30 range, which is nice. It's not the easiest to connect it to a Wi-Fi or Bluetooth network. You can do it. It's totally feasible. If you're doing it at a hackathon, it means you're going to spend extra time getting that set up, hoping that plays nicely with your host location's Wi-Fi network, all that stuff. If you desperately need reliable networking fast, I would recommend the Raspberry Pi, which is a lot more like a normal computer, just in a smaller footprint. This is one of my personal opinions, and I'm sure some people will disagree with me, but the Arduino language is really not my favorite. And I think for beginners, it can be a little bit difficult because on the surface, it appears pretty standard. It looks a lot, like Java, and then it starts throwing C++ compiler errors at you. You can include Java libraries sometimes, sometimes not. It's like processing most of the time, sometimes not, and it's not the easiest thing to Google. So expect to run into a few difficulties with that. I don't think that that's actually a huge problem when it comes to the platform, but it's something worth keeping in mind. So I want to talk a little bit about some example projects, like things that you can definitely do at a hackathon, right? Or on your own time afterwards. So one thing is you see it used in like wearables, so-called wearable technology, or soft circuits, which is basically stitching electronics into clothing and things, which is pretty neat. I've got an image there of the turn signal bike jacket, which has switches in the sleeves so that you can light up the turn signals on your back, which is pretty cool. You can also use it for home automation, whether that's proximity-controlled door locks, Twitter-controlled coffee pots, or coffee bots. I guess either of those is fine. I've built a lot of electronic musical instruments with Arduino. I've built a robot before at a hackathon with Arduino. If you really wanted, I guess you could use it for a quadcopter. Most hardware hacks basically are pretty feasible. So This is an example of one of the things I built at a hackathon. Do we have sound?
From your computer?
Yeah.
No.
Okay. Let's see. Now?
What's the video?
Hack Prince and Piano Stairs.
Your laptop? Do you want me to play it?
Yeah.
We're going to be editing all this afterwards.
What?
So we're going to be editing all of this
Okay,
afterwards.
cool. For those of you watching the live stream, this is a reason to cover things ahead of time.
Cool.
Okay.
Back to you.
Cool. So yeah, that was a simple thing that I threw together with a couple of friends. I think there were 3 of us all told. We decided to take the Hack Princeton title of the hackathon literally and hack the staircase. And all that is 6 light sensors, an Arduino Uno, and some flashlights. It's really one of the most basic circuits you can imagine, but it works really well. And I think that's really the interesting power of Arduino. I'm going to talk soon a little bit about the different inputs and outputs you can have, but basically when you're trying to think of interesting things to do, because it makes so many things simple for you, you're basically just constrained with how you can imagine putting them together, which I think opens up the room for a lot of really fun stuff. So I have a couple links up here for inspiration. I think that if you're just getting started with the platform, it's really useful to sort of look around, see what's out there, see what other people are doing, and then jump from that into realizing what else you can probably do. And a lot of the different blogs that cover Arduino hacks and things like that are really happy to feature you too. So it's a good idea to sort of read them, browse them, get a sense for what kind of stuff they post. And then after your hackathon, I would really encourage you actually to contact their tips lines and talk about your awesome hack. Not just because it's great to have people go, oh, that's cool, but also because you'll get a lot of feedback about what you can be doing smarter or better or differently with Arduino, which is really fun. So I want to talk a little bit about where you can buy things. A lot of hackathons will let you buy things ahead of time and expense them if they've got hardware support, whereas others will just have like kit for you to play with and you just arrive and pick from what's available. But if you want to pursue your own personal projects also, it's really good to think about suppliers. So Adafruit and SparkFun are my favorite US-based suppliers for things with really good documentation, fast shipping. Adafruit is New York-based and they're really awesome. They produce excellent tutorials. Mouser is another option. It's much less user-friendly, but it's a great place to buy things in bulk. So I've used them before. And then, of course, you have your unreliable, or less reliable, I guess I should say, but much, much cheaper suppliers from China and Hong Kong. So I've done that before, and I mentioned before that if you're buying official Arduino boards, they can run you around $30. You'll find knockoffs in the $2 to $3 range if you're buying from Hong Kong. Of course, then you run into the issue of you're not supporting the Arduino Foundation. So if at all possible, and if you have funding, I would encourage you to actually buy the official boards. But it's good to know that there are alternatives out there if you need them. This is also a good way to buy cheap Wi-Fi and Bluetooth chips. They're usually, again, like a tenth of the price that you might see elsewhere. Sometimes like 25% of the price, so good to keep in mind. It's a good thing to think about also where you can go for help, to talk to other people. The Arduino forums are great, the Adafruit forums are great. If you're in a community where there are other people working on this stuff, check out your local makerspaces, your local hackathon communities, and you'll usually find that people are pretty eager to talk to you and help you through things. So now I want to sort of talk about common parts that you can get, and this is sort of where the fun opens up, because there's so many different things that you can plug into Arduino. So inputs, right? Touch sensing is probably the easiest because all you need is a wire and some basic components and some tinfoil maybe. And you can do a lot of variation on that. You can do light sensing. One light sensor costs about $1. You can have switches, buttons, dials, knobs. You can have flex sensors. You can have heat sensors, microphones. Like there's so much stuff here. And this is why I said before, you're really limited by how you can figure out to combine this. As far as outputs go, a lot of people use LEDs because they look cool and they're like a very easy way to like visualize whatever you want to do. I also do a lot with music. A lot of the time I'll actually do the music generation on my laptop instead of on the Arduino, but the Arduino can make music itself as well. It's a little more complicated programming wise. You can do motion with motors, you can do network communication, you can control an electrical outlet. So there's a lot of stuff. And if you think about combining these, right, so to use my piano as an example, I basically took 6 light sensors, and then the output was piped through my computer using just, serial communication to make music, right? So that's just one input, one output. The thing for you to figure out is how you want to handle that interface. Or like another project I've done, we made a 6-legged robot for a hackathon. Why not? It was controlled by Twitch TV. So you've got your input in this case is basically a chat room on the internet, which goes over Wi-Fi to an Arduino chip, which then controls the servos. So again, that's just one input, one output. You can obviously combine stuff to do a lot more complicated things, and that's really fun too. I would definitely encourage you when you're experimenting to focus on getting the individual parts to work first, just to make sure it's feasible, because sometimes you might think you can mash up a bunch of stuff, but it's better to start simple and build from there. So I mentioned networking. There's been a lot of development in this over the last year, actually, in terms of things getting much, much cheaper, which is exciting. So serial communication via USB is like pretty easy. You can get that working like easily. That's not a problem. Bluetooth has gotten a lot cheaper. I buy my Bluetooth boards for about, I think, $250 each. So that works too. Wi-Fi is really confusing on Arduino, and I think that's a little unfortunate. There's the Electric Imp kit, which is actually really great to use, but unfortunately a little pricey. There's the XBs, even pricier. You can buy simpler Wi-Fi chips, which are very cheap and very hard to use. So there's a lot out there. If you want to do a hackathon project involving Wi-Fi, make sure that you budget enough time to get everything working. When I mentioned UltraSonic, I said I'm mostly kidding, except me and a friend did get that working. So that was fun. It has very low throughput, so I think like 1 character per second. But I would not recommend that, but it can be entertaining. So feel free to think of like weird ways to communicate between Arduinos and whatever else you need. But in general, USB is going to be the most reliable, followed by Bluetooth, followed by Wi-Fi in terms of feasibility. I also want to briefly mention that soft circuits and wearables are a thing. They're really fun. If you want to do a thing like this, you need to buy slightly different materials. You're going to want conductive thread. You're going to want the round washable incarnations of the Arduino. Batteries are not washable, so make sure that you can remove them if you actually intend to use this. I mentioned bare paint because it's actually conductive paint that's probably skin safe. They used to advertise it as such and they've stopped, so but yeah, so it can be really fun to integrate electronics in unconventional ways. So like one thing I'm building right now, for example, is a wooden jigsaw puzzle where the circuitry is all painted and it lights up when you finish it, right? So you can do strange interfaces if you think outside of the normal idea of hardware as like wires and rough edge chips and things like that. So to plan a project, count your pins. An Arduino Uno only has 6 analog pins, and that's what you use for things like light sensors, so just keep in mind like your limits. And don't worry about optimizing things, at least at first. Arduinos are great for prototyping, so you don't have to get super fancy. So now I want to talk a little bit about how to actually get started programming and what this consists of. If you want to be able to do anything with Arduino and look up stuff and understand tutorials, you're going to be really helped if you have a basic understanding of electronic circuit diagrams. It really doesn't have to be a lot. Like, we're talking maybe the first 2 weeks of a physics class. Know your symbols, know what the diagrams are actually trying to tell you. In this case, I've highlighted the ones that I think are really important when you're trying to read these tutorials, because you're going to encounter them very often. Also, please don't create a circuit with no resistance and no resistors. I know a lot of people forget to buy resistors when they get started, but that will actually kill the things you just bought. Don't do that. Breadboard's also a thing you'll need. I've tossed this stuff in this presentation because it's meant to be a reference and just like a quick index of stuff that you might need later. So again, a breadboard diagram just shows you the layout. Resistors, these are the things that not only will stop you from frying your boards, but are very important for different circuits you might build. So this is the Hello World equivalent for Arduino, and I've linked to it here just because you should know that the Arduino website has a ton of really great tutorials for getting started. You can tell that they both have the visual version, which is, actually shows you what it'll look like vaguely in real life, as well as the schematic. And it's really useful if you're able to learn how to translate between those and to know how to take the schematic and make it real. In this case, you just need a resistor, an LED, and then to connect it up. So that is the equivalent of Hello World, and you start with this. And then from there, you can move to more complicated things. You can see this is a marginally more complicated circuit. Again, they give you the visuals, which is, great. You can get started like that. And so, again, to use my piano stays as the example, all that was this times 6, which, again, works out pretty well. So I've linked here to the Adafruit tutorial. Again, I'm a huge fan of their work, and they've done a lot to sort of make this easy to approach and easy to mix and match and combine different functionality. So there's that. If you really want to get fancy, Arduino does have support for interrupts. If you don't know what interrupts are, this probably will not interest you, but I wanted to throw it out there because a lot of people don't realize it. But anyway, so thank you. I'm glad you all were listening, and I hope that this was kind of helpful. If you have any questions about Arduino, again, you can ask me on Twitter or make use of your local communities, because there's a lot of awesome people out there.
We have a couple questions in the chat too.
Sure.
So someone wants to know what the differences are between like all of these Arduino-like things, like SparkCore, Tessel, or Raspberry Pi, or Edison.
Sure. So there's a couple different things, right? The Raspberry Pi, for instance, is really more of an actual computer. It doesn't deal with physical interactions quite as well, even though it can. Whereas within the Arduino family, it's sort of a description of a family of things that behave similarly. So there's actually, the difference tends to be things like form factor, price, number of inputs and outputs. With the SparkCore, it's about being able to use Wi-Fi easily. That's the idea anyway. I've had issues with them in the past, but sometimes they work great. Yeah, so it can be hard to know where to start. I recommend the Uno as like the most basic starting block.
And then another question about using an LED straight on an Arduino and killing the board. I don't know if that was a question or a comment, but someone says, you must have a current limiting resistor or you will kill the board.
You're more likely to kill the LED than the board because the Arduino does have some regulators on it, but yes, you should always have resistors like I mentioned.
What are some resources for learning basic electronics?
I think that if you're looking to get into hardware hacking, I'd actually recommend against trying to learn basic electronics like as an individual topic. I think it's really effective to take a project-based approach similar to how you might teach yourself programming, which is that you figure out something you want to do and then you figure out how to do it. At least for a lot of this kind of stuff, it's now become so simple that you really don't need to know how, you don't need to know all that much. I mean, there's a lot of really good Coursera electronic engineering courses if you are interested in it though. And eventually you will want to learn how to make your own PCBs. That's like the biggest skill that I think is useful.
Cool. Any closing thoughts?
I think I'm good. I'm excited to see some hardware hacks.
Awesome. Thank you.
Thanks.
such a bad hair day, dude. We're not live yet.
Feel bad.
We're not,
Yo,
we're
come
live.
Come here.
We're not live yet.
Just grabbing all of them so we look not alone.
Not yet.
Also, like,
What's her 45?
Yeah, he's within us. We'll Skype with them and he's up there. No, not even. Tell him 5 minutes.
5
All right, you guys ready?
yeah.
Okay. We're live now? We're live. Hey, how's it going, guys?
In Canada?
So right now we have the hackers up at McGill Skyping in with us. You guys want to tell us what's going on there?
We have a lot of new people today, so we are focusing on like basic web dev, basic Git, and basic Android. We're really looking forward to the Android.
Nice. Well, Android's up next. Kevin will be setting up in a few minutes here. What are some things you guys are hacking on? Anybody building anything cool?
Yeah! Strong Android here.
Nice.
What are you doing on Android?
What?
What are you guys building on Android? Nice.
It's awesome.
Where are all your hats? I feel like it's cold up there. You all need hats.
We have an excess of hats.
You gotta go put hats on them right now.
Yeah, I'll just go without hats. So,
Can we see out the window?
yeah, let's do that.
Oh, the tundra.
The Thunder!
Wow, it's so snowy.
Montreal, that's like downtownish area. I don't know how that's not really downtown. Yeah, it's really, really foggy today. I don't know why, but there's snow.
Where are you guys? Where are you right now? You in a McGill building?
We're at the computer science building at McGill.
Nice. Is that where the hackathon was?
It was in a different building, but it was on campus, yeah.
Okay, cool. Awesome. Well,
From
you guys have some fun over there. Cool.
Cool.
All right, guys. Good chatting with you.
Chatting with you, yeah.
Happy hacking, everybody.
Bye.
Great.
More. Can we go thrift shopping?
What?
Oh!
awesome. Now, walk into the club like, what up? I got a big. I'm just pumped. I bought some from a thrift shop. Ice on the fringe is so damn frosty. The people like, damn, that's a cold ass honky. Rolling in hella deep, headed to the mezzanine. Dressed in all pink, set my gator shoes. Those are green, draped in a leopard mink. Girl standing next to me. Probably should've washed this. Smells like R. Kelly sheets. But it was 99 cents. Copping it, washing it. About to go and get some compliments. Passing up on those moccasins. Someone else has been walking in. Bummy and grungy fucking man. I am stunting and flossing and saving my money. And I'm hella happy that's a bargain. I'ma take your grandpa style. I'ma take your grandpa style. No, for real. Ask your grandpa, can I have his hand-me-down? Velour jumpsuit and some house slippers. Dookie brown leather jacket that I found. Dig it. They had a broken keyboard. I bought a broken keyboard. I bought a ski blanket. Then I bought a kneeboard. Hello, hello, my ace man, my mellow. John Wayne ain't got nothing on my fringe game, hell no. I could take some pro wings, make them cool, sell those. The sneakerheads will be like, he got the Velcro. I'm gonna pop some tags, only got $20 in my pocket. I'm hunting, looking for a come up. This is f***ing awesome. I'm gonna pop some tags, only got $20 in my pocket. I'm hunting, looking for a come up. This is f***ing awesome. What she know about rocking the wolf on your noggin? What she knowin' about wearing a fur fox skin? I'm digging, I'm searching right through that luggage. One man's trash, that's another man's come up. Thank your granddad for donating that plaid button up shirt. Cause right now I'm up in her stuntin'. I'm at the Goodwill, you can find me in the I'm not stuck on searching in the section. Your grandma, your auntie, your mama, your mammy. I'll take those flannel zebra jammies secondhand and rock that. Whoa. The built-in onesie with the socks on them. Whoa. I hit the party and they stop in that. Whoa. They be like, oh, that Gucci, that's hella tight. I'm like, yo, that's $50 for a t-shirt. Limited edition, let's do some simple edition. $50 for a t-shirt, that's just some ignorant. I call that getting swindled and pimped. I call that getting tricked by business. That shirt's hella dope. And having the same one as 6 other people in this club is a hella don't. Peep gang, come take a look through my telescope. Tryna get girls from a brand, man, you hella won't. Man, you hella won't.
Goodwill. Poppin' tags. Yeah.
I'm gonna pop some tags. Only got $20 in my pocket. I'm hunting, looking for a come up. This is f***ing awesome. I'll wear your granddad's clothes. I look incredible. I'm in this big air coat from that thrift shop down the road. I'll wear your granddad's clothes. Damn right. I look incredible. Hey, come on, man. I'm in this big air coat from that thrift shop down the road. I'm gonna pop some tags. Only got $20 in my pocket. I'm hunting, looking for a come up. This is f***ing awesome.
Is that your grandma's coat?
Yeah, this is what I was talking about, like when I'm not actually talking about. Anyway, hi. This is gonna be a talk about getting started with Android. I'm Kevin Galligan. You should listen to me. I learned to code when I was 7, and I'm way older than 7 now. I've been doing Android since 2008, which they actually had before the phones came out, and Java basically forever. I am president of Touch Lab. We're an Android consulting company. We're gonna have 8 apps featured this year, which I didn't know until last week, and I didn't realize. We run the big meetup in New York for Android. We just ran Android Con, so I know something about Android. I guess that's my intro. Okay, this is what Android is. I didn't know exactly where to start, so I'm starting super, super basic and expand out. It's obviously a mobile OS. I mean, it's just basically a flavor of Linux. With some UI frameworks thrown on top and different modules that make it obviously usable for a mobile environment, but also usable for TVs now. You can use it for the wearable stuff. We'll see how that pans out. It runs glass. You apparently can put it in a car, although I don't know if that's actually going to happen. Stuff like that. People are making desktops with it. I don't know if I'd recommend that, but you can. And then I guess that's it. So Android is that. It's an OS with a bunch of services on top. It's fun, but can be fairly complicated, mostly because of the rate of change in the environment. So, so I'm going to start with parts of an app. This is sort of, the assumptions here are you know Java and you can code in Java. If you can't, you're going to have a pretty hard time with Android. So you should start there, assuming you can code in Java. Every application is made up of an application package, which is distributed to the phones or whatever you're working with. Inside there, the most critical thing is the manifest. I don't know if you can just have a manifest and nothing else. That'd be an interesting thing to try. The manifest tells the system what is in your app. And the basic building blocks is an activity. An activity is like the most important thing you need to understand in Android. It's the thing that you can show stuff with on the screen. And inside the activity is your UI. It's roughly equivalent to a window, but don't get too caught up with that. There's an intent. An intent is how you communicate between your screens and your app, between your app and the system, between services, across processes, everything. Get very comfortable with what an intent is. It's essentially a message that can be persisted. So you put a bunch of data in there, and then if the phone goes to sleep and wakes up, and it still has it. Long story short, I won't get too into it. Blah, blah, blah. Then there's a service, which is the thing that runs in the background. We're not going to talk about that at all today because we don't have time. There's a broadcast receiver, which passes messages back and forth between the system and your app, and inside your app, and yada, yada, yada. Don't really have time for that. There's content provider, which lets you look at data across process boundaries. So you can go in and query contacts on the phone. You can query a bunch of other stuff. Content providers are useful for that. There's a side note, which is people recommend you write content providers for all your data. I would not recommend that, but like many things in Android, there is a lot of disagreement in the community, so I've had plenty of pretty serious arguments about that. So do whatever you feel like. Then there's a fragment. I put it in quotes because a fragment is like a modular representation of what an activity is kind of doing. The idea that came about when there were tablets coming out. So Google decided that you can have one application and then have the UI broken up. So they kind of coded a fragment to have the same life cycle as an activity, but be modular. So that sounds great, but it also is really complicated and way beyond the scope of today. So we're not going to talk about that. And I don't always use them anyway. So there you go. Also, that's a little bit of heresy, as with the content providers. Not all that much agreement out there on that. So, building screens. To make a basic screen, you create an activity. You create essentially your view, and you create your XML view definition, and then you register it with your application and put it in your manifest. Do we actually, if I just bring up code, we'll be able to see that?
Yeah,
cool.
Might have to increase the font size a little bit.
Oh, yeah. Okay, let me do this really quick while I talk. See if I can do two things at once. So you create your activity. Activity is going to extend the activity class, oddly enough. Oops, what are we doing here? Okay. And then you register that with, so here we go, activity, and you create extends activity. Seems pretty straightforward. Why did you do that? And then in your manifest, you just put it in there and you define this. Again, I can't get into too much detail because it's going to take forever. But you put this in here, and then there's some little extra stuff in here that tells it that it's going to be the thing that starts when you load your application, right? So that's how you do it. The XML layout, just to give you a feel for it, is you have a layout container, you got an image view, you got a button, you got a text view, you got a button. There's just components you put in there, and they get rendered on the screen when you actually run the application. So to give you a preview, starting earlier before we're actually getting there in the demo. Hold on a second. Okay, so you hit play. Here you go. Does some magic stuff like load image, and that'll go out to the network and do something. and you can load text from the network, and that'll show it. Although that's a bug, and I didn't finish that in time. Maybe we'll fix that during the demo. Okay, that's basically it. You create an activity, you create a view, and you put your view in the activities window, and then you interact with it by doing things that are probably beyond the scope of this talk. So, okay, what is an activity? Pork screen component, lifecycle overview, which is a note to me, not really what it is, but just to point that out there. Lifecycle overview, basically the activity has, it's one of the most obnoxious things in Android, and you're gonna have to get really used to it, is the Android lifecycle, activity lifecycle. You just have to get used to this chart. I mean, it shows up as a thing, as a search result, because that's how much people get freaked out by it. It's complicated, and it all has to do with the fact that the system has to maintain this thing when it's running, when it's in the background, when a call comes in. If you run out of memory, it has to shut it down, but it has to keep replaced. This isn't even close to the actual full set of methods in there. What you need to know is on create and on destroy is when the thing is birthed and actually completely killed. On start, on stop, kind of not so much. On resume and on pause is when it's actually running and when it's not. And if you learn those things, that's great. And then the rest of it you'll have to learn at some point. But anyway, but just remember that. I mean, you'll forget it, but then remember it later when you see it. Okay, so yeah, I kind of already explained this. You just set the content view, you put up triggers listening to button clicks, whatever you're gonna do, and then that's how you interact with your app. The view hierarchy, all the windows, everything that you see that isn't completely custom coded by you is built with this view hierarchy, and they all extend the base class view. That includes, buttons, text lists, scroll views, everything extends view. Everything that is done with everything that's laid out with the XML files that you saw briefly, and we'll go back to in a second, is a view group, which is basically a parent container. So you should get used to linear layout and relative layout. Even though I don't really like relative layout, I would say just start with linear, but you're gonna see relative all over the place. Again, a lot of disagreement on that, but relative's complicated. That's why I don't like it. So you have to make sure you understand it. Linear is very simple. It's just put it vertically, put it horizontally, that kind of thing. Just so, yeah, parent, everything inside there is a view. Again, with our code, you can see linear layout, orientation is vertical, and then we have an image view, and a button, and a text view, and a button. That's basically it. It gets obviously significantly more complicated than that. That's it. So there are other things that you should get very familiar with because you're going to need them. Collection views, like list view, but that's way, list view, but that's way beyond discussion for today. And then everything, all buttons basically have on click. So if you're kind of messing around and hacking and learning, you basically get this, we have this go button, which points to this, and you have an on click, and then you can do stuff. So for this example, here's our activity on create. Again, this is when the activity gets birthed. You have to call super on create. It'll blow up if you don't, so don't worry about it. You'll know it. Set content view sets that XML, which actually under the hood inflates that whole thing into actual components. Find view by ID is how you find stuff. Got the go button set on click, and then that loads image. Load image gets the image view, which is this, that guy, and then just loads it with Picasso, which is one of the wonderful libraries I'll put links to, and you should find out about. Anyway, I think that's about as well as I can explain the UI. Where are we time-wise?
We're about 10 minutes in.
What's that?
10 minutes in.
Okay, cool. So, quick discussion, just wanted to throw this out there. You can do code-based view creation. You can do your whole thing in code. And sometimes developers are really code preference heavy. I wouldn't do that. All the tools are very much based on the XML definitions. So I've dealt with a lot of different people, a lot of new developers over the years. Sometimes they're just going to do whatever they want to do, but it's going to be a much harder road and definitely less readable. But just throwing that out there. But you will occasionally need to do pretty heavy, like, code-based view manipulation, so you should learn it, but I wouldn't start there. Okay, so I feel like doing our big survey of Android, there's no way to get into mobile. The hardest thing to learn about mobile, if you are coming from any other background, I think is threading, which gets also the least attention. So I just wanted to explain this as best I can in the time. Threading is critical to Android. It's critical to all mobile too, like same thing in iOS. Like if you don't really understand what's happening, you're gonna have a really, really bad problem. In web, there really is no multi-threading. I know that if you look at like Ajax calls, it's a way of thinking that it's multi-threading, but it's not really, because there's no point at which you're managing state outside of a single thread context. So when you're on the client, you make a call, that goes to the server. The server usually is one thread context, and you're not managing state there, even though there's multiple threads running, but you're just doing one, and it comes back. And even though it's asynchronous, it's still like not two things happening at the same time, except for web workers, but nobody uses them. So yeah, you need to understand this, and it's something that people underestimate how bad you can make things. If we had a whole day, I would go through my rules for how to do threading, but we don't. So, so anyway, most standard Android, there's one big thread that runs throughout the entire system. It's not quite that simple, but as far as you're concerned, it is. There's one thread called the main thread, often called the UI thread. That's because everything that happens in Android, including the UI, happens in that thread. Everything that's long running needs to happen in a different thread. Long running being defined by longer than 5 seconds, or your system will get a pop-up that says your app's not responding. But don't think like, okay, if I only take 4 seconds in the main thread, I'm cool. Like you shouldn't take anywhere near that because your app is not responding while it's happening. So the basic rules are don't read and write disk data on the main thread. There are some subtle exceptions you can make to that, but basically don't do that. Don't do network calls in the main thread, and you can't anymore. You used to be able to, I think, gingerbread and below. Just don't. And then don't touch the UI from a background thread, and a lot of other things. You can't, if you're loading data from disk, it would be much easier to just say, hey, I want to push this into a text view from that context, but you totally can't. And actually, I can't get into it, but like I have a long explanation of why there's a main thread and the design of a system and like why you need that, but like again, that's going to take all day. So you can't do that, but don't worry, you'll know because your app will blow up. So that's the basics of threading. I'm going to have some libraries that will be coming along in our test project that you can download if you want to play with it, with some examples of that, but they're super basic. It's just something you're going to have to read into. There's no shortcut to avoiding that, I think. Okay, the state of Android. It's interesting. If you're an iOS developer, there's like Xcode, and then there are libraries that Apple has, and then there's definitely some stuff out there, but it seems like there's a general consensus of what you should do. Android is not like that at all. One of the guys I linked into here, Mark Murphy, has a great book that he continually maintains, and he's a great member of the community. He kind of told me privately about a year ago, he's like, he's getting out of training for a little while because there are now 2 different IDEs and 2 completely different like schools of thought, and then a ton of APIs and a new version coming out and all this stuff. And he's like, training now is actually hard because there's like, it's kind of all over the place. So there are 2 IDEs. There was Eclipse, that Google had standardized on, and all of their examples were for Eclipse. And then a vocal minority used IntelliJ, but it didn't matter. There was this old project structure that the folders were laid out a certain way, yada yada. And now we have Android Studio, which is just about to get into the first 1.0 version release with a completely different build system and a completely different folder structure. So you're in a state of some projects are the old thing, some projects are the new thing, some examples are the old thing, some are the new thing. Some people refuse to leave Eclipse. very vocally refuse to leave Eclipse. Half of Android like standard examples are old, half are new. So you have to be aware of that. I'm making it sound more dire than it is, but then again, I'm thinking if you've never seen this stuff, it probably is kind of freaky. I've been doing this for a very long time, so I'm totally used to it. Many different libraries and many different opinions about which ones you should use. So if I told you our best practice stack, and I will in a minute, you'll find people who very vocally disagree with that. So you're going to kind of have to make your own decision.
Okay. You are. Can you go over that part just a second?
Okay. Not sure we dropped, but your stack.
5 seconds ago.
Okay, so we're gonna give you a stack today. You gotta get Android Studio. We have a link in there. Download Android Studio. I think it has an SDK packaged in the download, but basically follow the instructions. They can tell you how to start that. Those instructions are pretty good. Prepare for Google's documentation to be inconsistent. So just throwing that out there. Studio they got. Some of the other stuff is a little bit whatever. You're gonna need something to run your project on. The standard Android emulator has been terrible, has always been terrible. It's still terrible. So if you don't have, we usually develop directly on devices. So you plug in with USB, push the application there. I develop on my personal phone for better or worse. There is something called Genymotion, which uses something called VirtualBox to have a really fast emulator, which is good, but Google doesn't let them put Google stuff on there, so you need to sideload it. I'll leave that up to you. Then Square. Square outside of Google is the shop. So Square, the credit card thing. There are two things that they have a bunch of stuff. But we're going to talk about Picasso, which is an image loading library, which we're starting to use for pretty much everything now, and Retrofit, which is a networking library, which we're also mostly using everywhere. Then there's something called Green Robot, which has an event bus, which if you don't really understand threading at a deep level, it's kind of hard to explain why you need that. But essentially, when you do stuff in the background, you need to throw it back over the threading wall to the main thread, and Event Bus makes that very easy. There are 20 different ways of doing it. You're going to use this one. I don't know what else to tell you. And then I have this thing called Magic Threads. I have a really bad habit of coming up with projects and giving them stupid names and regretting it later. But it's a very serious project that is the culmination of several years of refinement of doing background threading tests. And then also we have to extend Event Bus because it doesn't handle errors well and all this other kind of stuff. So that's your stack today that's in our test project. What do we got here? All the links are here, but you're probably going to post them somewhere, so I don't know. But I did. Local Hack Day, Android, Bitly. Figured that was easy to remember. Okay, so resources that you should... So that is the default Android ringer, and if you work in a room full of Android developers, it gets confusing. Mark Murphy, Commonsware, again, that was the guy I mentioned before. He has a 426,000 score on Stack Overflow. If you see an answer on there, he's probably right. If you give an answer and he tells you you're wrong, you're probably wrong. I'm just going to tell you that right now. He writes a book that he continually updates. You can subscribe to it. It's $40 a year. It's 2,000 something pages now. You don't want to read the whole thing, obviously, but that's the thing to read. It's awesome. There's a standard Android training, which will walk you through the basics. You'll see the activity, you'll see the life cycle. Again, if it tells you to build a content provider, I would ignore it, but I've had arguments with Google engineers about that. And Stack Overflow, of course, if you're not very familiar with navigating Stack Overflow, you should get familiar immediately. I'd also recommend getting very familiar with GitHub if you're not very familiar with that, because there's tons of stuff out there. And just start getting into the community and doing stuff. So, let's see. Okay, so the demo, again, you have to download Android Studio, and then I have this, the project up on GitHub, so you can go grab it. So that's the thing I just showed you. I want to see if there's anything else I can tell you about it. So yeah, I'll just actually walk through what it does. So there's two things that this does. It downloads an image, which you saw there. Let me refresh that so we can get that to be, you can see it actually happen. It's two buttons. They do two different things. One downloads an image and one loads some text. So the load image one, which we kind of walked through before, so here's the two buttons, go button, go text. We should probably rename this to be consistent to go image. And then Studio does a really good job of refactoring stuff in your XML and everywhere else. So it did that fairly well. Anyway, load image, what that does is it gets the image component, and then we use here Picasso. That was the thing I mentioned. Picasso does a really, really, really good job of intelligently loading images from the network. And that's been traditionally a very big problem on Android. You could either use Picasso or Volley, which is Google's thing. If you have another one that you want to use, I would understand very clearly why you want to use something else, because we've kind of used all of them, and this is the only one we use right now. All you do is, for this, the simple way to do this is just give it a URL of an image, and that's what we did. So you click it, and then it loads it, and then voila, it's all done. Fantastic. The other one is load text. Load text will give you an example of our threading thing. So the Magic Threads thing has a thing called task queue. Task queue is a serial background task processing and management engine. So you can add a task to this queue by doing this and calling execute. Each task extends task. They have a run method. And then we have this thing called handle error. I'm very big on explicitly handling errors, and you should be too, because if you're not, you're gonna have really bad apps. This means it returns false, which means I didn't handle it. So if this actually has some kind of crash, the app will blow up, which is a good thing, because then you'll know what's wrong. And then onComplete just does this thing where that event bus thing I talked about, it posts it to here. So on this is right now in a different thread context in the background. So when you get back to your activity, you can get the message from that task you just ran in this special thing from the event bus, and then you can put the text into the text view that's on the screen. So if you'll see here, we do that, but I have a little bug because I called toString on something, which really doesn't make sense. I'll see if I can fix that in like 2 seconds. And I can't, because it's an input stream and that's gonna take too long. So assume that had some text and we put it into the text string, which it did, but it's just a name of a class, so that's why it's a bug. We could do that, but I won't get into it. So you can see, if you're going to do anything, if you want to use the base, you can use this project to start a really basic app. I don't know what you're going to try to do with the hacking today, but you'll see in here the dependencies. So we've got Picasso, retrofit, and all the basic stuff that I was talking about in the stack. I can talk more about that, but I think we'll just kind of wrap up what we were going to present here. So,
we have one question to see what you know.
Oh, you do? Okay, let me see. Oh yeah, so by the way, if you're going to use that project, install Studio and then just do File, Open that folder where you got from GitHub, and then there's a Gradle sync button. This little thing here, you hit this, you probably can't see it, but it's sync project with Gradle, and then that should do everything, and you can click play. It used to be significantly more work to open and load a project. Studio's doing a good job of that, but you have to not try to do anything exotic. Don't try to import the project. Don't try to do all this crazy stuff. It's interesting. It takes a little while to get used to, but it actually works really well. I don't even know what I have left here. Okay. Other example projects besides my extremely minimal one is basically there's an SDK folder, that exists, the samples folder. Again, you have to be very careful. You have to look for the Gradle project structure if you're using Studio, which basically means look for build.gradle in the root. If you see RES and assets and all these other folders in there, that means it's the old project structure, and Android Studio is gonna not like it. I mean, you can get it to work, but it's gonna be kind of a pain. And if you happen to have Lollipop and you like doing a lot of crazy video stuff, this is another thing. We just gave a presentation at a meetup, so I kind of included that there. I think that's kind of it. So you have a question, and I can go into any detail you want.
So the first question is each task handled by a separate thread? I think this is related to what you were talking about with the task.
No.
You might want to repeat the question too.
Okay, is each task handled by a separate thread? It's not. The way that task queue works is everything processes in serial. Under the hood, it actually uses an executor service, but it's a single thread. There are problems with doing everything in a serial fashion, but you can get into a lot of trouble if you try to do a lot of parallel processes. So that was sort of an architecture decision. We tend to have a fair number of people working on projects that then get handed off to a client who may not be super fantastic on Android. So I lean towards less complex, more likely not to crash. And then if you have performance problems, you sort of deal with them on a case by case.
Cool. This is going to be a hairy question. Why would you use Android Studio over Eclipse? And do you have to stick to one or the other?
Okay, that's a multi-part question. What's that? Okay, why would you use Eclipse over Android? Or why would you use Android Studio over Eclipse? And what was the second part?
And like, if you pick one, do you have to stick to it? Like, is it hard to switch?
Okay, so there's a personal bias here. I've been using IntelliJ forever. I actually, not to age myself, but it doesn't matter, I'm old. I've been using IntelliJ since version 3. They're up to version 14 right now. I've used Eclipse for a long period of time in between there, thinking that Eclipse was open source and it was going to win. We actually started writing plugins for Eclipse, all this kind of stuff. IntelliJ earmuffs to everybody who loves Eclipse. IntelliJ is just better. So you should learn that, and Android Studio is based on IntelliJ. Even from the beginning of Android, I would use IntelliJ and then maybe just flip over to Eclipse to compile the project. At Google I/O 2013, they announced that Android Studio is going to be based on IntelliJ. So if you're going to learn one, learn Studio. Like if you learn Eclipse, it's getting like rolled out of the way, so you're going to learn something you have to unlearn eventually anyway. If you're an Eclipse fan, some people recommend starting on Eclipse now with Android. I wouldn't, but again, if I've learned anything, it's that people have a difference of opinion, a different opinion than I do sometimes. So you can do that. If you're learning one, do Studio. Don't even download Eclipse. You'll be out of your mind.
One last question, which I'm trying to find here.
I've got one in the meantime.
Yeah, let's hear it.
So where can people go for like Android help? Like say you're at a hackathon and you get stuck and like, there's nobody around who knows Android. Where are like some of the best online resources to go to get help with Android?
I mean, the only one I ever really use is Stack Overflow. And Stack Overflow is like, it's all there. It's just finding it. You know what I mean? The problem is if you're at a hackathon, obviously there's a time component. So if you have something that's unique, it would be difficult to get an answer. But if you're doing something that you're new at Android and you have a unique question about Android that's not on Stack Overflow, you're probably doing it wrong. Like, I mean, it's just not possible, right? So it's there. It's just, being judicious about picking out what's probably the good answer versus whatever, but that's the point. So yeah, that's the only one. We don't use anything. There's no I can't even think right now. I rarely use Google's Docs. We just kind of go to Stack Overflow and cross your fingers. It's either that or actually digging through the open source code, which is nice that it's there because, I've done a lot of stuff where you run a debugger and you actually step into Android's underlying source code and figure out oh, okay, that's what it's doing. Because again, Google's Docs are not great.
Right. The last question here is, I guess this is a little confusing me. Where do I get the emulator?
Okay, I actually can walk through that. So if you install Studio.
Well, wait, repeat the question.
Okay, where do you get the emulator? You have to install Studio. They have a pretty easy explanation of how to do that. Once you get Studio actually up and running, which means you gotta have Java. I don't know if you're running Linux or Windows or what you got, and Mac's got Java, blah, blah, blah. That you're gonna have to sort out. But Once you get there, you have to install the SDKs. I would pick, maybe Android L 5.0, definitely like KitKat 4.4.2, whatever. That includes the platform, and then also I think all the stuff you need for the emulator. Then you go into tools, and there is the Android device monitor. And nope, that's the wrong one. It's a long night last night, sort of. AVD manager, that's what you need. So AVD manager is the Android virtual device manager, and in here you just create a new one and you give it a name, ASDF, and you pick a target. I have a ton of them installed. You would have less if you just installed a couple platforms. And then you just have to fill all the stuff out. Intel x86 runs faster, but sometimes I've had trouble with that. But you should try that first. It is extremely slow. It's been extremely slow since it started. It hasn't gotten any faster that I can tell. Some people disagree with that. We almost never use the emulator, but if you don't have a device, you obviously kind of have to. That's it. So there. Now I'll hit play, and there's no way you'll see this actually start before I'm done, because it just takes hours. Not hours, but it'll take like several long minutes, because it's running a fully emulated version of Linux in a non-optimized emulator. That's why like Genymotion is good, because it uses VirtualBox, which is like a real emulator.
Cool. And any closing thoughts, or are we good here?
I think we're good. I kind of like, again, it's like such a sprawling topic that I didn't know where to go. So if anybody really, really actually is going to build something and like get stuck, if there's like a way you can give me a message, I can answer stuff. So, if I don't know how exactly we'll do that, but I would like to help. But, it's a big topic to start.
Okay, thanks.
Cool.
Oh, hello, America. We weren't expecting you just then.
No, we're coming live to you from New York. It's Saturday morning in California.
It is, and it's Saturday morning, it's Saturday afternoon in New York.
It'll be Saturday night.
Soon
eventually. We'll be live then.
Yes, that's true. We will be live then as well. I'm Swift, and this is Shy, and today is Local Hack Day. Right now, how many schools do we have tuned in?
We probably have all the full 34 tuned in right now. We've had
another 40 or so people watching.
We have 40 extras. I know we just got put on Hacker News, so if you want to go upvote us on Hacker News, you feel free to. But yeah, it's been going well. We've had some great workshops this morning. We've had a Git workshop. We had a Hubot workshop. You can just rewind the live stream. If you just come on board and you want to see something specific, feel free to do that.
Yeah, we also had Android and Arduino intros as well. So if you go to the live stream, in the description of the live stream, there's actually links you can click to go to the different workshops right
That's
to when
awesome.
to start.
We're gonna put it on the schedule too.
We also are putting them on the schedule, and we've been tweeting them. So lots more where that came from.
Speaking of the schedule, be sure to join our chat rooms. The chat rooms are on the schedule page. If you go to localhackday.mlh.io and you click on the schedule, there'll be a list of the chat rooms right there for you to join.
Yep. So what are some of the chat rooms? I know we have the regular Local Hack Day one.
We have Local Hack Day Ladies Storm Hackathons. We have Local Hack Day Web Dev, Mobile Dev, Hardware Hacking, Mecha Swift Testing, which I'm hearing is incredibly funny right now.
I can only imagine what's going on in that chat room.
And then we have new hackers. If you're a new hacker, be sure to hang out in there. We'll make sure there are people to help you if you have any questions.
Cool. So for those of us who are just joining the stream, why don't you give us a little background on Local Hack Day and like what we're doing here today?
So Local Hack Day has been in the pipeline for like 4 months now. We started planning it in the middle of the summer. We want to celebrate the end of the hackathon season. There have been so many great hackathons this semester. We wanted to really come together and celebrate that. And what better way to celebrate it by doing the thing that we love, which is hacking together. We're also trying to make it as easy as possible for new schools to have a hackathon. About half the venues of Local Hack Day have never thrown a hackathon before. This is their first ever hacking event, and we really want to give them all a shout out.
Wow.
And especially all the organizers. If you're in the room right now, be sure to turn to your organizers and tell them they've done a fantastic job.
Give them a big thumbs up, and a high five, and a round of applause. Yes, they definitely deserve it. There's a lot of work that goes in behind the scenes to organize things like this. So big shout out to all of the organizers for all of the 34 Local Hack Days out there. So quick recap for the people who in the PST time zone who are just joining us. We kicked off this morning with a very similar chat to this. We had all those wonderful workshops that you may have caught the tail end of some of them at the very end there. Well, we keep continuing that trend throughout the evening. Shortly after this, we have some API pitches.
Yeah, we have our fantastic sponsors, OrderIn, DigitalOcean, and Keen will be giving short API pitches.
Nice.
And then we'll be have a little surprise, and we'll go into our Intro to Web Development workshop right afterwards.
Nice. So, for those of you who didn't get a chance to catch it this morning, of course, we want all of the Local Hack Days to be as inclusive as possible and as welcoming to people who don't necessarily go to hackathons all the time as well. So obviously the code of conduct is in effect. We definitely ask that all attendees, organizers, sponsors, mentors, whoever might be on site is following along with our code of conduct. We have a short message to you from our commissioner, Nick, to talk about that. So let's pass it off to Nick.
Hello, I'm Nick Quinlan, and I'm the Commissioner of Major League Hacking. I'm here to talk about a code of conduct. We want every Major League Hacking event to be a welcoming environment for everyone. Please, be respectful. If somebody asks you to stop doing something, it's probably worth stopping. If you're in a situation that makes you feel uncomfortable, please report it to Major League Hacking, no matter who's involved. That includes participants, sponsors, mentors, organizers, and even Major League Hacking employees. The easiest way to report an incident is by simply emailing incidents@mlh.io. Full information on how to report, including information on how to report to specific Major League Hacking employees, is available in our Code of Conduct, which is available on this event's website as well as the Major League Hacking website. Thank you so much, and we hope that you have a safe, fun, and welcoming event.
You're back.
Oh, hello again, Local Hack Day. Hopefully you enjoyed that brief but informative message from our Commissioner Nick. He's actually going to be live at one of the
somewhere
in the world. I hear that he's going to be stopping by a Local Hack Day near you, so keep your eye out for some surprise visit from some folks from MLH this weekend.
I know Lee is out somewhere, Aziz is gonna pop up somewhere, and I hear Justin is gonna
pop up as well. Wow.
Pop up. Yeah, it's gonna be interesting. We have an informal travel team, I guess.
Yeah, right. Okay, so out of all the workshops that you've seen this morning, what are the things you're most excited about?
Gosh, I'm so excited about Mecha Swift. Okay. We've open sourced.
What is, for those who don't know, what is Mecha Swift? Yeah.
So we've open sourced the chatbot we use internally at MLH for all of you to hack on. We've set it up so there's a continuous deployment going. So if you take a look at Mecha Swift on GitHub, it's github.com/mlh/mechaswift. If you make a pull request, it'll automatically go up into the chat room. So for anyone that's curious how to use Mecha Swift, type in @MechaSwift help, and it'll give you all the commands, and you can do all sorts of exciting things. I'm really curious to see what people build on top of that.
I saw that we had a pull request go in already.
Yeah, we did. I know Randall, I think, is adding stuff right now, and yeah, there's a Hell Yeah plugin now.
Wow. Very useful.
We'll definitely use that internally at MLH.
Oh, yes. I could count the numerous ways we'll use that internally. That's great. Cool. So where can people go for help? What should the new people know? Like anybody who's just joining us, what do they need to know for today?
So be sure to join our chat rooms. Again, the link to the chat rooms is on the schedule page. That's localhackday.mlh.io, and if you click on event schedule, it'll give you a list of the entire schedule for the day and all the chat rooms. If you have any trouble, be sure to ask questions in those rooms. If you need to get a hold of us at MLH, you can tweet at us. We also have our incident reporting information available on our code of conduct, which there's a link to in your event registration page. So be sure to check all of those things out.
Totally. Also, it sounds like it's almost lunchtime too on the East Coast.
I think so.
There will be pizza for everybody. Yep, delicious pizza.
How did we afford to get everyone pizza?
Major League Hacking provided the pizza for everybody, so. Oh, our wonderful sponsors. Our wonderful sponsors, DigitalOcean, OrderIn, and Keen.io, as well as obviously our season-wide sponsors, Dell and GitHub, also awesome. We love you all. Speaking of GitHub, the GitHub Developer Pack is also available. If you're looking for some freebies out there, definitely check out github.com/education. You can get some free domains, a little bit of free DigitalOcean credit for sure.
Unreal licenses.
Oh, an Unreal license as well. That's true.
Mm-hmm.
Yeah. Speaking of Unreal and some of our hardware stuff, we have some great hardware talks coming up this afternoon.
So we have a Mayo talk. If you've ever seen a Mayo at one of our hackathons and have wanted to know how to use it, now's the time to learn. Same with our Oculus Rift. We're doing an Oculus Rift talk. We'll be having a bioinformatics talk. We have plenty of really great talks coming up this afternoon.
Nice. Well, any closing thoughts before we move on to API demos?
I think we should call Kaushal up and have him give his API demo right now.
All right. Well, we'll get Kaushal set up here in just a second. Happy hacking to everybody out there. We'll be back with you shortly.
You're live!
Hey, how's it going, America? My name's Kaushal, and I'm an evangelist here at DigitalOcean. Now, normally this is the part in the demo where I'd ask you guys how many of you guys have heard of us. And I realize I can't do that right now, and I'm probably talking to myself right now. So I'm just going to go forward pretending like that didn't just happen. So I work for DigitalOcean. DigitalOcean is a really easy way to host your application. You can deploy and run a cloud-based server in 55 seconds, and I'm going to show you just how easy that is to do. You go to DigitalOcean.com, you hit login, you hit create a droplet,
You decide which one of the many things you want to put on this droplet. Say I want to name my droplet LHD for local hack day. I want it in New York, and let's get an application on there. Let's get a Rails app on there, and it's going to be deployed with Nginx and Unicorn. And I'm going to add an SSH key, and I'm going to create this droplet. And now 55 seconds later, in the background, we're going to spin up this server for you, and we're going to give you root access to it. So we're just going to wait another 30 seconds for this to happen. And let me just add a bit of information to this by saying you have full root access to this application. It's like a server that you physically own, but we maintain and we handle the uptime for. So we're going to wait another few seconds just while this happens. And I just got an email from DigitalOcean saying my droplet is up and running. So we're just gonna give it another sec for the HTTP request to go through, because I might not be online. That was interesting. Why didn't that work? All right, so I'm gonna show you something a bit different. We're gonna log in. So instead of using that droplet, which for some reason wouldn't update its status, there it is. Okay, so this droplet, we give you an IP address and you have root access to it out of the box. So first of all, we're just gonna go to that IP address and see what happens. And you'll see right away that we have your DigitalOcean Rails application. It's just Rails new, and we just call it Rails new, and it's a brand new application. You can change whatever you want on this. And on top of that, you have root access to it. So if you were to SSH into root at this IP address, this is root access. You can sudo su. You can log out. I meant exit. Exit again. And so we're gonna log in again, and let's just go ahead and find this file right here, and let's write you guys a nice note. Vim? Do I have Vim? We're gonna install Vim really quick. I'll just take a sec. Okay, and now we're gonna Vim this file. And so this is the physical web page. So instead of DigitalOcean Rails application, we're gonna say welcome to local hack day. We're going to save. We're going to do some refreshes. And there we have it. Welcome to local hack day. This is your brand new up and running Rails application. You can git clone the project that you've been working on all day today, and it'll be up and running in a matter of minutes. So hope you guys use DigitalOcean today. If you need any help, please hit me up at this is my email. It should be on your screens right now. Take a sec to write it down. I'm kparikh@do.co, and I'm twitter.com/cashbagel. If you need any help, please feel free to reach out. I'll be here all day. Thanks.
Yay.
Hello, America and Canada. I didn't see you there. I'm Ron Burgundy. Sam Agnew, and I'm a developer evangelist at Order.in. You can see my Twitter handle and all that stuff on my crappy slides. So anyway, we're super stoked to be a part of this event. I've been excited for Local Hack Day for a while. As someone who's been a part of the hackathon community and a hackathon organizer for a while, I think it's really important that every school should have their own hackathon. So anyway, I'm going to talk to you a little bit about the Order.in API. So what is Order.in? It's a platform for food ordering. You can pretty much, if you want to do anything restaurant related or food related with your hack I was going to say weekend, but I guess it's one day, right? So if you want to do anything food related, you can use our API. You can get restaurant data. You can order food directly. Some pretty cool hacks I've seen where I made something that lets you order food from your Slack or HipChat channel, right? And a buddy of mine, Calvin, made a thing that uses food ordering as two-factor authentication called food factor authentication. So I thought that was a pretty funny idea. So anyway, we have a couple of resources for you. I'm gonna show you. I'm gonna get out of this real quick. We have an API Explorer that lets you test out our API on the internet before you write your code, so you can see what your requests are like. I have one prepared right now. I'm gonna order some food with this. So yeah. Oh, this must be the food that I just ordered. Oh.
Your donut?
Why, thank you, Shai. Oh, that is just exquisite. That was amazing. Okay, so we can use this API Explorer. We can put in some data. Oh man, that was a great donut. I'm gonna put in my address in the good old city of New Brunswick, and we can send the request and mess around with some of the data. This is the JSON. As you can see, we have a Diesel and Duke. I didn't even know they were on Order.in. It's pretty cool. I eat there all the time. Anyway, I also wrote a blog post that is on our developer blog that you can check out called "How the hell do I use the Order.in API?" And it has all of the resources that you ever need to know and a walkthrough. I'll be around all day via live streaming to help you out with whatever you need. And if you build something with the API, you'll get one of these cool shirts. I have a picture. Look at this beautiful t-shirt right here. And here's Gabe, our Rutgers Local Hack Day organizer, in the background. So yeah, let me know if you have any questions. Tweet at me if you need anything. I'll be here for live streaming. And that's the Order.in API.
What? Oh, hello there, Canada and America. It's great to see you. So unfortunately, one of our fantastic sponsors, Keen.io, couldn't be here because they're in San Francisco. Thanks to them, they've sent us a video, and we're going to go ahead and play that now.
I'm Justin from Keen.io.
And I'm Tim, also from Keen.io. Keen.io is a data analytics platform for developers, and we're really happy to be involved with MLH Local Hack Day. Justin here is going to tell you a little bit more about our platform and how you might be able to use it during the event. And on Saturday, we will be there all day on a chat line or some sort to support you and help you through anything you need. So I'll let him take it from here.
Thanks, Sam.
Good luck.
So the first thing we're going to need to do is go to keen.io and click on sign up for a free account. I've created one. It's right here. I'm going to go ahead and log into it. Once you've logged in, you're going to see that we've created a project for you. It's just going to be my first project. You can click into that and edit it to rename it. I've renamed it Local Hack Day. And you'll see that there's a couple important things here when you've logged in the overview. One is project ID. The others are your API keys. Got a write key, read key, and master key. Then over here under project members, you can add other hackers that you're working with on the project if you need to by just adding their email right here. The docs are a great tool for you to use to get started, and if you have questions as you're working with the API, there's a lot of resources here. That said, if you need some help, like Tim said, we'll both be available on Saturday to help you, so you can just send us a note with questions. If you click in down here to all the SDKs, you can see the different languages that you could use that we support. We're going to go ahead and use JavaScript. It's the most popular one, and it's going to be a great first example. So I'll go over to JavaScript. When you click on it, it takes you to GitHub. And GitHub is going to give you lots of information. The information that we're going to look at is how to get started by adding the Keen SDK, initializing Keen so that you can, with your credentials, sending events to Keen, analyzing your data, and visualizing your data. You can read through what all of that means on the page, but just to keep this quick, I'm going to go ahead and jump over to a project that I've created on my local computer and show you how to do it. So you see here that I've got just a standard HTML document with some things commented out. And these things that are commented out are what's going to initialize your project so that you can get started in send events and analyze data. The first thing you're going to need to do is grab the minimized version of our JavaScript SDK and add it to the head of your project. I've done that here. I'm going to go ahead and save it and go over to the project page to see if it's loading correctly. Here we got our Hello World page. I'm going to refresh it. Go into console. Keen. Look at that. It is loading. Now I'm going to go back to my project. The next thing we're going to do is initialize Keen with our project ID, write key, and read key. The write key is going to allow you to send us data. The read key is going to allow you to analyze and visualize the data. So I'm going to uncomment that. You'll see that I've already put them in here. Go ahead and save that. So the first thing we'll do is send some data. To send data, you have to create a variable that's going to be the payload or blob, JSON blob, that you're going to send to Keen every time that you initialize the add event variable. So let's go here. I'm just going to do page loads for kind of like an easy demonstration. The page load variable name is going to create the collection that we're going to be sending data to. Then we have key value pairs saying page view is true. It's a boolean. You could add strings or all sorts of different types of information there. And then the refer. So I'm going to grab something from the browser and send it along with the API call. Next thing is I'm going to just add event and reference the variable that I created up here. So let's save that and go back to our page and refresh it a couple times. So I think I got it 3 or 4 times. Now let's go back to Keen and see if we have some data in here. And there it is. How many events we got there? 3 times. Event properties. You'll see the properties that I created, the refer and the page view, and then we've added a couple things here. There's the Keen timestamp created at an ID. Each individual event has their own ID. The created at is a timestamp that we put on the event when the event is actually created, and the timestamp is what we place it on when we send the data, when we actually get the data into Keen. These are important because sometimes you might want to just save a bunch of events that you've created over time and then send them all in one bulk. So now that we've got some data in here, we can go to the workbench and explore it a little bit. The workbench is a very simple, straightforward tool that allows you to kind of do some ad hoc querying and get the visualizations from that. So I just want to know how many times people have viewed my app. That means I select the event collection and I do a simple count of how many events are in there. Now I'm going to run the query and it's going to tell me that the page has been loaded 3 times. This also gives you some JavaScript that you can use to put the analysis and draw the graph into your app. So I'm going to go back to that, and that's exactly what we're going to do. So you can see I've created, I've initialized Keen, created a function that's going to do the analysis. Within the function, I have a variable that is defining what that analysis is going to be. I'm going to do a simple count on event collection page load. And then I'm going to tell JavaScript to draw this query, this visualization, into a div that I'm going to create in the body of my project. See right here, there it is. So I've targeted this empty div with the ID of page count. Go ahead and save that. Go back here to my app, and I'm going to refresh it. So now you can see not only do we have the hello world, we also have a visualization here. It says that the page has been loaded 4 times. I can click that another time, and it's going to pop up and say 4 again. Click it again. And now what did I do? There we go. Caught up. All right. So that's how you add analytics to your app. We'll be here all day, both Tim and Justin. Tim at Keen.io and Justin at Keen.io. Happy hacking.
Happy hacking.
I can ride my bike with no handlebars, no handlebars, no handlebars. I can ride my bike with no handlebars, no handlebars, no handlebars.
Look at me, hands in the air like it's good to be alive. And I'm a famous rapper, even when the paths are all crooked. I can show you how to do-si-do, I can show you how to scratch a record. I can take apart the remote control, and I can almost put it back together. I can tie a knot in a cherry stem, I can tell you about Leif Erikson. I know all the words to De Colores, and I'm proud to be an American. Me and my friend saw a platypus, me and my friend made a comic book, and guess how long it took? I can do anything that I want, cause look, I can keep rhythm with no metronome. No metronome, no metronome. And I can see your face on the telephone, on the telephone. Shakers and producers, me and my friends understand the future. I see the strings that control the system. I can do anything with no resistance, cause I can lead a nation with a microphone, with a microphone, with a microphone. And I can split the atom of a molecule,
We're definitely gonna get fucked up for copyright concerns for playing the music.
Whatever. As long as we have the.
No, we're gonna cut it off.
Yeah.
Huh?
What's the address here?
Oh, it's 16 West 27th.
They're gonna flag us. They do it automatically.
Oh, so it's spot on.
No, you do.
Look at me, driving and I won't stop. And it feels so good to be alive and on top My reach is global, my tower secure. My cause is noble, my power is pure. I can hand out 1 million vaccinations, or let them all die in exasperation. Have them all heal from their lacerations, have them all killed by assassination. I can make anybody go to prison just because I don't like them, and I can do anything with no permission. I have it all under my command because I can guide a missile by satellite, by satellite, by satellite. And I can hit a target through a telescope, through a telescope, through a telescope. And I can end the planet in a holocaust, 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 in a holocaust.
My bike with no handlebars, no handlebars, no handlebars. I can ride my bike with no handlebars, no handlebars, no handlebars.
the name of the cake is rock. Super educated, I'm smarter than Spock. You ever tell me you will agree? Ain't no brother like the K-I-D-D. You know what I mean? I'm telling you, with the echo, I'm telling you.
Rachel, boy, open your eyes. A girl like me ain't waiting all night. Oh, boy, better think twice. I got that honey, that sugar, that's Rachel, boy, open your eyes. A girl like me ain't waiting all night. Oh, boy, better think twice. I got that honey, that sugar, that's Rachel.
Yeah, hey yo, I'm feeling like Ray Charles. I got my shades on, I don't know where they are. You couldn't find me even if you had a radar. And I spit rapidly, aka I make the music with the soul of the blind man. They be amazed how I get them ladies that climb in. And they try to do it, but they're blind to the fact that they're just stuck in the trap but staying right where they at. But I'm Ray Charles, Miss A calls, talking to my dime and my Miss A calls. And I spit tough, betcha I'm a last great ball. I'm going 8, y'all, I'm the new Ray Charles. I don't need no walking stick, my shit costs the grip. I get out the mouthwash if you talking shit. And I can hear the evil, but I won't see it. And if that blunt go out, you better reheat it. I got my black shades on, smoking till it's gone. Head to the sky, feeling so on. Ray Charles, I'm Ray Charles. Ray Charles, I'm Ray Charles.
Hey guys, hope you didn't miss me too much. It's been about 20 minutes, but I'm back, and this time I'm here to talk to you guys about web development. I'm going to give a talk to you guys basically explaining how data flows through your average web application, and then I'm going to touch on a bit about how Python and Flask handles this. So first of all, who am I? I'm Kaushal Parikh. I'm a student at Rutgers. I'm an evangelist at DigitalOcean, and I'm a web developer on the internet. Plain and simple. This is basically what I'll cover through the next few minutes. What is a web application? I'll tell you all of the buzzwords mean, like HTTP, REST, CRUD, middleware, all the stuff that you probably took for granted or don't really know or are afraid to ask. I'm going to show you how data flows normally through a web application and how the request response paradigm sort of works. So to help us out with this, I'm going to use the diagram that you see in front of you. We got a guy out there, the user of your application. He's going to make a request to the application, and the application is going to send back a response. And that's basically what I'm going to go through in the next few minutes. So let's start with the user. Your user is responsible for making a request. That can be typing a URL, filling out a form online, sending a post request that way, clicking a button on your web page and triggering that to send some kind of request, or he could be on a terminal using curl and just physically sending a request. But in all cases, he'll receive some kind of response from the server that he's trying to hit. And he'll display the content or do whatever he wishes with the information that he just got back. And again, this diagram basically shows the physical manifestation of your user is going to be his web browser, his terminal, the applications that he's using to make the requests from, all of the above, basically. So we talked about the user. Now we're going to talk a little bit about the request itself. So requests are made over HTTP. If you don't know what that means, I'm going to go over it in just a sec. They use the HTTP methods, and typically we use the REST paradigm, and I'm going to talk about what all of those things are. HTTP is the Hypertext Transport Protocol. It includes a list of verbs that we use to basically tag requests and send requests in particular fashions. The most commonly used ones are get, post, put, delete. And those are ones that you've probably all seen in some fashion. The less commonly used ones are trace, connect, options, patch, and there might be 15 or 20 other ones that we don't really use. And I'm going to go over why exactly that is in REST. REST stands for Representational State Transfer. It's sort of a paradigm for how we use HTTP verbs pragmatically. Example, you send a get request to get a resource. You send a delete request to delete that resource. You send a post request to tell the server about a new resource or create a new entry or resource. And that sort of makes sense. And it's sort of how we handle data flowing through web applications, flowing through your web application. Speaking of the application itself is the next thing that I'll be covering. What is a server? So when I say server, I can be talking about one of two things. I can be talking about the server hardware, or the server software. And I'm going to go through the difference in those two things. It's the place where the application is running, whether it be physical or in software. It accepts requests, sends responses, and there's an idea of a middleware that I'll demystify in a second. Server hardware. I'm not going to talk much about this. It's the physical machine that the app is running on. My phone can be made to be a physical server. My computer can be one. Like DigitalOcean has been known to provide servers for you. AWS has been known to do this. It's a server is just a physical machine. It's no different than the computer that you're staring at right now. We can have several programs or processes running on it, and that's what makes it different from this next type of server that I'm going to talk to you about. The program that you're actually going to write. We can think of this as the backend for your web application, and we call it a web server. Its responsibilities can include talking to databases, keeping state, doing whatever your application's internals are meant to do. And I talked to you about the word middleware. Middleware basically parses and sanitizes, middleware in this case, I'm talking specifically about HTTP middleware, which parses and sanitizes the requests that are made and makes sending responses and parsing all of that data, all of the data involved in that process really, really simple. And speaking of, here's the response. The response is generated by the server, and the software server is what I was talking about right there. The types of responses, you can have an HTML page, you can have strings, you can have JSON. There's a lot of different things that you can respond to the user with, and it's up to the user to determine how to interpret that. So if you send an HTML page to, or a GET request that Google Chrome is doing, let's actually do that right now. So I'm going to go to Google Chrome. I'm going to go to make things bigger. I realized that didn't make the right things bigger. So I'm going to go to www.google.com. So what actually happened was I made a GET request to Google.com servers, and it gave me back this HTML page. The HTML page that you can see right here. And there's a lot to this page because Google is sending us back a lot of information, but it is just an HTML. It is just an HTML page. You can see doctype HTML at the front of it, and there's a bunch of JavaScript and script tags for tracking information, I'm guessing. But yeah, let's get back to this. In addition to whatever response the server decides to give, a status code is usually also sent. And status codes are categorized in terms of numbers from 100 to 599, where 100 status codes, or any status code starting with a 1, is going to be an informational code that the server sends to the client. A 2xx code is what you actually want. It means success, received, understood. It's your best case scenario. That's why 200 OK is a great status code to be sending back. 3xx is a redirect. If your server decided to redirect your client to a different place or different entity. 4xx is 400s and 500s are where the errors start getting pretty intense. 4xx errors are client error detected, and 5xx errors are server error detected. So if you ever have worked in the industry and had Nagios bugging you about all the 400s you're getting or 500s you're getting, you can absolutely sympathize with how business critical not minimizing the amount of 400s and 500 errors that you're getting is to you. And so you have a web application. The user makes a request, the request is handled, and a response is sent back. So let's take a break from this presentation to write some code. I'm going to show you a really simple example in Python and Flask, and then we're going to come back and tie things together at the end. Cool. So this is a very simple Flask application. It's less than 10 lines of actual code, not including white space. And there is two things that are going on here. There's a GET request and a POST request. Methods equals post. Cool. Ooh, that was bad. Caps lock was on. Never turn caps lock on when you have Vim. It gets really mad at you. Like really, really mad at you. So what this is doing in particular is I'm going to lay it out in the exact same way I laid it out for you in the presentation. So this is our server. right here off to the side. Gonna open Tmux to make things easier. Cool. Make things smaller. Cool. So you see I have code up here and I have just a terminal window down here just to make things easier for us. And we have our user, our brave user is this Chrome window on the left side of the screen. And what I'm going to be doing is I'm going to be making requests to the code you see in the top right-hand corner of the screen. And I'm going to be running it right here in the bottom right-hand corner of the screen. So I'm going to be running this example, and as soon as I go to, it's telling me to go to http://127.0.0.1. I'm going to call port 5000, and the requested URL was not found because that doesn't exist, and it's actually .get. So cool. What happened there? Let's go really slowly. So the user typed in a URL or a GET request into their URL bar. They hit enter. And as soon as you hit enter, it travels over the wire and it uses the HTTP protocol to find its way to our server here, who has a record of it. So check out, if you guys can see what I'm highlighting right now, this last log line tells us that a GET request was made, HTTP version 1.1, and a 200 status code was returned. And on top of that, our web browser also got the code get, also got the string get back. And that makes sense. So let's do something different. Let's make instead of returning get, let's return welcome to Local Hack Day. Super excited about that. And now we're going to make this request one more time, and we have welcome to Local Hack Day. So we went through how to make a GET request and how to get the response back from the user. And again, I'm just going to bring you back to this diagram because our user made the request. It went to our server, the server software that's running, and the server software returned a response to the user himself. And in this case, again, Chrome is the user, and the terminal window on the right-hand side of the screen is the server, is the web server and the server-side code. Cool. So I'm going to do one more thing. I'm going to show you guys how a post request works. And so I can curl-x post, and I'm going to post to 127.0.0.1/:5000/post. And if you see what happened right there, making this bigger so everyone can read it. I sent a post request and I got a post back, and that's exactly what I was expecting from this application. Because if we go back to, wow, this is oddly sized. Anyway, so we go back to this, and what we are expecting is if we make a post request, we will get back the string post. So again, nothing fancy is going on here. There's probably 10 lines of code like in this entire sample application that I have here in front of you. And we're making GET requests, we're making POST requests, and we're returning data back to users. Additionally to this, we can get fancy. We can start writing HTML, CSS, JavaScript. We can have forms on the web page to have them submit. But the underlying thing that you have to understand is everything is done over HTTP. And this is how you deal with the request response kind of structure that you're used to dealing with. If I go to www.facebook.com, I'm making a GET request to Facebook servers, and they're returning back HTML, CSS, and JavaScript. And nothing fancier than that is happening right there. Which leads me back to, again, in about 30 seconds after I finish this talk, I'll push that code up to GitHub, and the slides that you're seeing right now are already up there. So it's github.com/Kaushal, my first name, /localhackday. Conclusion, web development isn't that complicated. At least the basics aren't. The data flow is simple. the request response structure is pretty easy to understand. I have a couple suggestions for you guys. Use tools and frameworks and ask for help. You have mentors here. You have people that are very willing to help you. Please reach out. If you're ever, you shouldn't be stuck for longer than a few minutes on anything. If you are, please do yourself a favor and ask for help. There's no shame in that. Here's some helpful links. While writing this talk, I went to all of these links, so they might help you at some point. There's flask.poco.org. It's just the Flask API and some notes about that. There's the HTTP if you want to know more about that. All of the status codes. So I mentioned there are 1 through 500s. If you wanted to know a 404 file not, or 404 not found, or 200 OK, or any of the crazy status codes that we have out there. And here's more information about REST as well. There's just a couple links. If you have any questions, please contact me. My name's Kaushal, again. I'm kparikh@digitalocean.com or do.co, either one works. Twitter.com/cashbagel and github.com/Kaushal, my first name. The end. Thanks for listening, guys. And again, happy hacking and have an awesome local hack day.
We're gonna skate to one song only.
So I ball so hard, motherfuckers wanna find me. But first niggas gotta find me. What's 50 grand to a motherfucker like me? Can you please remind me? Ball so hard, this shit crazy. Y'all don't know that don't shit phase. The next could go 0 for 82 when I look at you like this shit gravy. Ball so hard, this shit weird. We ain't even po be here. Ball so hard since we here. It's only right that we be fair. Psycho, I'm libo to go Michael. Take your pick. Jackson, Tyson, Jordan, Game 6. Ball so hard, got a broke clock. Rollies that don't tick tock. All the Mars that's losing time, hidden behind all these big rocks. Ball so hard, I'm shocked too. I'm supposed to be locked up too. You escape, but I escape. You be in Paris getting fucked up too. Ball so hard, let's get faded. Liberties for like 6 days. Gold bottles, soul models, spilling ace on my sick days. Ball so hard, bitch behave. Just might let you meet gay. Shot towns, B-rolls, moving the next BK. Ball so hard, motherfuckers wanna find me.
That shit crack. That shit crack. That shit crack.
Ball so hard, motherfuckers wanna find me.
That shit crack. That shit crack. That shit crack. She said, yeah, can we get married at the mall? I said, look, you need to crawl for your bar. Come and meet me in the bathroom style and show me why you deserve to have it all.
Ball so hard.
That shit crack.
That shit crack.
Ain't it, Jay?
Ball so hard.
What she order?
What she order?
Fish fillet.
Ball so hard.
Yo, whip so cold.
So cold.
This whole thing.
Ball so hard.
Act like you ever be around motherfuckers like this again. Who's your girl? Grab her hand. Fuck that bitch, she don't wanna dance. She's my friends, but I'm in France. I'm just saying, Prince Williams ain't do it right if you ask me. Cause I was him, I would've married Kate and Ashley. Was Gucci my nigga? Was Louis my killer? Was drugs my dealer? What's that jacket, Margilla? Doctors say I'm the illest, cause I'm suffering from realness. Got my niggas in Paris, and they going gorillas, huh?
I don't even know what that means.
No one knows what it means, but it's provocative.
No, it's not. It
gets the people going.
Ball so hard, motherfuckers wanna find me. Ball so hard, motherfuckers wanna find me.
You are now watching the throne. Don't let me get in my zone. Don't let me get in my zone. Don't let me get in my zone. These other niggas is lying. I acting like the summer ain't mine.
I got that hot bitch in my home.
You know how many hot bitches I own? Don't let me get in my zone. 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 The stars is in the building. They hands to the ceiling. I know I'm about to kill it. How you know I got that feeling? You are now watching the throne. Don't let me into my zone. Don't let me into my zone. I'm definitely in my zone. It may not mean nothing to y'all, but understand nothing was done for me. So I don't plan on stopping at all. I want this shit forever mine, ever mine, ever mine. I'm shutting shit down in the mall and telling that girl she the one for me. And I ain't even planning the call. I want this shit forever mine, ever mine, ever mine. Last name ever, first name greatest. Like a sprained ankle, boy, ain't nothing to play with. Started off local, but thanks to all the haters, I know G4 pilots on a first name basis. In your city, faded off the brown. Nino, she insists she got more class. We know, swimming in the money, come and find me. Nemo, if I was at the club, you know I balled. Chemo, dropped a mixtape, that shit sounded like an album. Who'd have thought a countrywide tour be the outcome? Labels want my name beside an X like Malcolm. Everybody got a deal, I did it without one. Yeah, nigga, I'm about my business. Killing all these rappers, you would swear I had a hit list. Everyone who doubted me is asking for forgiveness. If you ain't been a part of it, at least you got to witness. Bitches, it may not mean nothing to y'all. Understand nothing was done for me. So I don't plan on stopping at all. I want this shit forever mine, ever mine, ever mine. I'm shutting shit down in the mall and telling that girl she the one for me. And I ain't even planning the call. I want this shit forever mine, ever mine. Ever Mr. West is in the building. Ain't no question who about to kill him. I used to have hood dreams, big fame, big change. I stuck my dick inside his life until that bitch came and went hard all fall like the ball teams, just so I could make it rain all spring. Y'all seen my story, my glory. I had raped the game young. You could call it statutory when a nigga blow up. They gon' build statues for me. Old money, Benjamin Button, what nothing. Super bad chicks giving me McLovin'. You would think I ran the world like Michelle's husband. You would think these niggas know me when they really doesn't. Like they was down with the old me. No, you fucking wasn't. You such a fucking loser. He ain't even go to class, Bueller. Trade the Grammy plaques just to have my granny back. Remember she had that bad hip like a fanny pack. Chasing the star, I'ma turn you to a maniac. All the way in Hollywood and I can't even act. They pull their cameras out and goddamn they snap. I used to want this thing forever, y'all can have it back. It may not mean nothing to y'all. Understand nothing was done for me. So I don't plan on stopping at all. I want this shit forever mine, ever mine, ever mine. I'm shutting shit down in the mall and telling that girl she the one for me. And I ain't even planning the call. I want this shit forever mine, ever mine, ever mine. Okay, hello, it's the Martian, Space Jam Jordans. I want this shit forever, wake up and smell the garden. Fresher than the harvest, step up to the target. If I had one guess, then I guess I'm just New Orleans. And I would never stop, like I'm running from the cops. Hopped up in my car and told my chauffeur to the top. Life is such a fucking roller coaster, then it drops. But what should I scream for? This is my theme park. My mind shine even when my thoughts seem dark. Pistol on my side, you don't wanna hear that thing talk. Let the king talk, check the price and pay attention. Lil Wayne, that's what they gotta say or mention. I'm like Nevada in the middle of the summer. I'm resting in the lead, I need a pillow and a cover. My foot sleeping on the gas. No break gas, no such thing as last. It may not mean nothing to y'all. Understand nothing was done for me. So I don't plan on stopping at all. I want this shit forever mine, ever mine, ever mine. I'm shutting shit down in the mall It's telling that girl she the one for me, and I ain't even planning the call. I want this shit forever, mine, ever mine, ever mine.
There they go, back in stadiums, the shady spits his flow. Nuts they go, macadamian they go so ballistic, whoa. He can make them look like bozos, he's wondering if he should spit this slow. Fuck no, go for broke, his cup just runneth over, oh no. He ain't had him a bust like this since the last time that he overdosed. They've been waiting patiently for Pinocchio to poke his nose back into the game, and they know rap will never be the same as before. Bashing in the brains of these hoes and establishing a name as he goes. The passion and the flame is ignited, you can't put it out once we light it. This shit is exactly what the fuck that I'm talking about when we riot. You dealing with a few true villains who stand inside of the boot, true spilling and spit true feelings until our two feelings come flying up out of our mouths, never mind it. Payback, motherfucker, for the way that you got at me, how's it taste? When I slap the taste out of your mouth with the bass so loud that it shakes the place. I'm Hannibal Lecter, so just in case you're thinking of saving face, you ain't gonna have no face to say by the time I'm through with this place, so Drake.
It may not mean nothing to y'all, but understand nothing was done for me, so I don't plan on stopping at all. I want this shit forever, mine, ever mine, ever mine. I'm shutting shit down in the mall. It's telling that girl she the one for me, and I ain't even planning the call. I want this shit forever, mine, ever mine, ever mine, ever mine.
Theme song, my leather black jeans on, my by any means on, part and I'm getting my scream on, into the kingdom, but watch it you bring home. You see a black man with a white woman at the top floor, they gon' come to kill King Kong. Middle America packed in, came to see me in my black skin. Number one question they asking, fuck every question you asking. If I don't get ran at by Catholics, it comes to conservative Baptists, claiming I'm overreacting like the black kids in Chirac, bitch. 4 in the morning, and I'm zoning, they say I'm possessed. It's the omen, I keep it 300, like the Romans, 300 bitches. We're the Trojans, baby, we living in the moment. I've been a menace for the longest, but I ain't finished. I'm devoted, and you know it, and you know it. So follow me up, cause this shit about to go. I'm doing 500, I'm out of control, but there's nowhere to go, and there's no way to slow. If I knew what I knew in the past, I would've been blacked out on your ass. 4 in the morning, and I'm zoning, they say I'm possessed. It's an omen, I keep it 300, like the Romans, 300 bitches. We're the Trojans, baby, we living in the moment. I've been a menace for the longest, but I ain't finished. I'm devoted, and you know it, and you know it. Stop all that coon shit, early morning cartoon shit. This is that goon shit, fuck up your whole afternoon shit. I'm aware I'm a wolf, soon as the moon hit. I'm aware I'm a king. Back out the tomb, bitch. Black out the room, bitch. Stop all that coon shit. These niggas ain't doing shit. Them niggas ain't doing shit. Come on, homie, what happened? You niggas ain't breathing, you gasping. These niggas ain't ready for action. Ready for action. 4 in the morning, and I'm zoning, I think I'm possessed. It's an omen, I keep it 300, like the Romans, 300 bitches. We're the Trojans, baby, we living in the moment. I've been a menace for the longest, but I ain't finished. I'm devoted, and you know it, and you know it. So follow me up, cause this shit about to go. I'm doing 500, I'm out of control, but there's nowhere to go, and there's no way to slow. If I knew what I knew in the past, I would've been blacked out on your ass. God, 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 God.
Whatever the dollar you murder for, is that the one fighting for your soul? Or your brother's the one that you're running from? But if you got money, fuck it, cause I want some.
B.I.G. You fucking with me.
Oh God. Whoa. Okay, ain't nobody fucking with my click. Click, 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 click. Ain't nobody fresher than my motherfucking click. Click, 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 click. As I look around, they don't do it like my click. Click, 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 click. And all these bad bitches, man, they want the B.I.G. Oh God. I tell a bad bitch, do whatever I say. My block behind me like I'm coming out the driveway. It's grind day from Friday to next Friday. I've been up straight for 9 days, I need a spy day. Yup. She tryna give me that Wu-Tang. I might let my crew bang. My crew deep in that Wu-Tang. I'm rolling with, fuck I'm saying. Girl, you know my crew name, you know 2 Chainz. I'm pulling up in that Bruce Wayne, but I'm the fucking villain. Man, they kneeling when I'm walking in the building. Freaky women I be feeling. From the bank accounts I'm feeling. What a feeling. Nah, man, it gotta be a young player. What? On your mark, ready, set, let's go. Dance floor pro, I know, you know, I go psycho when my new joint hit. Just can't sit, gotta get jiggy with it. Ooh, that's it, now honey, come ride. DKNY, all up in my eye. You got a Prada bag with a lot of stuff in it. Give it to your friend, let's spin. Everybody looking at me, glancing a kid. Wishing they was dancing a jig here with this handsome kid. Sick a cigar right from Cuba. I just bite it, it's for the look, I don't light it. Ill way to ammo on the hand, stay on play. Give it up, jiggy, make it feel like foreplay. Yo, my cardio is infinite. Big Willie style's all in it. Getting jiggy with it. Getting jiggy with it. Getting jiggy with it. Getting jiggy with it. What? You on the ball with your kid? Watch your step, you might fall trying to do what I did. Mama, I'ma come close side in the middle of the club with the rubber dub. No love for the haters, mad cause I got floor seats at the Lakers. See me on the 50-yard line with the Raiders. Met Ali, he told me I'm the greatest. I got the fever for the flavor of a crowd pleaser. DJ play another from the Prince of this Your Highness. Only bad chicks riding my whip. South to the west, to the east, to the north. Bump my hips and watch them go off. But yes, sure. And you don't stop in the winter order. Summertime. I makes it high, getting jiggy with them. Getting jiggy with it. Getting jiggy with it. Getting jiggy with it. 850 IS if you need a lift. Who's the kid in the drop? Who else? Will Smith. Living that life some consider a myth. Rock from South Street to 125th. Women used to tease me, give it to me now nice and easy. Since I moved up like George and Wheezy. Cream to the maximum, I'll be axing them. Would you like to bounce with the brother that's platinum? Never see Will attacking them. Rather play ball with Shaq and them. Flatten them, like getting. Thought I took a spell, but I didn't. Trust the lady of my life, she hitting. Hit her with a drop top. With the ribbon, crib for my mom on the outskirts of Philly. You tryna flex on me? Don't be silly. Getting jiggy with it. Getting jiggy with it. Getting jiggy with it. Getting jiggy with it.
Hi, I'm Morgante Pell. I'm the lead engineer at Cafe.com, and I'm going to be talking about a super simple introduction to JavaScript. So just to dive right in, JavaScript's a quasi-functional, quasi-imperative programming language, which allows most sort of C-like language constructs. So you can do things like have variables, like var x equals 10. You can do things like have functions, like function hi. You can do something like say hi. So that's declares a function, and I can call hi, and it says hi. Now you'll notice one thing I importantly did here is console.log. Right here I'm in the console dev environment. Console Dev Environment is the webmaster tools, which comes with Chrome. Every major browser has some variant of this. Safari has its own developer tools. Firefox has Firebug as well as built-in developer tools. Even IE these days has some developer tools. I don't know anyone who regularly uses them as their developer tools, but they can do it. So in this console dev environment, you can access any of the variables that are available on the page in the global scope, as well as creating your own variables. Like I had my variable x that I declared up there. So if I just hit x, it did 10. And another important thing to note about this environment, which is I find actually pretty interesting, is it does anything. It converts anything that you put onto the line to a string and then prints that out. So if I do hi there, which is the function I declared, it's converting my function to a string, and the default implementation of converting a function to a string is just to print out the entire function. Now, if you want to mess around with things a little bit, you can actually redeclare these. So you can say, you can change x's to string, right? So how that's going to be converted to a string to do something like to create a function there, which say returns 11. So now if I do x, it does not, oh, yeah, I had to do the earlier here. That unfortunately x is already declared there. Essentially, but what you're doing is when you console log, you're printing out anything into this console. So that's frequently used any JavaScript development. It's your equivalent of like the print statement in most other languages, or echo, or anything like that. So if I want to do console.log, test this. Now, JavaScript is primarily used as a way to manipulate web pages and integrate interactive features into web pages. So a really useful tool for doing that is jQuery. You can do everything with raw JavaScript, but jQuery makes things a lot simpler, and in many cases helps you deal with like cross-browser compatibility. It's very rare that you'll see a major website that doesn't have some form of jQuery on the page. So jQuery's main function is this $sign here, and this $sign basically is a way of accessing any part of the DOM. So if I want to say remove every image on the page, right? So image tags are img. So this will select every image tag on the page. You can see we've got all these here, and I can do something like hide them all. And you'll see up here, all the image tags on the page were hidden, just with that one simple little command, because jQuery went throughout the DOM tree, removed all of the image tags, and then manipulated them. I can get them back very simply with just show. You see, we're just calling functions on them. How jQuery works is that if you call a function on a selector like that, it calls that same function on every element in there. So even though image is kind of an array, this right here is a sort of an array-like construct. You have 14 elements on it. It automatically goes through and basically does a for each on each of them and does show or hide or the equivalent there. You can also do things like manipulating their attributes. So they're like CSS attributes. So you can do like CSS, display none. So that's the equivalent of hiding them. Obviously we want to display them blocked most of the time. Now but you can also do even more cool things with this. So you can say, set the opacity of them. So, and you notice here I'm just passing an object into the CSS one, which is just a list of rules. So let's put it up to like 0.5. And this is just a list of CSS rules. If you ever use CSS, it's just a way of having styles applied to the page. Most web pages that you go to will have jQuery on it. They don't necessarily have it available in the global scope, but I actually think it's one of the most fun ways to start getting an introduction to JavaScript is just go around to different web pages and play with them by trying to open up the dev console and pulling things out of them. So you can do things like manipulating the context of the web pages, finding elements on the page. So here's this most popular one. All right, so we want to change that to say, we're making like a funny joke. So first we want to have the selector for it. So H1, most popular there, and we want to change like the text of it. Now jQuery has a nice built-in function for changing text. Just pass it. If we, if we don't pass anything to it, it just returns the text. If we do pass anything into that function, it acts as a getter, as a setter rather than a getter there. So if we do change it to craziest, let's say, because we think that's much more accurate than most popular, there we can manipulate the web page right in place. Now, as I said, JavaScript is most useful, especially for adding interactivity to pages. So we can do something like add a click handler so that when we click this, we will be able to actually have something happen. A click handler works by, you're adding an event handler and you're passing a function that's called whenever that event happens. So here we're going to create a function just inline, which says clicked, just prints clicked to the console. Very simple function. And then if I go up here and click on that, you'll see it says clicked. We can also change that to do an alert, which is a much more user visible form of printing something out or displaying something. So here we've got this big alert that appears on the page, clicked. That's just the built-in JavaScript alert function, which displays the output to the user. Now there's a lot more that you can do with this. There's a lot, constantly whenever you're using the web, whenever you're interacting with pages, there's dozens to hundreds of different events firing. So you can add them to all kinds of things. So you can add them to the window, and every time you resize the window, we can do something. So adding in a function here. And these are anonymous functions. So one of the major powerful features of JavaScript is that you can very easily and cheaply create functions. You don't have to name every function. You don't have to create a function up there and pass it in. You can just anonymously have a function inline right there. So we'll say resized. And this is creating an event for when we resize the window. Now I realized I'm in like a full screen mode here, so it's hard to resize the window. But let me see. There. So there, when we exited full screen, it called the resized function because obviously exiting full screen is a form of resizing the web page. And then every time I resize this, see, you'll notice it's also calling it multiple times. Like dozens of times, just even though I haven't even let go of the mouse, I'm resizing it. So a big danger that you can get into with JavaScript is that you have things calling so many times that it can overload the web page. There's a lot of issues with JavaScript performance that way. So you want to do things like setting that things call on an interval. Thankfully, JavaScript has a really great, in the standard library, it has a built-in function for setting things to be called on an interval, just send interval. And what that does is it calls a certain function on a certain interval, and it doesn't call it any less than that interval. So if I want to say console log hi, I want to do that. So the first argument to set interval is the actual function. In this case, I'm doing an anonymous function again. You can do that to call that on the interval. The second argument is the time that you want to call it on. So in this case, 1,000. Times in JavaScript are set in milliseconds. All times in JavaScript are milliseconds. So that will, there we go. So you see this is calling every second now. It's printing the console, hi. And if I do this, you'll see it keeps printing it on. You can also do a singular form of set interval, which only gets called once, is set timeout. So it'll be called first time, but it won't be called subsequently after that. Once, right in here. So this one will be called once, but you're seeing it's not getting piled up like in the future. Now, throughout this, I've been using anonymous functions in JavaScript. So the syntax for an anonymous function is this. You just don't have any name on it. So, now, right? Now, what you can alternately do is have a function that is named. So this is a named function. So, and a named function provides that name into the global scope. So, or into whatever scope it's declared in. So, named function is now available, and I can pass it into anything else where it takes a function like set interval, set timeout, any of these event handlers. But the other option that I have is actually to assign things to a variable. A variable in JavaScript can contain a function. So I can do there xfunc equals an anonymous function. So we're creating an anonymous function here and putting it into the x function call. So x function, same way that as if it was a name function, x function now works. Now, this is maybe not so interesting and useful for this immediate case right here, but it is how you start to build up sort of class-like functionality in JavaScript when you want to have like a set of functions that are available in a certain sort of namespace or object. In JavaScript, you can create those through having an object. So we want to have this be, class example. And it just has like 3 functions that say hi, say bye, or something. So hi will be one function, right? And we can have another function on there, which is bye. And again, the same way that we were assigning these functions to a variable above with the x function, this is just assigning them to those variables within that object, or if you're coming from a Python background, you think of this as a dictionary. So we can have bye here, and now both of those functions are available within that class example. So, so there. See, we're able to say hi, bye. So and this is like ways that you can start to group functions together onto a particular class, or onto a particular object, which is maybe something that's not as intuitive in JavaScript as it is in other languages, because JavaScript doesn't have the sort of built-in construct of let's just have like declaring something a class and having a bunch of methods underneath it.
We have a related question here.
Sure.
Is there a difference between defining function x or x equals function?
Yeah, there is actually a slight difference.
Do you want to repeat the question?
Oh, sure. So someone was asking, is there a difference between doing something like this, which is x equals certain function, so x equals an anonymous function, and function x equals function x. So these are both named functions, but the difference is actually in terms of where they're hoisted in the scope. So functions automatically go to the top of the scope that they're declared in. So if you do function x, if you were in a certain scope, in this case we're in the global scope, but if you do that, it would be available even previous lines in your program. So if you had function x, it would be available and you were calling it anywhere else, so it'd be fine. Whereas when you do var x, that's declaring that variable right there, and the function's available right there. So if you have them on that, frequently what you'll see as a pattern is actually doing both simultaneously. People do var x to like put it into that function, but then also hoist it up, just so that it's always available. If you want to learn more about it, you can Google function hoisting in JavaScript. It's one of the more interesting things around JavaScript. And one other thing so we mentioned a little bit around the scope. So how JavaScript scope works is you've got every time within a function, whenever you're within a function, as well as certain other less known methods, you have a new scope. So here y is available, and in the console we're in the global scope. But if we're going to write a function here that accesses y, it'll be available, right? So if we do that, y is available, y is printed out. If we change the value of y, so if we change the value of y to be by or something, and we call that function, sorry. Even though we were changing the value out after the function was declared, it's still reaching into the scope of when it was declared to find the y. Now, if we declare a function within a function, if we declare, a variable within a function, say var L equals hello, and then we call that function, but now, so within the function it worked fine, there wasn't any errors that were given to us, but if we try to do something like printing that variable that we just declared within the function now, we get a reference error because L is not defined in the global scope. It's just defined within that function. So that's, and you frequently will want to do this. It's considered bad practice in JavaScript to have all of your variables including the global scope. Because if they are, any function anywhere on the page, any code anywhere on the page can access it and manipulate it. So usually what you want to do is have very few global variables, or if you have to have one for some reason, so there's like expose some functionality, you should only expose the minimum functionality required or the minimum API required. So looking at that a little more, if we want to look at, so we have this variable there, L, hello, and then we actually could return something. If we want to return L, sorry, if we want to return L, that can actually work. So Q equals hello. So now Q equals hello, because it was actually, because we were returning L out of that function, we can return a pointer to that scope, to that function within the scope, to that variable within our function scope, and make it available in the global scope as Q now, or whatever we called that function as. So if we do hello here, that actually returns hello because that's the value of it. Now this can get a little tricky in that if you then are changing that value, so we want to change Q to be something else, right? That does not persist between runs of the function. So because each time we were in the function, it's redeclaring L locally. It's not checking if that's available in the global scope. So that's just a bit of a gotcha that some people sometimes run into. Yeah.
Like if you can't find it in the function namespace, it always looks for it in global?
Yeah, exactly. So if it doesn't find it in the function global space, it will go up to the global space. But if you write it in the local space, it will not pull in any global values. Whatever's the most local scope is always what's overriding it. So you override any global values. And you have to be a little careful about that sometimes, especially with some of the more important ones like so the global scope is actually on window here. Window's sort of if you're doing something like Node.js, which is a server-side JavaScript rendering environment, that's not going to be available. But anytime that you're in a browser using JavaScript, window is available, and that's actually where you have all these different useful functions available. This is kind of where the JavaScript standard library itself actually lives, including things like set timeout, set interval, set timeout, all of that. Now, one thing that you can start to get kind of tricky with is you can actually override things. So JavaScript is one of its great features and also one of its pitfalls is you can do you can do things that are somewhat dangerous and also pretty fun. So here we're going to actually change what set interval does. We're going to say we don't like timers. So anytime anyone tries to change set interval, we're going to say no timers. So that changed what set interval does in the global scope. So if I try to set an interval now, same way that we did it before, with having a function in here, right?
Bracing step, right?
Yeah. There. So we weren't actually able to set a timer. It simply changed, printed out no timers, and notice we're not saying test every second now. But we are still saying hi because redefining a function doesn't have any impact on previous uses of that function. So as you go into some more advanced JavaScript, you'll probably end up using this for actually, especially if you're trying to pull in APIs from other people. So if you're trying to like consume something and then you want to change it in some way, or it's actually how you can also do object inheritance in JavaScript. You can inherit some methods, but then redefine some methods locally, and have those local methods redefine it. I think we've got a couple more minutes here, but if you want to look at, so every function in JavaScript actually has something called a prototype. So we're doing this function here, and what a prototype is sort of the set of additional methods and variables that are attached to that function. So in many ways, a function in JavaScript is similar to a class in other languages. So hello we've got here, that works fine. But you'll notice here, hello also has this fun little method called prototype. So we can change parts of that. So there's a bunch of built-in values as well as attaching anything else we want onto there. So we can give function prototype a new method if we want to. So let's say by. So this is attaching a function onto that hello function. By. So let's just create a variable here which contains hello, and then we can actually, sorry. Sorry. So it needs to return itself here when we have this function up here. This is a keyword in JavaScript that references the current invocation. Hello, in this case, since we're not passing anything, it will specify hello. So hello there, right? And here's where it's printing out window. So here we'll have greeting equals hello, and then if we do greeting, we can actually call function again. And then every time it does that, it's returning back to the most recent scope. Here we can have it return this one. So if we want to do, and then there's some of these built-in methods that I was talking about for functions. One of them, some of the built-in methods from JavaScript for using functions. Two of the useful ones are apply and call, which will actually call a function with a particular variable scope to this. So we can do something, we can call hello with, and the first argument that you pass to hello is the variable that you want to be in what you want this to be overridden as. So we can call hello with hello as this if we want to. So now you'll see where it's returning this and printing it out. It's actually returning itself. So you can kind of cut into some slightly silly things there. And then we can also actually do the same thing with apply. It's just apply takes a set of arguments. And then if we were to do this, as I was saying, we can change the prototype. So we can change things like change any values in these prototype if we want to. So we can change it to like toString, and that toString can return by. So a lot of these additional methods are available on the toString. Yeah. Yeah. Cool. So I think we're just about out of time. I don't know if there's any questions.
There's one more question.
Sure.
How do you store data in JavaScript?
Sure. So storing data simply is just variables. That's within JavaScript itself.
Or like persistent data?
Yeah, and then if you want to have persistent data, there's sort of two ways that you can do it. You can have cookies in JavaScript, so you can set cookies on the page. The API for that's somewhat complicated, but if you Google setting cookies in JavaScript, you can do it pretty easily. More recently, HTML5 has local storage, which allows you to store a lot more data. So you can actually store entire databases in JavaScript. And local storage is sort of a NoSQL style database that's available locally. Whereas cookies, you only want to store, a couple characters at most. So the traditional approach is you like store a user cookie that represents the user, and then you go to the server to get any data you need to persist. The newer approach, if you want to have something that has no server at all, you can store data in local storage. And if you look either of those up, there's pretty extensive documentation on how to use them.
Cool.
Anything else?
I think that's it. Thank you very much.
Thank you.
Oh, hello. Yes, up next we have our introduction to the Mayo armband. Now, if you haven't seen the Mayo before, it's a gesture-controlled armband. So we have these in the hardware lab. So any Major League Hacking events, you can obviously get your hands on these and try them out in person. The way it works is there's a band that you put on your arm, and you can easily get the XYZ coordinates of your arm, and then some coarse gestures, so things like swiping or fist. Mayo's been awesome. They've given us a lot of product to bring to the hardware labs. So yeah, we have this short video talking about how to get started hacking on Mayo. I hope you guys enjoy it.
Hey everyone, welcome to Mayo Development. Thank you so much for choosing to work with the Mayo armband. I honestly think this product is going to blow your mind. My name is Goodine. I'm a developer evangelist here at Thalmic Labs. You can get a hold of me at my Twitter handle or at my email, chris@thalmic.com. If you have any questions throughout the day, make sure you reach out. In this video, I want to help you get started developing with the Mayo. To do so, go to mayo.com/start. Right here, you're going to be taken to our initial start page. In front of you, you should have your Mayo armband, you should have a USB cable, and you should have a Bluetooth adapter. For those of you who have slender arms, make sure you check out these Mayo sizing clips. You can put these clips between the pods on the Mayo armband to tighten up the fit. The next step is to download Mayo Connect. Scroll down to the bottom of the screen where you'll see links for Windows and Mac. I'm running a Mac right now, so I'm going to go ahead and download this version. I'm going to save that to my documents. And once that downloads, I'll go ahead and run that application. Once the download is complete, I'm going to go ahead and drop Mayo Connect into the applications folder. I'm going to replace the old one just to make sure I have the most up-to-date copy, and then I'm going to go ahead and find Mayo Connect. Once I find that, I'm going to go ahead and run it. And open. When I first run Mayo Connect, you're going to see this Getting Started guide open up automatically. You're also going to see this little Mayo armband icon in your taskbar. The Getting Started guide only opens up the very first time you run Mayo Connect. After you complete the setup process, when you run Mayo Connect thereafter, it's just going to bring up this icon in the top here. All right, let's get started. So first off, Mayo Connect asks us to plug everything in. So let's start with the Bluetooth adapter. I'm going to plug that in to my USB port there. You'll see this green check bar came up. That tells me that it's recognized properly. Next, I'm going to plug in the Mayo with the USB cable. I'm going to pull down that little plastic rubber flap there, and I'm going to plug in the USB adapter. Once that plugs in, you should see that green check mark light up within a few seconds, and there we go. After I continue, now I have the chance to name my armband. I'm going to go ahead and name that Goodine. Go from there. Next step is to actually unplug the Myo from your PC. You'll get a green check mark as soon as that happens. And then we're going to put on the Myo onto our arm. So try to put the Myo on the thickest part of your forearm. This is usually a couple inches below your elbow. This area has the largest muscle mass, which means we have the largest electrical signals to work with. So you usually get the best recording in that placement. Next step is to perform the sync gesture. So the sync gesture is really important. This basically is a reference that we use to classify hand gestures. If you do this gesture improperly, chances are you're going to have issues with the recognition. So to do that, you want to take your arm, just like this image here, wave your wrist out first, and then gently wave out your arm to the outwards direction. I'm wearing the armband on my right arm, and it detected that right there. Just for practice, we're going to do the sync gesture one more time, so I'm going to do it again. And there we go. Now we're calibrated. The Myo, after doing the sync gesture, can recognize all gestures that's supported by the SDK. So the first one is the double tap. We use this as an unlock. You simply take your thumb and you double tap your middle finger or your index finger or your ring finger. You do that twice very quickly. So I'm going to go ahead and double tap, and just like that, I get that check mark there. It tells me that it read it successfully. The next gesture that we recognize is the spread fingers. So simply spread your hand and it should recognize just like that. Next one is wave right. Simply wave to the right, wave left, and then finally make a fist. So now we're in this sort of playground area. Now you can kind of play around with the various gestures. Go ahead and try them and make sure that they work for you. If you are having issues at this stage, you want to take off the armband and replace it back on your arm and redo the sync gesture. After you do a sync gesture properly, you should see better performance. If you're really having issues, it might have something to do with the fact that you're in a colder climate and you may have dry skin. We started to know this now that we've entered the winter months up in northern Canada. So if that is the case for you, you may want to wear the Myo for a couple minutes before trying again. This will allow your body to produce a little bit of sweat, which will help with the contact. All right, so once we're done that, we can go ahead and try some of these applications. The very first one is simulating music control using the Myo. So if you're working, you don't want to actually trigger your music unless it's intentional. So what you do is you simply double tap to unlock, and that checks off the unlock icon there, and then you spread your fingers. Next, you wave to the right, change tracks, and finally, you can go back using wave left. We're just going to go ahead and pause that by spreading our fingers again. Next, it asks us to double tap and wave right to advance to the next screen. And now we're kind of simulating a thermostat. So here, we want to double tap, make a fist, and hold on to that fist. Now you can practice combining gestures and motion. So by holding onto this fist, I can rotate my arm to the right, I can go back to the left, and I can go all the way past 72 degrees Fahrenheit to advance to the next screen. Finally, we double tap and spread our fingers, and we finish the Getting Started guide. This takes us to the Myo market, which we'll explain later. So before going into the Myo market, I want to first explore the Thalmic Developer Portal. So this portal has all the resources you need for Myo development. You can see here we have Getting Started links. We also have documentation. This is very thorough documentation for Windows and Mac, Android and iOS. And finally, we have our downloads page right here. If you go ahead and click on the downloads page, this is where you're going to see the most up-to-date versions of Myo Connect for Windows, Mac, iOS, Android. You're also going to see the SDKs here as well as the firmware downloads. So I'm working with a Mac. I want to go ahead and download the Mac SDK from here. And I'll go ahead and I'll save that there. One thing that I wanted to mention really quickly before we go on is this Unity package down here. So within the Windows and the Mac SDK, we have a Unity package. So you can simply import this package directly into Unity and run a sample Mio application. It's very easy to get started. The next thing I wanted to highlight is this list of unofficial tools and language bindings. Here you'll see a whack load of bindings that work with the Mio. So if you're not happy working with C++ in the original Windows and Mac SDK, you can work with other languages using these bindings. For example, if you want to do a web application and you want to work with JavaScript, you can go ahead and click into Mio.js and then have a look at this. It has full documentation. It's very easy to build out web applications using this tool. So now that the download is complete, I'm going to go ahead and double click on this to open up the SDK. I'm going to open up that application, and the first folder I'm going to go to is the bin folder. In here you're going to find the 2 sample applications pre-built for you. So you can go ahead and run these applications to get a sense of the data that you're working with. So first off, on the far right column here, you're going to see the pose data. So right now you can see it says unknown. You'll also notice that it says locked. The reason why it says that is because the Mio is waiting for you to double tap, perform the double tap gesture to unlock it. From there you'll start to read in the pose data. So I'm going to go ahead and double tap, and I want you to notice the pose window that shows up down here. So I double tap and all of a sudden it turns unlocked and you see the small pose window show up here. If I do that again, now if I perform a gesture, for example the wave out gesture, you can not only see the pose detected right here, but it also shows up here as the currently detected pose. If I go back to rest, that changes. I can do, and then it will lock back up again. If I unlock one more time, I can do the wave in gesture. I can spread my fingers, make a fist, and then it will lock back up again. So the next set of data that's interesting to work with is the orientation data. So across these 3 columns, you get to see the roll, pitch, and the yaw respectively. So if I look at the first column, you can see that if I rotate my arm and I roll my wrist, you can see the change there. In the next column, if I change the pitch of my arm, for example, if I raise my hand up to the ceiling or if I bring it down to the ground, you'll see that change there. And finally, you have your yaw. So if I point to the right, it changes, and then if I point to the left, it changes. So this data you can work with in your application to track the movement of your arm. So now that you have a sense of the data that you have to work with, let's dive into the actual code. So going back to the SDK, we can go into the root directory and then from there go into the samples directory. Here we'll find the hellomio.xcode project. Let's go ahead and open that up. So when we open that up, first thing we want to do is navigate to the hellomio.c++. This is the actual code. You'll notice that if I go ahead and run this file, down here you can actually see the exact same data that comes through. So for example, if I change my roll, pitch, and yaw, you can see the data updating. It also has all of the pose data as well. So if I double tap to unlock, it unlocks and now I can change the pose. You can see the wave out, wave in, rest. So without diving in too much detail, I want to go over some of the main methods that you'll find in the C++ file. The first one is on orientation data. So this method is called whenever the Mio changes orientation, and it passes in the quaternion, which is the definition of the orientation. In most cases, the quaternion is not something that you want to work with, so we've provided the Euler angle calculation to convert that quaternion back to roll, pitch, and yaw. So this outputs radians, and you can then take that and scale it. So for the output down here, we scale it from 0 to 18. The next method that I want to highlight is the onPose method. This is called every time that a pose is changed. So in this case, it passes in the pose. We simply set the current pose to the pose. We can do conditional statements on it. And then in the actual print function, we can just go ahead and change that or print out that pose right there. If you want to build a native Mac application, this is all you need. You can simply take this sample project and build on top of that. Whenever you detect different orientations, you can trigger actions based on the values of roll, pitch, and yaw that you're looking for. Similarly, if you want to trigger actions based on your pose, you can do that in here. So with that, I want to take us back to the Myo market. So the Myo market, this is something that we just released, and I'm actually extremely excited. So this allows us to share the applications that we've built, but it also allows third-party developers like yourself to distribute the applications that you build. One application in particular that I'd like to highlight is the Race the Sun. So Race the Sun, it's actually an awesome game. If you haven't tried it before, definitely give it a shot. But I just want to show you how exactly someone built out this application. So what's interesting is that the creators of Race the Sun themselves did not build out native Myo support into the game. Instead, the developer here built support for the Myo on top of the game. So they built what we call a connector. So a connector simply examines your active window on your operating system, looks for a particular application, in this case Race the Sun, and then once that application is detected, it basically maps your gestures and movements to keyboard and cursor commands. So I'm going to go ahead and download this connector just to show you what I mean. I'm going to save that right there. So now that the download is complete, I'm going to go ahead and double click on this file. And it's going to ask me to install it into the application manager of MyoConnect. So I'm going to go ahead and do that. It asked me to replace it. I had an existing one in there, so yep, no problem there. Now I'm going to go into MyoConnect up here in this Myo icon, and I'm going to go into the application manager. So the application manager is where you house all of your connectors. So you'll see PowerPoint is in there, Prezi, Spotify, VLC. So what this means with these connectors in place, if I were to go into the Keynote or Prezi in my operating system, I will be able to control it automatically using the Myo because of this connector right here. So now I've just added the Race the Sun connector, which means that if I go ahead and run Race the Sun, I can control it using the Myo. So what I want to do, first of all, mention is that you'll notice that here it says View and Finder. Chances are when you're looking at this, it doesn't say that. The reason it says it on my machine is because if I go back into the Myo icon here and I go to Preferences, I can enable developer mode. This is something that you want to do. It makes life a lot easier as a developer when working with connectors. So it's in here right now. I'm going to go ahead and play the game for you guys really quickly. I'm just going to type in Race the Sun. It's going to open it up. So right now, I am actually moving this cursor with the armband. It's really cool. So I go play offline. I simply wave in to select that. I hit play, play, and now I'm playing. So I can make a fist right now to calibrate it. And as I move my arm to the right and left, I can control this. If I spread my fingers, it pauses the game. And if I were to rotate and wave my hand upwards, it would trigger a special move, my jump move. I can also wave my hand outwards. In this case, take control over the cursor and hit the X. So I'm going to go ahead and get out of here just so I can, dive into the actual code instead of just have fun. Okay. So all that showed you was that by having a connector in MyoConnect, I can control Race the Sun with the Myo. So it's really sweet. So how exactly did I do that? To show you how I did that, I'm going to open up Sublime Text 2, and I'll show you what this connector actually looks like. So if I open up the connector, Documents, here we go. It's going to open this up. So you'll see there's no styling right now. That's because of the .myo extension. It's not understood yet by Sublime Text 2. This connector is actually written in Lua. So you can go into View, Syntax, and change that to Lua, and now you should have the appropriate styling. So this is the connector. You'll notice that it's actually not that big. It's only 200 plus lines of code, and this allows you to play Race the Sun, so it's really cool. First thing I want to highlight here is the on foreground window change. This method is called every single time you change the window in your operating system, and it passes in the app and the title. So you can simply match the string. So if you detect race the sun in your application title, and you match that up, you can go ahead and run. It would then detect this as your active script and give you control over it. Next is onPoseEdge. So this method is called whenever the pose is changed on the Myo, and it passes in the pose and the edge. The edge refers to the state of the gesture. So if I squeeze a fist, that's an on edge. As soon as I release the fist, that's the off edge. So in here, for example, if I were to spread my fingers, it's going to call this escape method. If I go to the bottom where this escape method is defined, you'll see that this simply simulates the press of the escape key on the keyboard. Similarly, if I come back up here and I do the wave in and it does this left click method, going back down here, that triggers the left click of the mouse. So you can see in these connectors, you can actually define keyboard presses and cursor clicks as well as control the cursor itself using the Myo very simply with one of these connectors. So that's it. Really, that's what I wanted to highlight in this demo video. It gives you a sense of the data that comes out of the Myo. You have your orientation data, which is the movement of your arm in space. You have your pose data, which is fist, finger spread, all those gestures to work with. And you can use that data to build out native applications in Windows, Mac, iOS, and Android, but you can also control existing applications using these connectors. There's a lot to do here, and there's a lot to discover with the Myo. Make sure you check out our developer portal. The documentation, as I said before, is very thorough. There's a lot in there that can help you out. If you do have any questions, though, make sure you contact me. Again, you can contact me through Twitter. There's my handle right there, and you can contact me through email. I should be available, and I'd be more than happy to help out. Best of luck, guys. Can't wait to see the results.
Get up, get coffee. Code monkey, go to job. Code monkey have boring meeting with boring manager Rob. Rob say code monkey very diligent, but his output stink. His code not functional or elegant. What do code monkey think? Code monkey think maybe manager wanna write goddamn login page himself. Code monkey not say it out loud. Code monkey not crazy, just proud. Code monkey like Fritos. Code monkey like Tab and Mountain Dew. Code monkey very simple man with big warm fuzzy secret heart. Code monkey like you. Code monkey like you. Code monkey hang around at front desk till your sweater look nice. Code monkey offer buy you soda, bring you cup, bring you ice. You say no thank you for the soda, cause soda make you fat. Anyway, you busy with the telephone, no time for chat. Code monkey have long walk back to cubicle. He sit down, pretend to work. Code monkey not thinking so straight. Code monkey not feeling so great. Code monkey like Fritos. Code monkey like Tab and Mountain Dew. Code monkey very simple man with big warm fuzzy secret heart. Code monkey like you. Code monkey like you. A lot. Code monkey have every reason to get out this place. Code monkey just keep on working. See your soft pretty face. Much rather wake up, eat a coffee cake, take bath, take nap. This job fulfilling in creative way, such a load of crap. Code monkey thinks someday he have everything, even pretty girl like you. Code monkey just waiting for now. Code monkey says someday, somehow. Code monkey like Fritos. Code monkey like Tab and Mountain Dew. Code monkey very simple man, big warm fuzzy secret heart. Code monkey like you. Code monkey like you.
It makes it easier.
Hey guys. Yeah. So we're live streaming. Have you got the guys? Oh, hold on. I'm gonna turn off soccer. Oh, hold on. I need to go pick up. Take care of this. She'll right. Pass it around.
All right. Take it. Okay. Take it.
These guys are working on it.
I'm working on a quadcopter. Yeah, let me see it.
It's a quad.
I'm here for moral support.
Yeah, me too. Moral support. These guys.
Okay.
It's not that impressive, mostly just because I can't actually show you how it works. But in high school, I was part of a thing called First Robotics. Okay, yeah. Does anyone actually know what that is?
Yep.
Yeah, he was. Yes, awesome. Okay, so one of the problems I've always had when I was on programming was the driver station is Windows only because it runs in LabVIEW. I run Linux. Did back in high school, do now in college. Well, found a project online for an open source driver station that's cross-platform.
Awesome.
Problem? No joystick support. So you couldn't do the primary thing you needed. Well, I just got done. That blue window at the bottom there is the driver station with joystick support, ability to do almost everything the original driver station needed to do in order to actually work.
That's awesome. Fantastic.
Just pushed it to GitHub like 5 minutes ago, and now I'm going to go post it on the Chief Delphi forum to see if people actually test it for me.
That's awesome.
Good job. Hey man, I lived on Chief Delphi. Rock up.
That's awesome. Hey guys. Yeah, so we're doing a bunch of hardware hacking over here. Lots of electrical engineering projects. We've got some GSM Twitter feeds going, some 3D printing happening.
Let's see this 3D printing.
That's in another room about a few blocks away. So I could run over there if you really want me to.
Okay.
Yes,
Give us a tour of Silicon Bayou.
This is pizza. Hello. Yeah, we're excited for pizza.
So where's the train? Tell us about where are the trains, Matt?
The trains, I left my train in Slidell, actually in New York. I'm so sorry.
My apartment.
Express on rails. Where is Express on rails?
You didn't buy a second train yet?
2 trains.
Wow. Don't let him listen to his joke.
Matt Condon during Hack and Wide is known as the king of all puns.
Nice.
Yeah, oh, I know. Oh, I know.
Can you give us a couple puns now?
Yeah, give us your best pun.
My best pun? There are simply too many.
God,
What's your favorite?
I can't do this. I'm put on the spot. I can't do this right now. I'm terrified.
Pizza puns?
Pizza puns? I don't know. Do you want a piece of those or no? Because that's cheesy.
Oh my God.
Alright. Okay. So, queso. See, that was the cheesy one too. No, I'm so sorry. Alright, I need to sign a receipt for pizza.
They wanna know who your names are.
Yeah, who are you?
That's actually, she's just a person. Alright, I'm gonna go sign a receipt. I don't know. You can describe yourself.
What are you working on this weekend, Angela?
Time set.
What?
What are you working on this weekend?
Nothing. I am no engineer. I do not build things. That would be a really bad idea.
It sounds like an excellent idea.
Today is the best day to learn, right? If you're an aspiring engineer, you can learn at Level Hack.
Some great.
I'm a psychology major. Like,
Probably.
All right. Well, I think we gotta switch to our next talk. Guys, it was great chatting with you. Have fun.
Thanks for stopping by. See y'all.
All right. Happy hacking, everybody.
Hey everyone, my name is Evan Casey, and I'm going to be giving a talk on Intro to Scala. Cool. So a little bit about me. I'm engineer in Tapad, New York, startup, Hack and Wide 2014 fellow. I work with Scala on a daily basis, doing everything from Hadoop stuff, distributed systems, to web programming and Play, but we use Scala basically for everything throughout the stack at Tapad. So if you want to follow along on this tutorial, you can fork or clone the repository at github.com/evancasey/intro to Scala. And so, yeah, let's go ahead. So here's a little overview. We're gonna talk about some of the basics of Scala, what it is, how it fits in with other programming languages you might know. Some basic principles of the language. It's a functional language that also has support for imperative programming. So there's stuff like type inference, higher level functions, and then we're also going to talk about some patterns, so closures, pattern matching, monads, and then finally, basically, why is Scala awesome, but why is it especially good for distributed systems? So before we dive into Scala, you might want to consider just two very common programming languages. This is Ruby and Java. So Ruby as a dynamic language, many people say it's concise, it's a scripting language, it has a REPL, the IRB, it has support for higher order functions, you can extend existing classes, duck typing, method missing stuff. And then, on the other side of the spectrum, there's Java. So, a very classic language, better IDE support. People say that they write fewer tests with Java code. A lot of open source libraries, good performance, JVM tools, better multi-threading support than Ruby or Python or any of the more modern dynamic languages. So that Scala basically stands for scalable language. And the reason that it was named Scala, scalable language, is that it's really designed for high performance systems, and it fills in a lot of the gaps in between Ruby and Java that sort of the feature set that both of them would like to have but couldn't until now. So Scala is statically typed, meaning that when you initialize a variable, that the type of that variable is not going to change throughout the execution of the program. It runs on the JVM and has full interop with Java, so this is super cool. Basically, Scala compiles down to JVM bytecode, so you can intersplice your Scala program with Java libraries or even full-on Java classes, and it'll all compile down to the same bytecode. But what's interesting is Scala has support for object-oriented programming. So it's not a fully functional language like Haskell or standard ML or something like that. You can actually create classes that have state, but you're not limited to only types. And this produces a style of programming that's very unique to Scala, or perhaps OCaml would be another example of a language that combines functional and imperative programming styles or object-oriented styles. But it is a functional language. It has support for all of your favorite things like higher order functions, composable types, things like that. But it has all the dynamic features of many of the dynamic features of Ruby and Python, and you can do scripting with it, all that kind of stuff. And it's got a really good way of doing concurrency with the actors model. So Scala is really practical because you can mix it in with your Scala and Java projects, use existing Java libraries, tools, Ant, Maven, JUnit, etc. Pretty good IDE support, so IntelliJ is awesome and has a pretty good library for plugin for Scala support. And you've got Scala specific tools like SBT, which is the Scala build tool. So we're going to dive into just a few examples now. So a basic principle of programming in Scala is the idea of type inference. So for example, I'm going to switch over to the command line now. And let's open up the Scala REPL just to show you guys how you can use that. So say I want to initialize an integer. So I'll call it x, and I give it the value 1, and I hit enter, which executes in the REPL. And you can see that, let me zoom this in a little bit more. The Scala REPL has actually inferred the type of our variable x to be an integer. And that's because the compiler notices that we've assigned the variable x a value of 1, which is of type integer. So this is a simple example, but it can also work for other things. So say we had a little bit more complex of a data structure. So we had some, a hash table or a map, and we would like to map from ABC, which is the key, to a list of integer, 1, 2, 3. So when I execute this code, again, the Scala compiler is going to infer that this is a map of string to list of integer. So you can imagine if you have more and more complex types, this becomes a powerful tool. But you can also declare explicit types in Scala. So here's an example where we've actually defining the variable sum to be of type integer. And you might say, well, why would you want to do this? Because you already have type inference. But the idea here is that if you've got more and more complex types and classes, it's going to help a lot for your code readability to be able to declare these types explicitly. But Scala also has awesome higher level function support. So if you're say doing something like iterating over a string and seeing if it contains any uppercase characters, a Java example of this might involve initializing a Boolean variable to maintain the has uppercase state, and then iterating over each character in that string to check if each character is uppercase. And when the if case succeeds, the uppercase statement is updated, and maybe we would return that has uppercase variable. So this is a classic imperative example of how to do that. So you can write Scala code like this as well, but you can also use higher level functions, which enable you to do this quite a bit more easily. So here's the Scala equivalent of this, which is much shorter, as you can see, and the variable has uppercase is instantiated by just iterating over the name string using the exist function, which iterates over each iterable in the string class, for example, and checks is uppercase on each character. The same would work for lists or anything that's iterable. So this is great, and we can also do a lot of other stuff. So you could map over it, basically all of your higher level functions that you may recognize from other language: fold, reduce, contains, flat map, all of that stuff you can do in Scala. And there's more in the examples repository if you want to play around with that. But another great thing about Scala is that it was really designed to eliminate a lot of the things that people complain about in Java. And is that the syntax is very verbose, and if you want to initialize a class, for example, in this example we've got a class person that has fields name and age. You're going to have to write all this boilerplate code. So a constructor that allows you to set the initial values of name and age. You've got a Gitter functions for name and age, and then setter functions for name and age as well. So your class definition becomes, all of a sudden a significant amount of code. But in Scala, you can do this in a much more concise fashion. So here's the equivalent of this in Scala. It's actually just one line of code. So we initialize a case class, which gives us the constructor for free, and also allows us to do class equivalence functions. So the case class is something that abstracts away a lot of things, but the main idea is that it adds some functionality to a normal class. And so with this, we have the the building blocks of a class with getters and setters defined. So I'm going to switch over to the REPL now just to give you an example. So we would initialize a case class of person. We've got a integer, or actually the name, which is of type string, and the age, which is of type int. And we're going to initialize that. And so now the class is initialized, or the class type is initialized, and if we want to create an object of this class, maybe we'd say val p equals person of Bob with age 42. So as you can see, it's calling the built-in constructor of our case class, and now we can say maybe update age, so p age equals 12. Oops. Send it to val. P. Let's see here. P.age is, so here's the getter, and the setter would say, I think this is a problem with the REPL, but let's say we want to create a new one, so we'd say val x equals, person of Timmy and 22. So you get the idea. Going on, so we're going to talk about a few more advanced features of Scala. One of these being monads. So there are a lot of examples of monads in Scala, and I'm just going to talk about a few. And the examples of monads that I'm talking about here are option and either. So you might have encountered these in other functional programming languages, but the idea of an option and an either, the embodiment of that philosophy is that you can check errors through types, which means that you never have to check if something is null if you're using the option monad, or check if an error is thrown if you're using the either monad. The type has support for basically two options. In the option case, it's none, meaning that the variable was null essentially, but it then becomes a type of none, or a sum if there actually was a value assigned to that variable. So an example of this, might be, say you're parsing some JSON, you've got some fields that may or may not be there, and if a field is optional, you would want to assign that to a variable type option. That way, if the field is passed in, it becomes a sum, and if it's not there, it becomes a none. And then all of your higher level order functions are defined for these monads. So you could map over a sum, and basically the map would only execute the code in your map block if the value was defined. And a none would mean that the map block would never be executed. And the same with either. So say you're parsing some JSON again, and you've got a required field that needs to be there. So you parse it, and it throws an error. In Java or another imperative language, you'd throw an error, and then you'd have a try and a catch statement. But in Scala, the philosophy is that you want that error to be embodied in the type. So you can you would instantiate that object to a type of either, and if the required field was not there, you'd throw some error wrapped in a left that would be, field X is not available. But if everything worked out and all your required fields were there, then you would initialize it to a right. So again, one example of this is, say we had an option of type called O, and it's a type of option of string, and we've we set it to sum of hello. Oops, that was a mistake. Okay, so here's O, and then say we had something that was an option of string as well, but there was, there's an error, so we call it a none. So now all of our higher level functions are available, so we could say o.map, let's say hello plus goodbye. Live coding, always fun. String, so let's give it a two upper, I think that'll work. Nope, maybe two uppercase. Okay, let's say, give it a print line. So for each print line, hello. Okay, well, I'm striking out here, but let's do another example. So if we had a type of int, of some one, and then we map over that in the same fashion, and we say our wildcard is the variable we're iterating over, and then we'd say +1. So now we've got a sum 2. But if we have a case of none, for example, if our option of int is not there, and then we do a map over it in the same fashion, it's still going to return a none. So you can see how that enables you to treat the none or the sum option in the same way. Cool. Lastly, another really nice thing about Scala is pattern matching. So you can use pattern matching to unpack types or use them for if statements. So in this example, we've got a function what that accepts a type of any, and the type of any could be a int, string, or any other type, because any is the most generic type. and we want to use this like a switch statement to print or return a different string depending on what the type is. So if we have a what, or if the what definition accepts a int, then the case of int will be called and it's going to return it's an int. However, if the type is a string, then it's going to return a string that says it's a string. But you can also use this for other types. So going back to our REPL, say we had our option of int, right, from before, so res5 is a sum of 2. So if we matched our option against a case of sum b, and let's say we want to return an int, so we're actually unpacking the integer out of the option. And then we'd also handle the none case, so we'd say none is, returns a type of 1. And now we execute that code, and as you can see now, the match statement has returned a integer of 2. So what happened was our sum was matched against a type of sum, and since that match succeeded, it just returned the b, which is the integer nested inside the option. Cool, so that is an example of how to use pattern matching. That's all I have for examples today. There are a lot more examples in the GitHub repository. But finally, I'm just going to talk about like some really awesome tools that can be used in Scala. So at Tapad, we use Apache Kafka, Scalding, and Spark for a lot of our distributed, basically Kafka for our messaging queues and Scalding and Spark for our Hadoop jobs and data pipelines. These 3 open source libraries are all written in Scala and are really, really good for these types of problems. So if you're interested, I would highly recommend checking out these 3 libraries because they're awesome. Yep, and that's all. So you can tweet at me at ev_andcasey, and also let me know if you're interested in working for Tapad. Thanks.
Hey guys, I am Ben Drucker. I'm going to talk to you about building applications in the browser with Angular. I know it's a super popular technology, so we'll dive in a little bit. Quick 30-second sort of overview of me. This is my Twitter handle if you want to reach me. I work for Valet.io, a company that I founded that does fundraising for nonprofits. We help them use mobile technology to collect donations in the room at their big events. So we use Angular super heavily on the front end. I probably am like the single largest publisher of Angular modules at this point, and Node on the back end. So I do all JavaScript and all Angular on the front. So I want to quickly cover what exactly Angular is, because it's kind of in this nebulous spot where it's not quite a full-on framework the way maybe Ruby on Rails is, but it's still really useful. So it describes itself as a toolkit or a tool set, and ultimately that's not super useful for someone who's approaching it at the beginning. More crazy quotes from the founders of Angular. Basically, Angular is this sort of in-between bit that solves some of the hard problems in JavaScript and kind of gets out of your way for the rest of it. So what exactly are those problems? So Angular doesn't really get in your way when it comes to models, so there's no sort of active record-esque thing in Angular. Your models are plain old JavaScript objects. You can put together your own ORM and do all of that stuff if you want. If you want to just throw plain old object literals onto your scope, you can go do that. Angular really doesn't care. Template-wise, Angular uses this sort of crazy HTML syntax where you're not compiling handlebars or doing anything like that. It's HTML basically with its sort of own little extensions on it called directives, and those can sort of handle all kinds of behaviors declaratively from your actual markup that you'd normally be like diving into jQuery for. And the last is the chunk that basically glues 1 and 2 together, which is this $scope concept, and having sort of this hierarchy in your templates. So just quickly looking at what some simple Angular stuff might look like. We have all of these ng things around, which are directives, but then also some directives that don't have special prefixes. So required, for example, is actually sort of adding some special behavior that Angular deals with. So you sort of have to know what's going on. There's a lot of implicit sort of behaviors being added, but it can be really powerful. And then these double curly brace mustache expressions where we're just multiplying a quantity and a cost, running it through a filter. So this looks like HTML. It's easy to generate via something like Rails, and it's really simple to work with. We're not going to go too much into this, but directives are basically every crazy thing that you see in the HTML that's not plain old strict HTML, and you can do all kinds of stuff. It's very powerful and also very hard to grasp. So, and lastly, why Angular versus, let's say, doing jQuery? Like, if you're asking, why can't I just grab jQuery and listen on some click events, listen on some hover events, and deal with everything? When you're going one way, you have to listen for all these things, render your views, send them out, and that's fine when your application is tiny and does 1 or 2 little things. When your application does lots of things and gets very complicated, you really want this version to a data binding where you have lots of form fields and all kinds of complex logic. You want to be able to change a form field and have your actual object in JavaScript be updated, and vice versa. And Angular's sort of toolkit, if you follow the way it goes, will do this all automatically for you with no special stuff. $scope you'll see a lot. It's worth reading up on if you want to know more. Basically, the way Angular does what I just talked about, sort of not having a set method, not having fancy things like that, but managing to update everything dynamically, happens via this $digest method, which basically runs through all of the stuff on your scope and sees if it's changed. If it's changed, it goes and updates the DOM. And so it's complicated internally, but you get to go build stuff right away that works and updates automatically and looks really cool, and you don't have to know really any of the details right off the bat. Lastly, Angular does have an abstraction for sort of data-oriented stuff that might be reused in different places. So they're called services. The terminology is very confusing, but you'll see these common built-in ones, $HTTP being a super common one that maps over XML HTTP request and makes it nice cross-browser and returns promises and does all kinds of nice stuff for you. And so you can inject those, and we'll look at that. So easiest way to demonstrate all this stuff is just to go start writing some code. Are we stopping for questions at any point from the chat? Okay, at the end. All right, so I am going to install Angular using NPM, the Node Package Manager. If you want, you can download it off the website. You can use Bower, but you should do this if you're comfortable with NPM. And so we're just going to install it and then just get a little HTML file going here. Oopsies. Have to save it to the right directory. Okay. So one of the nice things about Angular is that you're not doing too much more other than dropping in a few script tags. So we'll also make our little application and get going here. So just creating a simple Angular application. And at the end of the body, we're just going to drop two script tags, one being our application, and actually before that, Angular itself. So okay, close that tag. Save it up. Okay, and then within our actual application file, what we're going to do is Angular is a global since we've included the script before. And we're going to create a new module, passing an empty array as the second argument without the empty array. People trip up on this a lot. If we just do this, you're basically saying there's already some module called LHD, go get it. So instead we want to create a new one, but we have no dependencies. And then we can just leave that there. Alrighty. So let's just pop this open in the browser. And we can see that everything is loaded up. So we're actually going to add a little tag here that instantiates our application. And we're going to add a controller here as well. Okay, so both of these ng attributes are directives, so you don't really need to know precisely how they work, but Angular is actually parsing through this HTML document, looking for attributes that it's been told to look for, and then going to your code, finding the appropriate application, finding the appropriate controller, and setting it all up. So now we'll actually add this controller. And inject a scope. And pop a little message on there, and then display it in our body. So let me up the font size a little bit. So now we have something that we attach to the scope of this controller. That's now available sort of inside hierarchically below the particular HTML tag, the DOM node, where we added the ng controller directive, and we're grabbing this attribute. We can do many more interesting things though. So instead, let's drop an input tag in here. And we'll use the ng model directive, which will do two-way updating on some property on the scope. And so we'll call that name. And then we're going to change this around a little bit. So our greeting is hello, and then we'll say greeting name. And we're able to update that input in real time, see the changes reflected, and it's that easy. So we can do all kinds of complex things here. So if we add a little required attribute, you won't see anything meaningful here change, but we can very easily add something. So we're going to give this input a name. And actually wrap it in a proper form, which also has a name. And then we want to warn the user when this particular form has some invalid attribute, or actually the field itself. So you saw the ng prefix directives before, which are really obvious. There are other behaviors that deal with what seems like just plain old HTML that's not as obvious. So Angular inside your forms is actually going to parse through the names and publish the basically internal controllers for these inputs, for the elements rather, onto the scope. So we can actually go use this stuff. So I'll show you. So if we wanted to say, for example, here, we're going to use an ng show directive, which takes an expression and displays the element when the expression evaluates truthy and hides it when it evaluates falsy. So we only want to show this error message when nameForm.nameField invalid. I'm going to say, oh no, you need a name. So we have an error message here, and then when I actually fill in my name, that portion is hidden automatically. So you can already start to see this is pretty simple behavior, but doing something like this with jQuery and having to listen on all of these key up events and things becoming unfocused and all kinds of crazy complexity would suddenly turn into a ton of code. It's not that there's no code here, it's just that Angular is dealing with all of these incredibly common patterns in HTML user interface design. Okay, so let's see, what else can we cover? So let's actually build up a slightly more complex form here. So I can actually grab an example from something that I worked on this morning, which is What we're going to do here is have a user enter their zip code, and we're going to go get the city and state that they're from. So I work on payment processing, and this is a super common mistake that people make in their interfaces. There's no point in collecting a city and state. You can get those from the zip code, and so let's actually look at what it would mean to go do those things automatically within Angular. So we call our form zip and get rid of all of this other stuff. And then we are going to have an input for our zip. And it's required. And then we're going to have a button that submits the form. We're going to call that lookup. Okay. And then what we can do is actually pass something to this directive called ng-submit, which will listen on the submit event for the form. That event is fired by somebody clicking on the button. That's just how the browser works. You don't have to worry about it. And then we're going to call something on our scope called lookup, which we will actually go code. Oh, we'll need to add model. And actually, last thing before we continue, we don't want you to be able to click on the lookup button if you haven't put in a zip code. And so we're going to pass this ng disabled directive, and it's going to be disabled when, let's just call it zip form, when zip form is invalid. And so we can just look at this. So we have a disabled button because the form's invalid. You'll see if I type in something, the button becomes enabled. Obviously, you would want to do some length filtering on that zip field, but let's go actually write some code to go look this up. So the service I'm going to be using, it's called Ziptastic. It's a super easy API here. So we'll just grab this little example. So in addition to a scope, we're going to need to inject the $HTTP service, and then we'll define our function here. Actually, just to make this easier on us, we specifically want to look up the zip. Put a result up here so we can set it later. Okay, so we just want to make a GET request and pop on our zip model, and when the response comes back, we're going to set scope.result to the response data. And should be good. And then below the form, we're just going to display our result. So we're going to look up my zip code, and there you go. So in a total of 10 lines of code, we're looking up a zip code using an HTTP service. This will even handle errors as well. So we could drop something on here and somehow deal with the error that comes back. So using next to no code, we have some super usable UI sugar. Okay. So I'll just delve in actually briefly how to sort of format some of this stuff more meaningfully. So here. And then we're going to use these double curly braces and say results.city. And we'll use the state as well. Oops, wrong tag. Okay. So again, looking up zip codes. Whoops. Always fun to break something. Oh, would help if we name our variables properly. There you go. So yeah, every time you add the slightest bit of complexity, we can go back and look at what it would take to deal with this kind of thing using jQuery. So managing all kinds of templates, putting potentially IDs in these fields and all kinds of spans so that we can go insert the data later. Letting Angular do all of that for you is dramatically easier, and unlike an alternative, let's say Ember, this is very easy to get started with, but will also stick with you as you start to build large, complex applications that need a ton of testing. That's why I use it, and that's why I recommend it, because you can get started and then continue building your skills over time, but just build stuff even if it's a little wonky from the start. Just tell them, flag me at whatever point you want to start questions.
Cool. So, questions. Where are the best places to go for Angular resources for people who want to learn more?
The tutorials at thinkster.io are pretty good. I know people like the Scotch stuff as well. I would caution you against going too crazy using open source modules, or at least take a look at what you're getting into. There are lots of things. I'm somewhat biased because I've rebuilt a lot of these things myself, but for common tools, Stripe, stuff like that are really horribly written and will encourage you to use really terrible practices. So have at least some sense of like what's good and what's just going to get you sort of crossing off a feature, and at least make that decision when you're going to build something.
Are there any like prerequisites of things people should learn before learning Angular?
Yeah, I mean, you should definitely have solid familiarity with HTML, no question. It will eliminate the number of lines of JavaScript that you need to write by a whole lot, but I wouldn't say at all it's not like liquid, it's not a templating language. It's going to be a horribly painful experience if you can't write JavaScript. The point is to simplify the common things, to not have to be writing logic, show this when some condition is truthy, hide it when it's falsy. But ultimately, if you're writing a sizable application, anticipate writing like thousands of lines of code and thousands of tests to make sure it works.
Obviously, there's like a ton of choices these days in terms of like JavaScript frameworks.
Mm-hmm.
Like why Angular as opposed to some of the other ones, and like are there like so like if you find yourself using like a need for Rails, like there are certain times that Rails obviously makes the most sense. Like are there certain situations that Angular makes a lot of sense?
Yeah. So I think it's easier to say when Angular doesn't make sense, because there are very few cases when it doesn't, and I think people tend to overestimate how often their applications fall into that bucket. If you're dealing with large volumes of data changes and highly complex interfaces, maybe games sometimes fall into this category, or crazy stuff. React is worth looking at in that case. Everywhere else, React just isn't that mature yet. You're going to be spending a ton of time building things from scratch. It's also a much lighter weight tool, React is. So you're expected to compose lots of things. Angular still has that expectation, but gives you just a little bit more out of the box. Ultimately, if you're not comfortable sort of architecting large APIs from scratch, you really don't have any business using React. Angular will help you get over that hump, and that doesn't necessarily mean that it's good in the long run. It just happens that it's very usable for large applications as well, and that's why I feel like it's worth investing time, because it's not a tool, Rails, for example, that you might dump as you deal with something more sophisticated. With 90% of applications that you're building in the browser, unless it's crazy like amounts of data changing, you're just going to be able to stick with Angular pretty much forever.
Cool. Any closing thoughts right here?
Yeah, try to read as much good code as you can. It can be harder with applications like this. Angular is still new enough. There's not a ton of open source Angular applications available the way that you might be able to find a decent number built in Rails. I have a lot on GitHub, probably at least a dozen like reusable components that you can go try if you want. But I mean, more importantly, like when I would distinguish between like the Google engineers who write about this stuff versus some random dude on the internet. You can probably trust like Thinkster and maybe Scotch, but something that's flexible, ultimately people have their own preferences and their own ideas about, and the fact is 80% of them are going to be wrong. So just be willing to be patient and refactor things a lot, because it's just a lot going on. It's a lot to manage. So you're going to get it wrong and have to fix it, and that's okay.
What's up, local hack day? This is Sam Agnew. I'm the order in dev evangelist, back here to give you a talk on APIs 101. So, my elbow, damn. So we're gonna try to keep this. I'm gonna try to keep this super noob friendly. Like this is very much geared towards people who are like brand new to hacking, who just like want to learn how to build stuff. So APIs are probably, if you've written code before, it shouldn't be too much of a new concept because APIs are everywhere. It's nothing new. I know you hear about like, okay, like, oh, there's the ordering API and there's Twilio, and you hear people doing all these cool things, but at a very base level, they're just, an API stands for Application Programming Interface. So it, pretty much all it is, it lets like one computer program talk to another computer program. So, let's get into this. So, your language has an API. Like if you do Python, like you want to import modules and stuff. That's an API. If your frameworks have APIs, like if you have code interacting with someone else's code, that's the basic idea. But the most common manifestation of this, when you hear people talk about it at hackathons, is RESTful APIs. And if you were listening to Kaushal Parikh's talk on web programming earlier, you should know that REST stands for representational state transfer, and it's pretty much a way of like communicating like via HTTP. So let's get started with sending some HTTP requests, because that's the most basic thing that you're going to want to do when you're trying to bang out some code. We're going to use an API that our buddy Shai, the organizer of Local Hack Day, made called bearcatfacts.info. It's one of my favorite websites of all time. As you can see, bearcats have a prehensile tail. Isn't that beautiful? Let's see another one. Not every bearcat gets high from catnip. Whether or not a bearcat responds to it depends on a recessive gene. No gene, no joy. Okay, so as you can tell, this URL that you visit just generates a random fact about bearcats. Why bearcats? I have no idea, but we'll have to ask Shai. So what's happening here is your browser is sending a GET request to bearcatfacts.info, and some server's responding by giving you this text. So what we're going to do is we're going to try to get this text programmatically, which is should be pretty simple. So I'm going to use Python. That's a pretty common language that everyone loves, and I'm a big fan of it. So let's bang out some Python. So I'm going to start bearcatfacts.py. Seems like a reasonable name. So whatever language. What's up?
Zoom in.
Oh, I should zoom in. You should be right. Is that good enough? Can you see that? Cool. Even more. Make this nice and toasty here. All right, cool. So whatever language you happen to be using generally has a way of sending HTTP requests. In Python, we have a library called requests. So we're going to import that library. So what we want to do is we want to send a GET request to bearcatfacts.info. So you can do that by just saying request.get and then giving a URL. So http://bearcatfacts.info. So what this is going to do is, this is super simple. You can see in 2 lines of code, I already wrote something that's going to interact with something on the internet. And it's pretty revolutionary because at its core, like you can just build a cool hack out of that, like out of just communicating over the internet. So we're going to print this here. And you're going to see that we're going to be sending a request. So let's run that real quick. Let's see if we can get a bearcat fact printed. Okay, so it's printing this right here, response 200. That means that we got a successful response from the server. So what I'm going to have to do is .text here, because this request.get is returning a request object. And in the request, there's a text that we can print. So let's see. All right, bearcats are the reason why Waldo is hiding. That's cool. I didn't know that. Bearcats take between 20 to 40 breaths per minute. It's a lot of breaths. I don't know if that's pretty crazy. Bearcat's brain is more similar to a man's brain than that of a dog. I didn't know that. I don't know if these are true, but I hope they are. So, you know, this is a super simple. We just printed something on the command line, and it's a Bearcat fact. And you can do anything you want with this. You can let's put that in a loop. Let's make a for loop. So let's print out like 10 Bearcat facts. That'll be pretty tight. So what this should do, so you can do anything with this, right? Let's see what this does. See, it's printing out a bunch of Bearcat facts. Bearcats do not sleep, they wait. You should own a Bearcat as a pet. I guess that's a fact. That's not an opinion. All right. What do you think about that, San Diego? Okay, so you could store this in variables. You could be like fact equals blah blah. Like you can have an array of Bearcat facts. You could say like and then we can print out like our array. So let's see what happens here. We're just gonna have an array of Bearcat facts once all the requests run. Okay, so look at that. So you know, once you can send an HTTP request and get data back, you can do all kinds of crazy stuff with it. So I'm gonna talk about something else real quick. So right now we're just getting text back from this API. Like you send it a request, it gives you text. But there are other forms of communication. Like you're not just gonna get a string every time you use an API. So I'm gonna use the Order-in API as an example, just because I work for them and that is something I'm familiar with. So this is our API Explorer right here. Let's check out this one, delivery list. Okay, so this is a little bit different because you have to have an API key. So there's this thing that there are tons of APIs out there. There's Twilio, there's SendGrid, there's Order-in, and for a lot of them, you're gonna have to have an account on whatever service they're using because you don't just go to a URL for all of them. So I already have created an API key for Order-in, so let's check that out. You can all look at this and be evil and steal my data or whatever. So we're gonna send a request to the restaurant API. So what we're gonna do is we are going to give it an address, and it's going to give us all of the restaurants that are delivering to that address. And we can do this in the browser too, because this one is just a simple GET request like we were just talking about. Okay, so I'm gonna go to, this is the r-test.order.in/. Okay, so these are the documentation. This is the documentation. Usually when you're using some web service or some form of API, they're going to have documentation on their website. As you can see here, we're just at hackfood.order.in. And this is the delivery list endpoint. So we're going to go to /dl. This is just a web route. This is just you're going to add this to the URL. So we're going to go to /dl. I guess that stands for delivery list, huh? /datetime. Datetime means I'm going to put ASAP, which means we want food now. So ASAP. Zip code. Okay, I'm gonna give it the old Order-in office because that's just, I can see I already typed this in at some point because that's just an address I happen to have memorized. It's just in my brain forever. Okay, so I'm gonna give it the zip code, the city, the address, and that is this right here. So when I enter this URL, I'm not gonna get any data, even though we just looked at the documentation. That's what it requires, but there's a little bit more to it than that. So this is because this isn't just Bearcat facts, right? So this is gonna say unauthorized or something. Okay, error code 401. So what I gotta do is, as I was just talking about with the API keys, earlier in their documentation, you have to authenticate, right? So we're gonna add this query string at the end of our URL. So this is we're just sending some variables in through the GET request right here. This isn't really something you need to worry about. It's just you can copy and paste it, like there are instructions right here. But this is where I'm going to paste my API key right here. And you're all gonna see my API key and be able to do terrible, evil things with it, but not really because it's not in production, so cool. All right, let's copy and paste that. Throw that in here. magical stuff, isn't it? All right, so now you're gonna see a big blob of stuff. All right, it's beautiful. All right, so this is called JSON. So a lot of APIs will return, they'll communicate their data in some way, shape, or form, right? So JSON is just some serialized method of like representing data, right? There's other stuff, there's like XML and whatnot, but we're gonna stick with JSON for now. So this is just a JavaScript object notation. If you've ever written JavaScript, you'll notice that it looks exactly like a JavaScript object, hence the name. And we can look at the data here. We can mess around with it. Zoom in a little bit so it's clear. Okay, so this is just a list of restaurants. This is Eisenberg's Sandwich Shop. It has a restaurant ID, has a name, has a phone number, all that stuff. You can all call them right now, I guess, but that'd be rude. Okay, so it just has all the restaurant information. We can get this programmatically. I mean, so the example I just showed you used this URL, and we can even just straight up, we can even just replace this URL right here if we want. Such awesome Vim through, huh? Cool. All right. Let's print that. We're gonna have to. Since we're getting JSON, this is just a method of the request object in Python. You're gonna have to look up some documentation for whatever request library in your language of choice, but this will print some JSON to the terminal. So all I did was I changed the URL that we were requesting, which is right here. So it's the same concept as the Bearcat facts, except we added a little bit of authentication in here because not just anyone is requesting this API. So let's see what happens. It's going to be disgusting. It's going to look absolutely deplorable. Look at that. That is terrible. But it is a bunch of data, and that's what we care about because we can do stuff with this data. And that's what we're going to do. So let's look at this. We can inspect the data here. So we can print out the name of every restaurant, let's say. So this is just a Python list of restaurants. We're also going to have to serialize the JSON. So I'm going to do JSON dot. Is it JSON.loads or JSON.dumps? Which one is it? .load. Well, yeah. Just real quick. I keep getting those methods confused. JSON Python. Super simple. So this is just an example of when you're coding, you're just going to look shit up. So JSON.dumps, that dumps some JSON, and decoding JSON is JSON.loads. Okay, just wanted to double check before I did some stupid stuff. Okay, so JSON.loads is going to take this big blob of text inside the parentheses, and it's just going to convert it to a Python object, which is going to be a list of restaurants. So let's check to see if that works. Our file name is still bearcatfacts.py, but whatever. Okay, expected string or buffer. Okay. I think it wants. Is that JSON, not a string? Let's see if that works. Value error, huh? That's terrible. Okay. Am I doing this right? Well, whatever. So as you can see, we have this JSON right here, and we can mess around with it. But most APIs don't require you to use HTTP requests. For example, the order in API has a Python module, which is documented right here. It's open source, because open source is awesome. And we can install it, pip install order in. I already have it installed, so we can just import it right here. And instead of using HTTP requests, we could just use our Python module that already has all that extracted away for us. So I'm going to import order in, and I'm going to copy this line right here, which is just the setup line for the API. So for servers, I'm going to give it our test server, which is ordering.test, and I'm going to give it my API key, which you've all seen me copy like 3 times now. All right, so let's take that giant hash, the beautiful hash, copy that. Okay, so now we can just use this order in API module to call these endpoints. So instead of giving it a big URL and getting a bunch of JSON from that, we're just gonna call a function in Python, and that's about as simple as it gets. Because usually, you import things and you just use them. So let's delivery list. That is the API I was using. Okay, so let's look at the documentation. Delivery list takes, as we said, the date time, the zip code, and the address data and stuff. Where is it? Right there. So we're going to give it the exact same arguments we gave right here in the URL, but in string form in Python. So I'm going to say ASAP. I'm going to give it the zip code, or the address. So the address was 902 Broadway. Going to give it the city and the zip code. So the city is New York, and the zip code is 10010. Okay, so let's see what this does. This should print a big giant dictionary. It's printing out the, yeah, there we go. So that is just a ton of data, and it's already serialized. So, because the API is just, this Python module is just a wrapper around our REST API. So you can do a ton of stuff with this. You can do restaurants equals that, and then loop through the restaurants. So let's do that. So for restaurant in restaurants, let's just print the name. So restaurant. So what I'm doing here, this notation is just a dictionary in Python. So each restaurant has it's like a key value store. So if you look at this right here, NA corresponds to the name. So if we try to access that element, it's just going to print the name. So we're just going to print the name of every restaurant that is delivering to 902 Broadway in New York. And I see that I clearly spelled Broadway wrong. So let's fix that. All right, so now let's see what this is going to be. So it's sending a request, storing things in the restaurant. All right, cool. So now we have a giant list of restaurants. Look at that. The Loop, Lou's Baguette, Blue Dog Cafe, Becca Sushi. There are a lot of restaurants in New York, let me tell you. Okay, so take a little stretch. So you can see we're already getting a ton of restaurant data. Like, that's cool. We already have the names of all the restaurants that are delivering here. We can do a ton more too. We can go through their menus and everything. So let's mess around with that. So we can give it a restaurant ID. Each one has a field called RID, I believe, or just ID. So let's print all the IDs. Cool. These are just a bunch of numbers. So let's just take this one. Let's find out what restaurant that is. Okay, so instead of just finding out what restaurants deliver to us, let's take a look at the menu. So we have another endpoint called restaurant details. And that will, that you just give a restaurant ID, which is the one I just copied and pasted from the terminal. And it gives you all the data on that single restaurant, like the menu and stuff. So I have no idea what restaurant this is, but we're about to find out. All right, cool. So let's run that and see what happens. Okay, so as you can see, this looks disgusting. We can use the API Explorer to do the same API request and have it not look disgusting. So I'm going to click on restaurant details, and I'm going to give it that same ID. And now we can mess around with the JSON. Cool. So it's 11th East 20th Street. It's in New York. Here's its phone number. These are the cuisines it has. And now we can look around at the menu, right? So we can see like, okay, breakfast. What's in breakfast? What's for breakfast? Let's find out. Oiko's 0% fat yogurt. Cool. So you know we already have menu data. We can do a ton of things. Like APIs are pretty versatile. There are a ton of them out there. I've only showed you 2 of them. I've only showed you Bearcat Facts and Ordering, but you know every major service pretty much has one. And if they don't have a public one, you can reverse engineer some things and figure out what they're doing internally. So like you know, if you wanna order food, you could use Ordering. If you wanna send emails, you can use SendGrid. If you wanna like send text messages or receive phone calls with your programs, you can use Twilio. There's just so many cool things out there. I would say you should check out this website, programmableweb.com. Visit. They have a ton of APIs. Like you could just go check out what kind of cool stuff is on there. Like Facebook implements mobile app ad enhancements. Cool. Like you could just see a bunch of cool stuff on here. Like they have a directory. Pretty much like anything you're looking for, you can find, right? Like you can see they have Twitter and all that stuff. But yeah, like it's the internet. There's a ton of things out there. There's a ton of data that exists out there on the internet, and you have access to all of it. Like pretty much, as a programmer, as a hacker, you are like a modern day wizard. You can, if you have an idea, you could just make stuff happen by like there's an API for everything. You can go like. You have an idea, you can just bring it to life by finding like something that does most of the work for you, and that's pretty much like the power of what you could do these days. Like as a developer, you just have so much power, and APIs are the things that give you all of that power. And I think that about covers it. I was trying to keep it super basic. If you need any like specific help, you can definitely hit us up with the live streaming. We're all mentoring out here. We have a posse together, and like this is all of it's documented on the web. I just wanted to give you a quick introduction to what APIs were and how they kind of work at the basic level. Definitely let me know if you have any more problems. You can all tweet at me if you need anything. My Twitter handle is sagnewshreds. Tweet at me and tell me what you need, and I'll respond immediately if I can. So yeah.
All right, questions.
Any questions?
First question. What is OAuth?
What is OAuth? Who said that? Who said that?
For me.
Oh, that was you? So OAuth pretty much lets you it's like another level of authentication. So it lets you do things with an API that you normally wouldn't be able to do via like sending HTTP requests. So for example, if you're going to use a Twitter API, right, you can use Twitter API to post like tweets and like to do things that you would normally only be able to do as a user on your account. So there are these, Twitter has like an OAuth API. It's like, it lets you authenticate. So let me find an example. So there are tons of apps, like you'll notice like Facebook has it too, that when you go to like use an app that is integrated with Facebook, you have to click like the Facebook login button. It's like, oh, like authenticate via Facebook, and then you click like, okay, authorize this app or whatever. And that's pretty much some developer is using OAuth for you to give them permission to use your profile data and to act as you or whatever permission you gave it. And that gives you a ton of awesome like things you can do also, because like, I don't know, you can just, you can have someone authenticate with Twitter and then just have them post tweets of Richard Stallman quotes or something. You can do a ton of hilarious stuff with that. We definitely check out some of those. I know like GitHub and Facebook and Twitter all have OAuth APIs that you can do a bunch of cool stuff with.
What are the worst APIs you know?
The worst APIs I know? Oh man. Would it be mean if I said Twitter? Oh, you know what? You want to know what? I mean, just because of the documentation. But oh man, that was a good question. Bearcat facts, obviously. You know, because Shy made it. Like, what is this? What is this garbage? British Bearcat owners spend roughly 550 million pounds yearly on Bearcat food. Is that true? I don't even know if that's true. That's terrible. There's also oh man, I'm really blanking out on this. There's like one really bad one that I complain about all the time, and I don't even remember. Let's find out. Terrible APIs. The good, the bad, and the ugly of REST APIs. Let's see this. Let's see what the internet thinks. That's what you do when you don't have an immediate answer. You just Google something. REST is good, SOAP is bad. Okay, I can get on that. Let's find out the ugly. Oh, I don't think this is specific APIs. This is just bad stuff about them. What do you think is the worst API, Swift? You have a ton of experience in that.
I have no opinions.
Yeah, that's a stacked question. I probably shouldn't mention it. When I said Twitter, I just meant because I was frustrated one day when I was using it. But you know, you can do a ton of powerful stuff with it, so that's cool. But definitely Bearcat facts. Say Bearcat facts 100%. Sucks. Shouldn't use it.
Any other closing thoughts?
I'm a bad person for even using it. That's all I can say. Like I'm gonna go stuff my face with pizza and cry myself to sleep after that one. Gotta
Where's Jason? Show me Jason.
This is Penn State we were talking to.
Hi, Penn State.
Show me Jason right now.
Do you want to see Dan's?
That's stepping
He
off.
made something pretty cool.
We've heard a lot about this Oculus Rift that is portable. I want to see it in action.
Dude, hold on. I just gotta find something to run.
Okay, so we're putting it in a backpack. That's why it's portable right now. I don't know how it's working.
It works.
Can you see it? You can see the backpack, right?
I can see a backpack.
There's a lot of wires.
There's a ton of wires. Every time you lift it up,
the backpack.
So
That's not even true. Shut up. You don't know anything. You can't prove anything.
I literally just saw you say like.
All right, let's just do the typical little Tuscany demo thing.
Tuscany demo.
Backpack and make it portable.
You're seeing videos.
Has he crashed into any walls yet or tables?
No.
Not yet.
No.
I use my PlayStation 1 as a CD player.
I kind of want to call you out on that.
Oh, awesome talk about the APIs, by the way. That was
thanks, dude. I'm just glad I got to trash Shy.
You're driving traffic to Bearcat Facts, though.
Yeah, I am, dude. It's all a part of our diet pill pyramid scheme.
Like some of them might be true, but then the thing like the what?
So like, are those
the one about the dinosaur?
20% of them actually go out to the Chuck Norris API, replace Chuck Norris
that
with the
makes
word
so much
Bearcat.
sense. Dude, I was like reading them out loud, and I was like, what? There's no way that can be
So
right,
about
like-
60% of them are real Bearcat facts.
Okay.
The 20%.
And like 40% are just like made up funny jokes.
Does it say that in Chuck Norris facts?
No, but he said that in talk as well.
That'd be funny if Bearcat Facts picked that up and replaced it to the guy who created Bearcat Facts. Doesn't like Chuck Norris.
You should do it. You should build this out. It's a real product. You should get funding. It's getting growth already.
Would you be a C-Day for me?
All right.
I would.
Oculus Rift is going in the backpack right
All
now.
right, it's going in there.
So what kind of backpack is that? Tell us about the backpack.
It's a Swiss Army backpack.
Oh wow, fancy.
Yep.
Lots
Wait,
of.
oh wow. I'm like actually on the YouTube thing right now.
Yeah, this is live right now. You're being
That's to 34 other schools.
Sure.
Does anybody ever use the word book bag?
No, that book bag is not.
You're in Philly, right? People in Philly say book bag, don't they? Water ice, bagel, right? You hear the Delaware County accent, right?
Yeah.
That's I grew up there, so we were just making fun of it outside. How about Jimmy's? Do you say Jimmy's? Does anyone say Jimmy's?
Sprinkles.
No, I know it's sprinkles. I say sprinkles, but people in Philly say
There aren't that
Jimmy's.
many like Philly people.
Yeah, but you're in Philly, so you probably see Philly people in your day-to-day life. Like,
So right now it's plugged in though, right? Like, so the idea is you're gonna put like a battery.
Plug it in because the battery died.
Got it.
Sounds like we called it the wrong time.
does it take? It takes AA batteries.
20 minutes ago when it was kind of working, but
There we go.
Is this the same room Hack
now
PSU
it's
was
like
in?
kind of not portable.
Oh yeah.
It's like mostly
Because I recognize it from the pictures,
pseudo portable,
imaginary pictures.
basically not portable.
Well, we didn't hack there. But
I'll be able
like
to
the
walk
demo.
certain.
Okay, yeah, I saw pictures of that room and when it was done.
Yeah.
Wait, you guys should pitch Hack PSU for the
Yeah,
spring.
Yeah, I want to hear about Hack PSU.
So okay.
Actually, Albert, do you have a hat near you?
Wait. Put on a hat.
Yeah, dude.
You need a hat.
Gotta
You
get
need
the
a hat.
beanie. This is unacceptable. You can't talk to us without a beanie on.
Now we sit in silence awkwardly.
Yeah. I'm gonna wear this all the time.
It is Penn State's hackathon. It's a 36-hour hackathon. It's in the spring. The dates are the weekend of March 27th.
The dates are the weekend.
Yeah, the weekend.
The dates are the weekend.
The
Okay.
weekend of March 27th next semester. So we're sort of getting this to kick it off. Right?
Yeah. This is like our pre-run, so to speak. And we're looking to get 500 people or so. So anyone you might think of who wants to go, definitely go. We're education based, so like we have talks basically like all throughout Hack PSU, and
awesome.
they are on anything from like basic programming to Unity to like Blender, all these like really interesting technologies, because people here just know how to do random things. And it's great. And so
It's almost like people here go to school.
Yeah.
It's like it's at a university or something, right?
Yes, we have like this huge like push for diversity, where we're trying to bring like as many groups together that like are or underrepresented in the hackathon community. So you know, we're like getting all the like women in CS, women in IST groups together, and like all of the there's one called OSTEM, which is like geared more towards like LGBT community in programming, and that's another area that we're definitely expanding to. So we're hoping to bring a lot of really cool people to HackPSU.
That's awesome.
And yeah, I think that's it. Oh, and just in time, Dan's like
Show us the backpack.
Show us it.
Wait, tilt it up a little bit. Oh God.
This looks amazing.
That's a hack.
This is amazing.
Someone put a hat on him.
Yeah, put a beanie on him while he's expecting.
He needs a beanie and headphones.
And some foam peg.
Let's just turn him into a cyborg.
Yeah. Wait. Yo.
Yo, I want to go bungee jumping.
Yes.
Beautiful. Look at that.
So we're like getting all the like.
I want to know how far I can go.
Okay. You gotta turn the computer.
How far can you
Turn the computer.
We can't see him.
We can't see.
Can you still see him?
There we go.
There we go.
Water.
What is he doing?
Yeah, wait. What?
You gotta talk to us.
Tell us what's on the screen.
What's on his screen? Yeah, we're just looking at some guy walking through the Oculus. It's like, it's portable, I promise.
Yep. It's virtual, but you can still run into walls.
I can still run into walls.
Yeah. Dan, what are you seeing right now?
Yeah, what do you...
Oh, Italy.
Italy.
I don't know.
Italy?
If I've ever been. I'm kind of, it's a vacation spot for me.
Yeah.
How do you feel about the architecture of the house that you're looking at?
It's kind of
Dan,
a little disoriented.
Dan, they're asking how you feel about the architecture of the house that you're in.
Yeah, where in Italy is it?
It's the Tuscany demo.
I could have built a better house.
Could you build it better in real life or in virtual reality?
Both.
It's a bold move right there.
Well, be sure to tune into our Unity Rift Talk at 5:30 for everyone who wants to learn how to make a better house in the
Tuscany demo.
Wait, is that actually
right
going to be part of the talk, building a better house?
So.
That will actually be part of the talk.
We should probably.
All right, let's go.
Thanks, guys.
All right, bye,
Great
guys.
talking to you. I hope HackPSU rules.
You are up.
Yes. Oh, should I introduce myself?
Yeah.
Okay, so my name is Jack Cook. I'm a freshman at Brock Science, and I'm here to give the intro to iOS talk. So I'm going to do this by I'm going to teach the basic principles of iOS through the making of a calculator app. So I already have some code written. It's mostly just the logistical stuff that makes the calculator work. Okay. So if you click on the if you click on the project in the top left, well, actually, here, let me do this. In Xcode, you can create a new project with file, new project. You're mostly going to want to use single view application in most cases, unless you know what these are. You're going to hit next. It's going to ask you for your app name, organization identifier, and the language you want to use. For this talk, I'm going to be using Swift, and it's going to be an iPhone app. So in any case, here in the project view, I guess, you can see a lot of basic stuff about your app, such as the bundle identifier as shown right here, version number, build number, team. This is needed when you're deploying to the App Store. This is the version of iOS you want it to run on, the minimum requirement. iPhone, iPad, both. This is automatically set for you when you create a project. It's the storyboard of your application, which I'm going to get into in just a second. This is what orientations you want the app to be compatible with. For this talk, we're just going to be doing portrait mode. And then there's some other stuff that you can go through here. There's a lot of stuff in the info file. So yeah. In iOS, and the interface of an iOS app is largely centered around the storyboard. So what this is basically is it's like, this is representing a view in your app. You can create more of them by dragging out a view controller. There are different types of view controllers you can use. So here, this is going to be the calculator, essentially. So a calculator needs a number, I guess, that it displays to you as like the answer to the operations you put in and stuff. So here I'm going to make that number. So I'm going to set it to 0. That's what it's going to be when you start up the app. And just a couple of stylistic things. So here you can see I'm kind of modifying properties of this label right here. This can all be done in code, but it's very easy to do with the storyboard. So let's see. And then, okay, so yeah, here we can see the font, the color. I'm going to align it to the right. But yeah, so as you can see here, it's very easy to just create your app, essentially, what it looks like. And so in iOS, we have this thing called auto layout, which makes your app essentially compatible on several different screen types. So to modify the constraints of the view, I'm going to click this box on the bottom right, and so I can tell it I want it to be 40 pixels away from the top layout guide, which is right below the status bar. I'm going to uncheck that. It's going to be 16 pixels away from the edges of the screen, and I'm going to keep the height at 116 pixels. So this is always going to be true no matter what the screen size is of the app. So I can just add those 4 constraints, and then so we need the buttons on the calculator as well. For this, I'm just going to be using a view. I've written the code for it in this keypad view file, which I'm going to go through a little bit later. So I'm going to set the background. It's going to be transparent. Let's see. And it's going to fill up the rest of this screen. Right, yeah. So again, I'm gonna use auto layout so that it automatically adjusts to screen sizes, no matter how big or small the iPhone is. And this way, Similarly to how Android interfaces are developed, it adapts to any new iPhone that will come out and all of the existing ones. So this is where the buttons are going to be generated by the code in, which reminds me, to set a custom class of any of these, you can go to the identity inspector and set the class of it. So in this case, right here I have keypad view. I can set this to keypad view. And it's important that you set the model to the module to the name of your app. So now, this is a keypad view, which is provided by this class. So to initialize a keypad view, you're gonna have to override this required method and subclass UIView, which is provided by the user interface kit package in iOS. And so here essentially is all of the code that I'm using to actually generate the buttons of the calculator. Here we can see I'm defining the button. Here's the dimensions of it. And then this is looping through the sides and the top of the calculator so that I can get the different, when the buttons are in different places, they'll have different text on them. So one important method here is that I'm calling the add target method on button, which on the button constant, which in Swift you can use constants by starting with let. So let I equals 0. Well, I've already used I right here. So let k equals 0. This is just an example. In Swift, this is it can't be modified ever. You can modify the like the properties of it, but you can't actually equate it to something else. It'll throw a compiler error. So in Swift, if you want to change the value of something, then you should use var, which indicates a variable, and then you can redefine it as much as you want. So yeah, so I have a constant right here. And so by calling add target on a UI button, what this does is it will, when the button is tapped, it calls the calculator button method, which is down here. So what I'm doing here essentially is I'm looking at the subviews of the label and I'm looking at the subviews of the button and getting the text from the label, which I've just put in up here. So what I'm going to do later is check that text, and depending on what the text is, that'll be the function of the button. So one cool thing that iOS has is notifications, or notifications, sure, but in code it's kind of like pinging other parts of your app, where you can send out a ping and other parts of your app can receive it. So I can do this by using the NS Notification Center. When you're using NS Notification Center, you're always going to want to use the default center. And then you can post a notification named, in this case I'll use calculator button. And the object is going to be the button. You can set this to nil. In most cases you don't need to send an object. But I'll explain later that it is necessary that we put the button here. So essentially what this is doing, here I can run the app. What this is doing is it's saying whenever a button of the calculator is pushed, you can kind of tell the rest of the app that it's been pushed, and it'll respond accordingly. So here we can see I have this keypad view which looks blank in the storyboard, but the code here is generating all of the buttons that come up here, which, by the way, All of the code that I'm using in this talk is available here if you want to follow along or look at it later. Just to put that out there. Okay, so when I tap one of these buttons, right now it does nothing because the notification that I just sent out isn't being received by anything. So here what I'm going to do is I'm going to receive the notification. So I'm going to use this calculator button method. And it's important that you use the same name as the other, as the notification that you sent out, otherwise it won't be received. And yeah, so now the text in the button that's being tapped is being passed to this method, which then basically contains what the button should do. So again, this is a lot of logistical code. It's not necessarily something that needs to be gone through, but now that I'm sending a notification through NS Notification Center, it's being passed to this method, and whenever I tap, or in this case, click a button in the simulator, it will do something, or not. Never mind. Okay. I don't... Okay. This doesn't want to work. I'm not sure why this... Oh, okay. I was supposed to do that a while ago. So, to make this keypad and this label interact with the code, we're going to use something called an IB outlet, which you can either add by control-clicking directly into your code, which will pop up this screen, which, by the way, in Xcode, you can use this button to display the whole file, this button to display two files, and then choose which file you want to display here, and then this to view the difference between your file locally and remotely if you're using Git. So I can add the IB outlet. So here I already have it written, but yeah, so you can add an IB outlet to your code by control-clicking into your file, make a name for it. You're going to want to make sure it's strong and that it's an outlet, and then connect, and now you can use this variable in your code. So I could set the text of the label, for example, like that. And I have access to all of the other parts of this label that we could see right here in the attributes inspector, such as the font or the text alignment, and so there's a lot of things that you can do to. There's a lot of things that you can do with your IB outlets. Oh, I'm gonna leave that there. So I can hook up these IB outlets, and now they are interacted with the code that I've already written several times in order to perform the functions of the calculator. Oh my god. Okay. I'm sorry, I'm not sure why this isn't working, but I'm just going to pull my code from GitHub that is working. So now the buttons work. I wish I could explain why it wasn't working. But in any case, the rest of the stuff that I was going to go through mainly consisted of, for example, you can create a new class in Swift by declaring the, well actually, Xcode provides it for you. If you just type in class, you can hit enter, and it's already written out stuff for you. So here's the name of the class. This is its superclass. Here you can see I've used UI view controller. And then here are the properties and methods. I'm using you can also define enums pretty easily in Swift, such as that I've done right here. You know what? Just make the code a little bit bigger. So yeah, stuff like this in Swift, it's really easy to define. There's a lot of documentation online. Yeah, Swift is good, basically. So I think the other thing that I was going to get into here is app icons, right? So so here, if I go to the project, like again, I've shown here, you can modify a lot of basic information about your app. Stuff like an app icon, if you click the little arrow next to it, you don't actually have to add the files to your project. Oh, I may have lost my icons. Okay. The idea is, though, you can drag any image into these boxes, and as long as they correspond with the dimensions that it's showing you here, it'll take it. So, for example, 29 2x, that's indicating that it wants 2 times the 29 pixel icon. So this would take any icon that is square, and the edges are 58 pixels, basically. And so you can do that here. You don't actually have to add the files to your project. That's a mistake that you can make to add some extra megabytes to your app that you might not want. So try to avoid that, I guess. And so I guess another thing I was going to get into is when you launch an app, you see that it said calculator there. In iOS 8, it became really easy to modify what your app displayed when it launches, because when you generate a project, it creates this launch screen file. And so it's configured right here to show that launch screen file when it's opening up. So you can pretty easily change what is being displayed when your app starts up without actually having to use images as you used to have to do. I'm just going to remove constraints to remove the errors. But yeah, so here it's pretty much like a storyboard. It's just a nib file instead, and so I could add, well, I guess I wouldn't be able to tap that button, but just text, images, anything you want can go here and be displayed when you're starting up the app, as you saw briefly when the app started up. So overall, I mean, I'd say Swift is a pretty easy language compared, well, I probably shouldn't put it that way, but compared to other programming languages, it's very beginner friendly, I guess. It's a little less like, I don't know what the word I'm looking for is, but it's more just simple. The syntax is a lot nicer. You don't need, for example, you don't need parentheses around your if statements. You still need the braces. But just stuff like that makes it very easy to pick up as a beginner to programming. So iOS might be a good place to start. So I think that's all I had to go through. So if there were any questions that wanted to be asked, I might be able to answer them.
Questions?
So where are the best places to go for like beginner iOS resources?
Sure. So if you go to developer.apple.com, actually, you know what? So if in the iBooks store, this isn't necessarily for iOS, but if you just want to learn the Swift language in general, the Swift programming language, it's free. It's an amazing resource. It has everything that you'll ever need to know about Swift if you want to start learning it. But yeah, as I said, developer.apple.com. Apple, in my opinion, has some of the best documentation for their code. So if I'm ever having issues with my code, it's pretty easy to go to here and you can click resources, and if you're looking for iOS 8 or is that it? There's developer library. But yeah, I mean, there's a ton of guides here on just everything that you can do in iOS essentially. So I mean, this is a great place to go if you're just looking to get started.
Cool. Let's see, any other questions? I think we're probably good.
Cool.
Hey guys, I'm Stephen Liu. Today I'm going to talk about Node.js and how to actually use it and the ins and outs. A little bit about myself. I'm an engineer at Abacus. I basically do JavaScript. I breathe, eat, live JavaScript day to day. So I'll talk to you a little bit on how to actually write a Node.js application. So the first thing you need to know about Node is that it's different from every language that you're typically used to. Instead of running everything synchronously, everything about Node is non-blocking. So everything you can do in parallel, essentially. So an example of this is like this terrible PHP code, where when we get down to fread here, we have to wait for PHP to read that file into the variable. And sometimes that can take a very long time if you're doing like over a gig worth of data or more. And then at the end here, we're trying to get the contents of MLH. Unfortunately, both of those things don't depend on each other. So why are we waiting for reading in the file if we can just get the site at the same time? So this is where kind of like JavaScript comes into play, or like essentially what we're doing here is reading the file. That takes 2 seconds, and then printing the file, and then instantly we go to getting the site and taking another 2 seconds to print the site. And in theory, this blocking code would take about 4 seconds. So Node.js kind of brings in parallelism here. So instead, what we do is we read the file in here. And when we're done reading the file, we can print out what we read from the file. But at the same time, we don't need to really block on it. So we also do request.get for the site and print out the body of the site when it's done. So in theory, it looks something like this, where like the single event thread is in the center. So we read the file, and then we essentially tell Node.js, when I'm done reading the file, I need to print the file later. And then right at the next second when we execute the read file function, we get the site, which also we say when the site is done being pulled in, we need to print out the site. So if those operations both take 2 seconds and we can do them both at the same time, this non-blocking code takes about 2 seconds. So the key takeaway here is you never need to wait for I/O. Input outputs like file reading, getting data, requesting data, or doing anything of that sort. You can run multiple I/O operations without blocking each other. So if you really want to follow along to my next part on how to write code in Node.js, you can just like go to this link. There's a lot of different tutorials out there that can tell you like how to get Node.js installed into your machine. But I'll skip that part because it's kind of boring. So we're going to talk about how Node.js pulls in certain modules and how you can create your own modules. So the first example is you can use require. So require is built into Node.js, and there are several modules that Node gives you. FS is file system. That is one of the modules that Node gives you. So an example of this here is like we require the file system and put all of its functions into the variable FS. Now I can create other modules too within my app, but I have to put the // to refer that it is in my current working directory. If you don't, it's going to try to look up the global module list. You don't need the .js extension, it'll automatically append it to you. And you can also refer folders, but inside that folder, you must have an index.js for it to work. So we just talked about pulling in modules. Now we're gonna, I'm gonna show you how to actually like create a module. So an example of this would be like if I create a name.js, I can use module.exports and place a function into there. Anything you place in module.exports gets exported to wherever you use it. You can put objects, you can put variables. In my example, I'm doing a function. To use it in another file, you simply just use the require statement that we just learned about and execute the function at the end. And so this would actually output my name is Stephen Liu. Cool. So let's build something a little more complex. And along the way, I'll tell you what like roadblocks we'll like put in, so that way you can learn a little bit more about Node and all of the different things. So the first thing is we want to obtain an array of keys, in an object. That last part is wrong. So here's a very small example. So like I put my card here. If you want to contact me, it's right there. So essentially you want to take all the keys, which are like GitHub, Twitter, name, email, company, and website. Those are the keys, and I just want to print out those keys. So the real basic way to do this is just doing a for in loop. So for var detail and card. I'll push all the keys in there. I also push the values in there, but you don't need to do that. And then when I execute it, I can run node keys.js, and that's the output that I get. So there's this cool thing where that kind of function already exists out in the world, and I don't really want to make my own like I just did. So there's this cool repository called Node Package Manager, and they include a ton of different modules that are open sourced out in the web. You can get the whole list by going to that site, and essentially I'm going to pull in someone's function to help me do this job. With the same way as using require. So for how I'm going to do this is I'm going to run npm. So the first line is npm install Lodash, and I'm going to save it to my current folder. And if you see, what npm does is create a folder called node modules, which then if I run my, when I run node, it will import all the node modules in that folder. So the next part is I'm going to rewrite keys to a more easy way of than what I did before. And as you see here, I reduced my code to essentially nothing. And I used a require statement at the top to include the module that I just installed. And at the end, I just call a function which is included in that module, and I get the same exact output. So I'm going to get it a little more in depth from what I kind of described before about how Node is non-blocking. This should block, right? So if I do request.getMLH, right, I should, in normal logic of synchronous programming languages, I have to wait for that site to be pulled down, which could take some time, you never know. And then I can get to printing out the keys on my card. But in Node.js, this is not the case. So I'll give you a small example of how that works. My text is really small. So this is the same exact code. I'm going to run it real quick. So if I run this file, you'll see that my keys at the top have printed first before I actually printed the site. This is because I ran an IO operation, which is non-blocking. And so that way I can go down to the next parts of my code and execute that. So if you see the site here, which is cool, they got this nice little ASCII art. You'll see that the order of operations here is dependent on how fast the site loads. Cool. And if you want to create a web application, unfortunately, web applications in Node take a little time to explain. But the easiest way to get started is using npm and installing what we call the Express generator. So Express is a framework to create your application in. It only includes the controller and the views, but does not include the models in MVC. If you want, and then right afterwards, you run the command express my app, and it will create the folder and the entire node structure for you to get started with your site. And that's it.
Awesome. So, questions. First off is, for people who want to learn Node.js, where are the best resources to go to beyond your talk and some of the tools you mentioned?
Cool. So a lot about Node.js. If you want to learn Node.js and how to create sites, the best resource that I found that I use is just kind of Googling your way through. But there are kind of tutorials out there if you type in like Express4 and so forth. You'll find some tutorials on how like Express works to its entirety. Express.js also has their own website, which goes step by step on how to actually create your site, and it's probably better at explaining it than I am.
How do you know if, like, when Node is right for a project? Like, obviously there's certain tools that are good for certain jobs. Like, what kind of jobs is Node good for versus other languages?
So yeah, that's actually a very good question. It's really dependent. In my opinion, Node.js is a very great language because at a startup that I'm currently into, your backend code will be very similar to your front end code. So you don't have any gaps in between, like, oh, your front end guy needs to learn Ruby in order to write back end code. Node.js is also one of the better, it's also a very good asynchronous programming language compared to like PHP, which is synchronous, Ruby, which is also synchronous. If you want to dabble into a very fast web application, Node is a very good way to get started.
What is like one of the most common like pitfall patterns that people run into in Node, like big places people stumble?
Right. So a lot of the pitfalls is honestly two things: getting started with JavaScript and then understanding essentially how Node handles requests or Express handles requests. Because JavaScript by behavior is all callback functions, you getting like very familiar with that and knowing how like you can create essentially a synchronous application through callbacks. That will be the first thing, the roadblock that you kind of have to get through. And then once you get past knowing JavaScript really to its entirety, the next part is understanding how Express or Node incorporates into JavaScript. And that's like basically the two major roadblocks I've had in the past.
So obviously Express is a pretty popular framework in Node. Are there other frameworks that you have experience with? Like, what other ones would you recommend, or other tools even you would recommend for Node?
Right. So Express is very unopinionated. It's also extremely small and you can do a lot of things many different ways. There are other cool ones that I haven't personally used, but Meteor is one of them. Meteor kind of like is more opinionated, but can really get you started off the ground.
How does Meteor compare to Express, like in general?
In general, I couldn't really give you like great concrete examples, but Meteor is more like heavily and tightly integrated to the front end, so that way you don't have to like pretty much duplicate code.
Cool. Any closing thoughts?
If you want to know more about Node, just tweet me at Stephen Liu, and I'll be happy to answer your questions.
Where's your hat?
You're live.
Coming at you live. Where's your hat?
You're not allowed to be on the live stream without a hat.
The room that we're in is literally like 85 degrees. I was sweating like drips of sweat from my head just sitting here. But world hacker. For old time's sake, let me grab it. Can you turn
Is
down the
it
music really quick?
is it cold at your school, or is it just hot inside? You have a university that gives you proper heating?
It's very hot inside,
Yeah.
yeah. They heat all the buildings obnoxiously hot. But let me introduce you guys to whoever else is around here. So,
Please.
Let's do it.
Itai, say hi. This is another one of the organizers you guys have been in contact with throughout the times.
How's it going?
Hello.
So, what else do we have? Where's your hat? We have you guys in the live stream up on board. Yeah, can you create a section here?
Oh, is that an ASUS campus rep?
One of our students is like an ASUS rep, so she gave us a bunch of this stuff.
That's awesome.
Who else do we have? Some of the other Hackbee organizers here.
Is it cold at your school, or is it?
You guys should mute the live stream while we're streaming from your.
It's very hot inside. Inside the building we're in, at least.
No, you should mute the live stream.
And here's like the room of everyone else. So we had a bunch of people.
Hey guys.
Hi everyone.
I hear myself in the past. How's it going? Myself in the past. This is insane. But yeah, then here's the rest of them. More organizers just coming in there, an orchestra concert. And yeah.
Hey.
Hello.
Cool.
ASUS campus rep?
Oh yeah, here she is.
Nice.
Hello.
All right, guys. Good chatting with you.
So yeah, how are things going on your end?
Good. Yep. All right, we gotta run. We'll see you guys later.
See ya.
Very superstitious. Writings on the wall. Very superstitious.
and I'm giving a talk about Intro to Bioinformatics. To start off, so I am Brynn. A little background about me. I am a student at the University of Pennsylvania. I am a senior at this point. I am studying computational biology in the School of Engineering. So that pretty much means I take a lot of computer science classes and a fair amount of chemistry and biology and statistics and a lot of upper level biology and genetics. I am also a hacker. I go to a lot of hackathons, and I was the director of the PennApps hackathon, if you've heard of it, like last spring and the fall before that. And I also participated last time. So yeah, here we go. So this talk's a little bit different than what you've probably seen today if you've been paying attention. You know, this isn't a language or a type of technology that I'm teaching you about. This is kind of a more general topic, so I'm kind of going to do an overview. I'm assuming most people here have a background in either biology or computer science. They maybe know a little. And I'm going to start by just telling you what bioinformatics is and why it's cool. And maybe, you know, even some like downfalls of it and how to fix some problems that you might run into. And then I'm going to give some really cool examples of things that you could actually do on your own to do your own like computational analysis of biology information. Okay, so what is bioinformatics? Very simply put, it is biological problems that you solve with computational solutions. So there's kind of a process to any like bioinformatics solution to anything you might be doing. The first one is to pick a biological problem. Not necessarily always the first step, but generally a good place to start. I've listed a couple of things that are like, you know, wider topics in biology that I'm actually gonna give you some examples of later. Genetics, so that's studying DNA. Evolution, so how different organisms have evolved from each other. Proteins, so these little tiny molecules that actually make up everything in your body. And medical image analysis. Good, so step 2 is usually find some data. So bioinformatics is really quite frequently a kind of big data approach to biology problems. So yeah, there's a lot of data and it's kind of a struggle. You know, if you've ever thought about like something like Facebook has a lot of data to go through, biology has way more data to go through. The scale is just unbelievable. In every single cell in your body, you have millions of like base pairs of DNA. So if you're trying to at all like keep a resource bank of, you know, different people and the different like, you know, maybe their genomes, like several different people and like all the genomic information they have, it's actually, you know, millions and millions of base pairs, like millions and millions of data points. And think about something like financial transactions. So, you know, a bank has to keep track of people using like their credit cards every day and their debit cards every day and cashing checks every day. And this is like millions of people doing this. So something of that scale, you kind of got to think on that scale. So you can't really solve the thing. You really need to think a lot about how you're storing your data and think a lot about algorithms. So what's the most efficient way to parse data and like get information out of it? I'll give a good example of this later. So there are actually a lot of databases online that already like came up with very elegant ways to store all of this crazy amount of data, and they have it available to the public, which is kind of crazy if you think about it. Like you can actually see like the genome of different organisms online and play with it, and it's totally for free. And I'm going to go through an example of this later too, playing with one of these databases. So the next step in the process is coming up with some kind of computational approach for analyzing your data. And yeah, there's a lot of them. I listed a few here. If you're in computer science, these probably sound like buzzwords to you. So one thing you can do is a machine learning approach. So machine learning, usually when you use machine learning, you're trying to classify things into categories. So maybe, you have information about genes and you're trying to figure out like which organism they belong to or which type of functional group they belong to. And if they look similar, they might do one function. And if they look very, very different, maybe they're from an older organism or they have some kind of different function. So machine learning can be useful for something like that. Graph theory. So when you're looking at genes and how they, essentially how the proteins interact that the genes create, it kind of forms a really complicated network, and you can actually use graph theory to apply to that network of, let's say protein A interacts with protein B, and then interacts with protein C, and D, and E, and there's some very long chain, but, protein X interacts with all of them. You could use a graph theory approach. Like a very basic thing would be to say, oh, well, put it on a graph so that every protein is its own node on the graph, and look at all the connections between them and say, oh, it looks like protein X has a lot of connections, so it's probably really important. That's a pretty basic graph theory approach, and you could extend that out and use all of these really complicated graph theory algorithms to look at this network and figure cool things out about it. And again, it's just normal computer science approaches with just biology data. Natural language processing. So I've actually used this before to look at paragraphs describing what genes and proteins do, and look for keywords and compare between different genes and different organisms and see what the differences are, and try to get information out of this. Again, which genes are important, maybe which genes belong to a group based on the description of what they do or what they interact with. And dynamic programming is actually used a lot, if you've ever heard of this. If not, again, it's totally fine. It's used a lot for looking at sequences because, again, analyzing sequences is actually, sequences of DNA, is actually very difficult and uses a lot of computational power. So you need to be very smart about it. Another common computational approach, both for looking at your results and also sometimes as part of your actual analysis, is using visualizations. So the bottom one here is protein structures. So, there's some data that says, oh, this part of a protein looks like this, or it's a different type of element, a different type of sub-element, and showing how they interact in different circumstances and how these proteins can come together. Because proteins are so tiny, we actually can't do that at all in real life or really see it. So we need computers to actually see it and make it really big for us so we can actually understand what they look like at that very, very tiny scale that we could never actually visualize. And up top, I have a heat map. So this is showing how different genes act in different circumstances. So let's say one gene, let's say there's an experiment that puts in a molecule, something like glucose, which is sugar, and looks at how different proteins are expressed more or less based on putting in the sugar, this extra molecule. And we can actually visualize how they interact on a wide scale with lots of different genes and in lots of different experiments with heat maps. And it makes it a lot easier just to look at it and see what general patterns are. And then you can even apply computational approaches on top of that and learn things about these heat maps and learn about how these genes interact and how they're expressed and how they react to different elements. And the last step is verify, verify, verify. This is very heavily into statistics. Because when you're doing computational approaches, you aren't actually proving anything straight out. You're generally just making inferences based on lots and lots of data that you've looked at, and you usually say, well, since I looked at all of this ridiculous amount of data, it makes sense that what I found is important, and then you cite some statistical report. You say, it's statistics. If you've taken a statistics class, you say it's statistically significant based on X, Y, Z. And this is extremely important because, again, it's very difficult to actually verify things with computational approaches. So we have to just prove that what we're doing is very, very likely to be true. Okay, so there are a lot of shortfalls to bioinformatics. And it takes very, very smart people to try and get around these problems. The first one is just that normally when you're creating your machine learning models or something like this, you kind of have to create cutoffs on your own. You kind of say, I'm pretty sure this belongs to this category if it is this much similar to whatever the category is. And that's not very certain, and you just kind of have to have a lot of experience to be able to actually draw those cutoffs and make it actually make sense. And again, there's way too much data for anybody to ever even comprehend. So you have to be very smart about how you store it and how you analyze it. And the main problem that I'm seeing right now is just that there's so many different tools, and there's all of these different file types for saving information about genes. Even something like that, just there's no standard format for saving information about genes. There's tons and tons of different file types. And a lot of what bioinformaticists do, unfortunately, at this point is convert file types or convert your data so that it'll fit into some tool that somebody made to visualize your data or to analyze it or do something else. Okay, let's go through some cool examples. There's a lot of examples with genomics. You could use bioinformatics approaches for pretty much everything in genomics. I'm going to explain a little bit about what it is for those of you who maybe haven't taken a biology class in a while or haven't ever taken one. So DNA, starting really basically, is just a string of the letters A, C, T, and G. That's all you need to think about it as a bioinformaticist, as somebody who's going to just be reading strings, which, if you're a computer scientist, you're already starting to think oh, how can I analyze this as a string, and what ways can I compare strings and learn things about it? And again, we have millions of them, and each little part, so maybe 100 of these A, C, T, and G strings is called a gene, and that's a functional group. So we're actually going to look at a gene that's a few hundred base pairs. Again, that's what an A, C, T, or G is called. And it's the insulin gene, so it creates this molecule that's very important to the disease diabetes. And it is the actual DNA in all of your cells that codes for this molecule to be created. We have something in genetics called the central dogma, and it's very basically the idea that you take this DNA that's stored in all your cells and you use it to make proteins, because DNA can't actually do anything, it's just information. You can almost think of it as just binary, zeros and ones. You can't actually do anything with that. You need to kind of translate that and turn it into something that's actually useful. So proteins are the things that are actually useful. They're the things that actually interact in your cells and build things in your cells and do things. And there's weird research that proves that sometimes you can usurp this or go backwards, but this is the central dogma that we will assume for now. Okay, so let's take a look at some resources. One of the best resources is NCBI. So this is kind of the National Institute of Health, the United States government resource of tons of genetic information about every kind of organism you could ever imagine, and all sorts of information you could never even begin to go through. So this page is all the information they have on this gene insulin. It's in Homo sapiens, so it's a human gene. Again, there's a lot of stuff here. They have lots of cool visualizations, but a lot of the things on the government websites are kind of outdated in terms of visualizations. But yeah, so there's a lot of information here. I wanted to show off, you can actually, on this page, you can get the like actual A's, T's, C's, and G's that make up this gene and do cool things with it. So again, it's kind of up to you to come up with the questions that you have and the things you want to solve. But they have a resource that's very important and that a lot of people use called BLAST. And BLAST is, you know, let's say you're a biologist and you come up with a list, you find a gene in an organism and you don't know what it is or what it does. You can actually search just the pure like A, C, T, and G sequence and figure out which organism it belongs to and what its function is. I've also used it to like compare between organisms. So maybe I'll have a gene in like one organism and I'm looking at something really closely related and I want to kind of tell the difference, like see how related organism A and B are and see how related like A and C are. So I will look at like a particular gene or a very important gene and I'll use this tool called BLAST and look at the exact sequence and how closely it matches to the same gene in this other organism. And this is the kind of result that you get when you BLAST. So I just took this gene that we were looking at here and put it in this BLAST algorithm. And there's like a couple different BLAST algorithms, but the one that they use on the website is pretty good. And it just shows you the alignment to everything in its database, and it does this very, very quickly. So this one actually has an exact match because I stole it from the website, and of course it will have an exact match. It matches to the one that I took it from. And you can, again, if you're looking at different types of genes or different types of organisms, it's actually very useful to see how similar these genes are. And maybe you can learn things about the evolutionary tree, like what organism evolved from what this way, or if you have a gene on your own, you can figure out where it belongs or what it's supposed to do. So BLAST is a really cool resource. There are lots of other resources, and if you are a programmer, you probably want to access their API. I use this a lot. So all of these resources that NCBI has are available through their API, and you can call it and get all the data by yourself. I had a couple examples here. So this is an example. You just start with their like base sequence, and you do one of their search functions, like get a summary or fetch or do something like that. You pick a database that you want to query. You pick the ID of the gene and the type of information you want to return, and this is returning XML. So again, if you're doing a computational approach on your own, you can go through their API and get all of this information for whatever genes or articles or anything you want all on your own, and you can analyze them on a larger scale. And that's actually pretty, again, you have to pose your own questions and figure out what exactly you want to be searching. But it's actually a pretty cool thing to be able to search all of this information pretty instantly. Let's see. Yeah. So again, you can return different file types, and you have cool things you can parse. This is actually this is an example of an abstract of an article. So this is another cool thing. It's not just like the pure string like ACTG that it has online. It actually has like every article that's ever been written about biology and genetics, and it's all online for you to access. I actually use this to do natural language processing on the abstracts to like find information, as I said before. So this is very useful because again, I can just query the API for all of the articles that I want to find, or I can start by like doing my own query, getting all of the article names or numbers that I want, and then getting a query and taking out these abstracts and doing some kind of like processing on them. And yeah, that's one very interesting approach to doing this. And there's tons of other things you can do with genetics. Again, I'm not really going to go into everything because that would take forever. And I love genetics. I'm a geneticist, so I have lots of examples. But I wanted to show you some other interesting things you can do with bioinformatics other than just look at these 4 characters and learn things about them. So evolution, again, I talked a little bit about this before. It's actually a very difficult question that we can't really solve. We kind of, like in theory, you can look at just purely a string, like all the DNA in every organism, and compare them next to each other and say, well, this one is more similar to, organism A is more similar to organism B, so they're clearly more related and they belong together on the greater evolutionary tree of life. But it's actually much more complicated than that, and there are a lot of like weird biological problems that lead to weirder computational problems. For example, genes that are crucial to functioning are very rarely changed. So, maybe organism A and organism B overall look really similar in terms of their DNA, but actually, organism C it has the exact same like crucial function genes as organism A, and it's just some of extra DNA that's not actually useful that's been changed significantly. So those 2 organisms are actually probably more related than A and B. And this makes making trees really complicated and figuring out the evolutionary story really complicated. You can also incorporate data about how organisms look, or like how long their spines are, or et cetera, and the more information you put in, the harder it is to process all of it and learn things about it. Protein structure. So again, I showed a picture before. You can do a lot of cool like visualization and 3D modeling to try and figure out how proteins interact. Because proteins actually like physically lock into each other. I think they call it like a lock and key model, but we can't see it, so we kind of have to create these computational models to figure out how they work. And again, you can think of protein interactions as a graph and analyze it with graph theory and do some cool things there. Another thing you can do is medical image analysis. So I actually, somebody I know had this problem and was having some trouble. So she was actually writing like Java code to analyze this image. And it wasn't this one in particular, but the whole point was she wanted to be able to find a tumor in like an MRI image. And she broke it down into a bitmap. So she looked at like the color of every single pixel. And she essentially wanted to be able to circle the tumor. There's a lot of computational things involved there. She ended up using some algorithm that like goes through every pixel and just looks for like groupings of things that are the same color, and this particular like extremely light color that shows up in an MRI as a tumor. And doing this sort of thing makes it way faster for for patients to get analyses of their MRIs instead of waiting for doctors. It's always good to have a professional look at things, but sometimes it takes a lot of time and you really can't afford to wait. So there's a lot of really cool things, kind of more in the medical space you can do too. It's definitely not just limited to genetics and all of these like tiny things or theoretical things. It's things that are actually very applicable and can be solved. And bioinformatics is really just any biological problem that you can solve using these computational approaches. And that is it. If you have any questions for me, you can always tweet me at bclaypoole, and I'm more than happy to answer. And I think we can have a question and answer session right now too.
You can. So the first question from the audience is, how did you get into bio and CS as a combo?
That's a really good question. So I was actually very into biology when I was younger, and I just took like normal biology in school and really loved it and started studying it on my own and like going to, very cool biology summer camps, and because I'm a really cool kid and always have been. I've really always been interested in that. And when I was in high school one summer, I signed up for a program, like a free summer, again, one of these free summer camps. It's called Summer Ventures, and it's like in North Carolina, because I'm from North Carolina. And I actually signed up for a class called Visualization that I thought was about like seeing in the eye and like biology things. And it was actually about computer science. And I knew nothing about computer science. So I went and I met a lot of cool people who taught me a lot of really cool things, and I started really getting into computer science. And I couldn't really choose between biology and computer science, so I ended up just finding something that allows me to do both.
That's awesome. I think we have time for one or two more. So we spend a lot of time thinking about how to make our community more inclusive to like people who are traditionally underrepresented in tech, but theoretically like they know CS already. How do we make like hackathons and hacker culture more accessible to people who are not already programmers, who might like be in fields like biology and or whatever and have interest in this stuff?
Yeah, that's a great question. So I actually work on this as part of PennApps too. I started something called PennApps Health. I also started something called StitchFest, which is in a similar vein. But we essentially have these like kind of subgroups within our hackathon that are completely devoted to these fields that are not just straight up computer science or hardware. You know, with hardware, we're starting to pull in people who are more into like electrical engineering, and that's great. But there are tons of people who have lots of other interests that aren't necessarily those in particular. So I think it's really nice to kind of create these sub-communities and try to have this focus of like, here's a group of people who are just going to focus on, you know, healthcare hacking, like things that can help the greater healthcare industry. And those people, you know, some of them were doctors that I actually like. I taught like a summer class on Node to try and like help them get integrated, and it was really awesome. And we actually managed to pull in some people from medical school. So, you know, I think this is like a very interesting problem and something we can really work on a lot by trying to say, you know, we know you guys have other, you know, we know you have other interests, but we really, really like this idea of like constantly building new things and trying to like come up with solutions to these big problems. And even though we don't understand these problems, we would love for you to come to our event and learn about how we operate, and for you to teach us things about, you know, the problems in your world, so we can try to solve them together.
Awesome. Any closing thoughts, and how can people get in contact with you going forward?
Yeah. I don't know about closing thoughts. Again, I highly encourage anybody who thought this was cool to just kind of play around with some of these resources. You know, it's a little difficult because biology, like there's so much biology terminology, but something like looking at a string of letters is something that you know, computer science people understand pretty well. So, you know, I encourage you to just play around and look at what some of these databases have to offer, especially the ones that I had listed earlier. And if you want to reach out to me, again, I have my Twitter handle up here. You're more than welcome to tweet at me. If you want to email me, you can try BRYNN, it's my name, Brynn at pennapps.com, and I will get back to you as soon as I can.
Hi, I'm Scott Resnik, and this is the intro to the Oculus Rift talk. I work at a startup that does contracting for AAA video games. I do mostly engine programming and optimizations for console games and things like that. So, but let's get into about the Oculus Rift. Let's just do a quick hardware overview. So this is the headset, as you've probably seen it, and it has a single screen inside of it that has a resolution of 1920 by 1080, and it shares that screen between both eyes. So it has two lenses on each side, and they direct the image on the screen into your eye. The lenses let you focus on the screen that's up close, because normally if you didn't have a lens and you put your face that close to a screen, you wouldn't be able to focus on it. Your eyes wouldn't be able to. Also, inside of the headset, it has a gyroscope and a magnometer, which allows it to track your head rotation. And then in addition to that, it has an IR camera that you mount on top of your computer or around the side that detects IR LEDs, which are under the surface of the plastic on the actual headset, but you can see them in the image on the screen. You can see the little orange electrical bits going around. Those are all the IR LEDs. They blink at different rates, which lets it know which LED corresponds to which part of the headset, and then they do some tracking magic behind the scenes, and then you can tell where the head is positionally relative to the screen. So that lets your player look around and lean around, and then you'll be able to replicate that action inside the actual virtual world. So there's VR is rather new, so there's some best practices that they've kind of put out in the Oculus Connect talks that they did, which you can also watch on YouTube. But just kind of summarizing what they said really quick, everything looks the right size. So because you have two eyes, two cameras, and two images being streamed to both of your players' eyes, they get a stereoscopic vision. And as a result, they get depth perception. So everything in the world appears the correct size. So if you walk into a large building, it seems really huge, which is both good and terrifying, because you can walk into this like amazingly made level and you can look up and it'll feel gigantic and you'll feel like small and it'll be awesome. But it can also be terrifying, because you might be playing, say, Elite Dangerous, and you're flying in your little tiny spaceship and a much larger spaceship comes barreling towards you, and it's quite frightening. So the general gist right now is to be gentle with your players. Because if you aren't gentle, people who are new to the Oculus will have a very hard time playing it. So you kind of build up this immunity to the Rift when you start developing with it, because you're putting it on and you're seeing glitches in your level, and you're aware of it being a game, whereas someone who's new and putting it on, they're just experiencing like all of that all at the same time. So then things that jump out at them or collide with them or are massive and moving quickly can be kind of scary, and it's a problem. They can also experience vertigo. If you've played some of the games, there's some grappling hook type games, and you go jumping off a cliff, and then you'll be falling, and your body starts feeling like it's falling, and you can feel that in like the pit of your stomach. So don't try dumping your players off cliffs. It's not fun. Well, it's kind of fun, but take it as you will. Moving fast is scary, and above all else, never restrict their head movement, because if you prevent them from rotating their head, it starts to make them motion sick, is what happens. So they feel that they're moving their head, but what they're seeing in both their eyes isn't moving, and it creates this kind of disconnect between what they're feeling and what they're seeing. And it's like the same as when you're trying to read a book in a car, or if you're on a boat for the first time and you get seasick. It feels very much the same. You get like this awful feeling in your stomach. It's you shouldn't restrict the positional movement, but it's not as destructive to the player experience if you restrict the player movement. It's just not recommended. And regarding movement, seeing how things are moving and feeling how they're moving, the feeling that you're moving, I believe is called vection. And vection creates problems. So if you're creating a first-person game, like if you're playing like Team Fortress 2 or some other first-person shooter style game, you have your Oculus camera mounted on the player and they're running around, and they are seeing that they're moving through space, but they're sitting in a chair in their room or wherever they're playing, right? So their body isn't feeling that they're moving, but their eyes are receiving that they're moving, and it can make you a little bit sick. You kind of get used to it. They when the DK1 came out, they were calling it your VR legs, like your sea legs. It kind of goes away after a while, but it can be very daunting to a new person. That's why you see like funny YouTube videos of people like putting it on and standing up and then like walking around and then falling over in the real world. So as Oculus says, Oculus is a seated experience. So make sure your new players, anyone testing out, are actually in a chair, because it can go very bad very quick and they could break your priceless headset. The slide got a little screwed up, but I'll talk about the Unity integration because it's the easiest to use right now. There is a UE, an Unreal Engine 4 integration, which is also fairly easy to use, but most people are already playing around with Unity. So they changed the integration as of SDK version 4.3 or 0.4.3, I believe. And they made everything a lot simpler. So what you see is the view that you get inside your world browser thing in Unity is the OVR camera rig, which holds the center eye anchor, the left eye anchor, and the right eye anchor. And the camera rig's position in the world represents the default position. So when you start up with a game and you have the Oculus on, it sits in a position that's like 0, 0, 0, and any way they lean is offsetted from that. When they lean, it offsets the center eye anchor, and then when they rotate their head, it rotates the center eye anchor. So if you want to determine where one was looking, you use the center eye anchor, and if you want to determine where the reset position is, you use the OVR camera rig's positions. Some useful functions. They have the OVR manager .display.recenter pose. You want to expose this under some sort of key press, because especially if you're demoing it to a lot of people, like someone new will sit down and you'll put on the headset and they weren't in the same position as they were before. So their head will be off to the left, whereas the other player was right here, and then everything's a little bit wonky. So if you just have a key on the keyboard that you push and it assumes that where the person's head is, it recenters it. That's what that function does. And then you can get the look direction of where they're looking by using the center eye anchor .forward, so you can have your world react to what the player is looking at, which is like this kind of natural input that you didn't have before when you're playing with other games. You can so if they look over at an enemy or look at like a UI panel in Elite Dangerous's case, the UIs will pop up as you look over in the appropriate direction, and it feels really cool. So take advantage of which direction the player is looking. So animation is hard. I wanted to dig into this for this talk because the last couple times I've been in a hackathon and tried to do something with the Oculus, we've had to skip over animation because things are difficult. You essentially need to end up using inverse kinematics, which essentially you have a bone chain, and then you have a target position, and then you want to find out the rotations that the bone should have to match the location. And MechAnim, which comes with Unity, has this built in, but it's not great because the Oculus now has leaning support, right? So if you try to lean and you're trying to use the MechAnim's built-in inverse kinematics support to make the character lean, you find that MechAnim doesn't support that because you can only position the hands and the feet and give a look-at direction for the head. So it doesn't help you much if you want to have a player tilt their head. It doesn't help you much if you want to lean the body. So I thought this would be the most useful thing to dig into. So I ended up writing my own inverse kinematics, which is why it says stick it to the man, because we're going to use our own. Two-bone IK is pretty simple. It's easy to calculate, whereas if you add more bones into the bone chain, you get into weird numerical issues. There's two major algorithms, and they're all very complicated, and they take a lot of math, and it's not very fun. Thankfully, Ken Perlin, the guy who invented Perlin noise, he did a presentation at GDC a while ago. I forget the year, but he wrote out code in Java that solves a two-bone joint chain, which makes it easy to port. So I ported that for you. Two-bone IK is essentially what I said. You have some bones and you have a target position, and you want to make the bones move to the target position, which is simple when you have 2 bones, but you do run into this like case where there's an infinite number of solutions. So as you can see, like I have the 2 sides of that little diamond shaped thing, and it could be anywhere on that oval, right? Because you can just swivel those 2 bones around and they meet the distance requirements, and it kind of looks like the little diamond marker from The Sims, except smoothed out. So you run into some issues. So Ken's method actually it uses a point in the world to find the point on that oval that you just saw that's closest to it. So it resolves the infinite case into something that you can use. So the function I wrote for you guys looks like this. You take some bones, you get a start bone, you get an end bone, and an elbow bone. And then you get a target and a target rotation. So the target is the position you want to move, target rotation is what you want the end bones rotation to be, and then you get a blend weight. So if you wanted to make if you're trying to make the character's arm gradually outstretch, you'd calculate the final position, but then you'd gradually increase the blending factor so they'd move from whatever the position is to stretching out their arm. Super easy to use. And then there's also elbow pull point. Whereas, as I mentioned before, in Ken's solution, you can specify a point in the world that you want to use as the anchor for that oval solution. If you don't specify it, it uses the elbow bone's current position as that, so it'll pick the solution on that circle closest to where the elbow currently is. But if you want to specify a different point, which we do later in the talk, you can pass it in as an optional argument with that nullable vector 3. The code will be up on my GitHub, github.com/LordTalks. It's not up yet, but I'll upload it as soon as I'm done with the talk. So what we're going to use the inverse kinematics for is matching the lean. So you want as the player leans around to be able to look down and see their character in the world, because it's a really cool experience. If you don't have like an actual model below the character, they don't feel like, you lose kind of your presence of the world. You feel like you're just floating there observing it. But if you look down and you see like a virtual body in the world, it kind of grounds you and it kind of makes you feel better. So what you want is for that body to react with how the player is moving through actual space with the headset on. So the head doesn't really matter because you can't see your own head unless there's a mirror, which just for our solution, just don't put a mirror in the level. But if you are doing that, you'll have to solve the last little bit of the head yourself. But the torso does matter because you can look down and see your torso, and you can like lean to the right and look down and you'll still see your torso. So you need your torso to move with your head. So that's the problem we're going to be solving. So first we need to get the bone chain. So in addition to my 2-bone IK function that I wrote for you, I have a search children function because the built-in finding of children into Unity requires you to type out like a whole long path, and it's kind of annoying. And then also if you change models, so like if you're working with like a test model and then your friend's working with trying to get a new model rigged up, then you have to edit all those strings of those long paths. So what this simple ik.searchChildren does is just search for a child, matching the name, and then returns it. Super easy. And then you can use the bone chain by just accessing the parent, and then you get the whole chain all the way down, which is super useful. So then we're going to place an extra node in the world on our character, which I call the iTarget. And the iTarget is a game node that that you put in the center of your actual 3D character's eyes in the world. And we use this to help sync the Oculus's center eye anchor to the in-game center eye. And the reason we make it a game node is because it's much easier to place. Instead of like typing in values and then hoping that you get it in the right position, just make a game node, scroll it around in the world, and position it where you like. And then we'll store an offset from that iTarget to the head bone, because we want to be able, because we're going to get the value from the center eye anchor. So we want to be able to go from the center eye anchor to where the head bone should be for the player leaning around. So we do the final minus initial. So the final is the iTarget, and the initial is the head bone's transform, and then we get an offset. We're just going to store that for later use. After you get that offset, you can go ahead and collapse the player's head down with scale 0, because if your character's wearing glasses, or maybe they have some obscure geometry on their face, you'll see like certain polygons just pop up in the world. So the way you solve that is just set the scale down to 0, and it clumps down to being nothing. and it just gets the problems out of the way. But we have to set the local scale after you capture that I target offset, because if you do it before, then the scale will affect the offset, and then you'll get an offset of 0, and it won't work, and it's no fun. So then we do the neck offset, which is the vector from the head bone to the neck bone, which we only use its length here, so I call it the comfortable neck length. And you're trying to find how long the virtual character's neck is, so that you can use that information to position where the actual neck should go when we do the IK to position the body. So we do the neck offset is equal to the I target position minus the neck base's position, and the neck base is just the very bottom neck bone. It's like down here, and you can see it in the actual image there. I've drawn little debug lines, so you can see the white line is representing the vector. And then we store the comfortable neck length as its magnitude, and then I multiplied it by 0.75 because the strained, if you use the full neck length and you were trying to do, like, say you're like trying to have that mirror in the level, or you're doing the multiplayer level, if you're storing that value as the full length, then you get these weird weird IK results because the neck is like the full length, and it's bad. So we just shrink that down a little bit, which causes the neck to kind of relax if you actually solve the IK on it. So then we're going to compute the target neck position. So what we're trying to figure out is from the eye center position of the actual in real world Oculus position, where to position the person's torso so that when they look down, everything looks right. So we're trying to position the neck where the real person's neck is in equivalent coordinate systems, because you have your world space world coordinate system and you have your in-game world coordinate system. So we compute the world target head pose, which is a mouthful, but it's the target position that we're trying to move the head to in world space, as the center eye, which is the Oculus's center eye anchor position, minus the center eye's rotation times the eye offset. So what that does is it takes that offset that we computed before, rotates it by however the orientation of the player's head, and then subtracts it. So this gets us to where the if the player's eyes are at center eye pose, where the head bone of the actual character should be. So then we've got that value. And then we want to compute the target neck pose. And the target neck pose is going to be based off of the head pose. So remember, we got that comfortable neck length, right? So what we try to do is we look at the line between where the resting neck position is, which I just call the bind poses neck position, and where the target head position is. So you have a point in space. You can kind of see it on this gray line in the actual image on the thing, where the gray line, the end of the gray line is the starting position for the neck, and then the line turns yellow, and then the ending position is where the target's neck, the estimated neck position is, or the head position, sorry. So then we estimate where the neck should be by just following that line, the length of the comfortable neck length from where the head should be. So if we just say the neck is supposedly a straight line, which it won't be, but we just, for the sake of simpleness, call it a straight line towards where our neck's resting position is by the length of the comfortable neck, then we have to move the rest of the body to match up with that value. So that's what we compute the world target neck position to do. And then we take all that information and slam it into our two-bone IK, which it seems the slide has messed up on me, but hopefully you can see the code there. So we pass in the chest base, which is the very bottom node on the torso, which you can see in the white lines and thing, where the white line starts. And then we have the chest, you can't read it, but it's like the chest middle, which is the bend in the white line on the image. And then we have the neck base, which is all the way at the top. And then we pass in the world target position and the center eye's rotation. The rotation doesn't really matter much because we're just swiveling a little nub of a neck, but we pass it in anyway. And then we also supply the thing I mentioned before, which is the elbow pull point, or in this case, we're pulling the back of it. So I noticed if you crouched with the Oculus, because it didn't have a good way of solving that little circle or oval issue, the side of the body would like slide out to the side. So he was kind of doing this awkward like little dance thing. So what I did was I just put another node, like I did the head targeting, the eye target node. I put one for the back and just dragged it out a little bit, and then called that the back pull point. So that always pulls that that ambiguity towards the back. So if you scrunch down, his back crunches backwards, just like your normal back would, instead of to the side or forward, which looks even weirder. So that just helps solve a little bit of indiscrepancies with it. It's a fairly cheap operation, and the key thing that you want to keep in mind is to do it. There's different update functions. There's like update, and then there's fixed update, which you use for physics, and then there's one called late update. So if you're mixing these IK functions with Mechanim, which you'll probably be doing, so you can play like walking animations and running animations and hopefully like shooting or I don't know, climbing or whatever your game is about. They run before a function called late update. So if you put your IK call in the normal update function, it'll get overridden by Mechanim and you won't see anything. So you have to remember to put it in the late update function. So that way it overrides the values that you get out of Mechanim. And then if you put it all together and you put on the headset, you can look down and then you can see your feet and the body moving around. And then that should hopefully give your players a better experience when they're looking about the world, so that they feel grounded instead of just kind of like a floating ghost in the world. It helps you like center. So like a common problem that you see with games that don't have any anchoring points is the player will gradually start to like rotate in their chair, because they'll rotate their head and they start walking towards something, and then they assume suddenly that where they've rotated is forwards. So then you'll get this like drift that the actual player starts doing, and they'll drift to the left or the right or something, and then they get all tangled up and it's no fun. So if you add actual anchoring points in the world, like a virtual body, they can look down and then they see that they're actually like off from where their virtual body is, and then they usually their brain will usually correct and they'll rotate back to center, which keeps them from drifting around in their chair, which is really annoying, because if you're drifting and you're using a keyboard or maybe a joystick or something, your joysticks will get further off to the left, and it's an issue. So hopefully these functions help you deal with the troubles that you have in IK and animation.
Cool. A couple of questions. So the first one is, for people who are interested in learning more behind your talk, what are some of the good resources, places people can go to learn about Rift and all that?
Well, there's Oculus put on a conference called Oculus Connect, where they had a bunch of like the head people, like Lucky Palmer, the guy who started it, and Michael Abrash, who came over from Valve, and they all do talks, and they have them uploaded to YouTube. So if you just like go to YouTube and search Oculus Connect, you'll find a lot of information. And some of it's like technical, which you don't have to worry about if you're using Unity, like it handles all the integration issues, and some of it's technical, like if you want to learn about like time warp and all the things they're doing to make the correct frame rate happen, you can learn about that kind of cool stuff from the Oculus Connect talks.
Cool. And is Unity definitely the best place for people to start with Oculus development?
It's by far if you haven't done anything, it's by far the easiest, because I didn't talk about it, but the SDK that you download from the developer.oculus.com, you can download, it actually has like a built-in player controller, and it gives you like a crosshair in the world, and it handles like the stereoscopic, and so you can just drop in this prefab, and then you can walk around the world in first person, and it handles all that for you, which is why I didn't talk about like movement and crosshairs and dealing with mouse input and stuff, because they handle it all for you. So it's definitely the easiest right now.
Are there any key differences between the DK1 and the DK2? Like, as a hacker who doesn't know anything, we're not looking at different ways.
So the DK1 didn't have any positional tracking, and so that's where this camera thing came out, and at first, I thought the positional tracking wouldn't be really worth it, because I was like, you're rotating your head and it adds a lot of complications, which I just talked about with the IK. So I thought rotation would be enough, but then I started to actually play, like I played Elite Dangerous and some other demos with the positional, and it adds a lot more than you would originally intend. And then in addition to that, the screen got an up-res, like the DK1 only had it was only 900 tall. I forget, it's horizontal, but it had a huge, what I called screen door effect, and it looked like you had your face pressed up against the screen door, and it was very hard to see away. You still have some of that in the DK2, and then hopefully in the CV1 they'll get rid of that, but it is an issue. And they also upped the number of frames per second in the DK2 from 60 to 75. So, which also, like, if you're playing like a game at a computer, you think 60 frames is enough because it seems buttery smooth, you know, compared to like movies and things. But once you put the headset on and start rotating your head, it becomes actually apparent that you need more than 60 frames per second. So 75 is what they have in the DK2. They're shooting for 90, for the CV1, but I'm guessing that's going to come down just due to hardware requirements. Like, we don't have GPUs, things capable of outputting 2 eyes at 90 frames per second. It's too much of a technical challenge at the moment.
Sure. And speaking of like hardware requirements, like for people who want to get started with this, like what kind of computer they need to have, like what do they need to basically get started with the DK2?
Well, it depends on what kind of game you're building. If you're building larger games, you're definitely going to need a beefier computer, but you can get away in smaller environments, like one room types of things, with like a GTX 570 and up, and whatever the mobile equivalent is. But if you're playing, like I run a GTX 770 on Elite Dangerous, and it struggles in parts. So you definitely need like 770, 780 Ti, or if you're lucky enough to have like a 970 or 980, or whatever the rough equivalents of the AMD cards are. I haven't kept up with the AMD side, but you do need a beefy card if you want to be able to have larger experiences.
Totally. Closing thoughts you might have, and then where can people find you?
Well, you can find me on GitHub at github.com/LordTalks. It was in the talk. I'll scroll back to that if I need to. And some other closing thoughts, because Unity 4.6 came out, you got new UI elements. Those are also very handy because you actually put UI, like buttons and labels and stuff, into the world, which makes it much easier to deal with on the Oculus. And then also the Oculus extension became available in Unity free, whereas before you needed Unity Pro, which was very, very pricey. Now, everything I showed you today could be done in Unity free, so you can just download and play away with it.
Awesome.
Are we live?
Yes, you're live.
Hello!
What up, guys?
Not too much. What are you guys doing?
So we're just hacking, you know, on a Saturday.
What's the occasion?
It's just like this local hackathon, I think.
Yeah, I don't know. I just wandered in. It's weird about it.
Because Nick's here.
That's pretty cool.
Yeah.
What do you?
Nice hat. Where'd you get it?
I picked it up off the street.
I don't know how to say. It's awkward.
Nice.
Are we live right now?
Yeah, we're live. So, show me some of what's being built at UT.
All right. So we've got.
What are you all working on?
We got these guys over here.
Hey.
What are y'all working on?
Are we live?
Yes.
Wait, someone's browser is up.
Can you see this? You give them a synopsis of what it is. Not too much. What are you guys doing?
So basically, you have like
so we're just hacking.
and
I did.
you have like logistics and things you
well, what's the occasion?
I hear myself in the background.
You got the YouTube stream.
That's pretty cool. Is it playing back?
Yeah.
That's hilarious. Right.
So, how warm is? How unlikely are you to use those hats in Texas?
It's really hot right now. Like, yeah. I don't know. It's how hot is it?
It's really hot. It is. It is like the 70s.
I think I could see sweat on you.
Yeah. Yeah. We didn't have time to put on makeup before the call. If you can believe it. We hear you have the makeup team over in headquarters.
Yeah, we do.
Yeah. Good. Good.
Yeah.
It's awesome over here in Austin. Aside from the heat, like there's a lot of really cool hacks. Lots of first-time hackers. Lots of people who this is like maybe their second hackathon after Hack Texas.
Wow.
We have an awesome work team. We have.
Hi, Taylor.
Do the jersey.
Wait, let me see your jersey. I want to see your jersey. Yeah, that's swag.
Yeah. We've got some really good breakfast burritos.
Oh my goodness! Not breakfast burritos, breakfast tacos.
Whoa.
Pro tip: breakfast tacos. If you're ever in Austin, and this goes out to everybody, eat breakfast tacos. They're amazing. I discovered them the first time they brought me.
So Nick, how did you end up in Austin?
You know, I was kind of just wandering around, and I felt like, I should check out this UT place. Just wandered in. There was a local hack day. There's so many.
Oh.
Did they know you were coming?
What?
Did they know you were coming?
No, not at all. I just showed in.
Yeah, I was really surprised.
Nico's first words were, "No way!"
That's pretty cool.
Also, the building's locked right now. So like, there's. He must have broken.
I actually had to like follow some guy in here because the building was locked and they had no idea. Yeah, no, like.
Did he ask you if you're a CS
I followed him all around the building, and I like asked him, "Do you have a card? Like, here, let me show you the door to get in."
Yeah.
So.
That's
We're
skill.
here, and there's a lot of cool hackers. So
Awesome. Well, I'm really excited. Thank you for showing us around, and we'll see you on Gitter, I guess.
Yeah. Yeah.
See ya, everybody.
Bye.
Hey, I'm Alex, and today I'm going to give an intro to Erlang. Can you see my slides? Alright, so I would like you to follow along with this demo. There's going to be a lot of code at the end. Please go to the repository I created, which is at github.com/aberke, that's ABERKE/MLH-hack-day-Erlang-intro. Alright, so what is Erlang? Erlang is a functional language. By that I mean as opposed to object-oriented. It's strongly typed, you have to compile the code before you run it, and it's garbage collected. So unlike C, you don't have to worry about allocating and freeing memory. Erlang is both a language and a runtime system. That means when you download Erlang, you're also downloading a virtual machine called Beam that the Erlang language runs on top of. Usually when you hear about Erlang, you hear about concurrency. We'll talk about that later. Alright, I want to show you Beam. Here's my repo that you guys should all be at. Feel free to clone it, and let's open up Beam. Alright, so from the command line, once you download Erlang, you can hit Erl, and we're into the interpreter. On the right, I have my repository, the directory for my repository open. And let's just play with the interpreter for a moment. I can do something like 1 + 1 is 2. I can assign a variable. 1 equals the value of 1. See that? That's assigned. So as you can see, each statement ends with a period, and variables have to start with capital letters. What I'm going to do here is I'm going to talk about why you should care about Erlang. Erlang is awesome, and then we're going to do some more coding at the end. Alright, so Erlang was originally developed by Ericsson, and Ericsson is a huge communications and telecom company, mostly in Europe. And they developed Erlang as a proprietary language for their telephony system, but it was later released as open source or free software. So Erlang has a lot of advantages, and one of the big ones you hear about is concurrency. Processes in Erlang are extremely lightweight. You can run millions of them at a time. And that's because processes are not operating system processes, they're not threads, they're these processes that run on top of the Beam virtual machine. And you can pass messages between these processes that are all running concurrently, because each process has this concept of a mailbox, which is really just like a queue that collects messages sent by the other processes. And processes are used for many things. They don't just do work. Sometimes that work can be storing state, and I'll talk more about that later. Another cool thing about Erlang is it can be distributed. So you have all these processes, and they're all running at the same time for the same application, but they can be running on separate machines. Erlang was built with that in mind. Erlang has a special way for different machines to communicate. Erlang is also very fault tolerant. So the work that you want your application to do, it'll be spun up in another process, and you might have a special process that's a supervisor process. And a supervisor will spin up processes as necessary to do the work, and a supervisor can also detect when a process fails. So say a supervisor spins up a new process, the supervisor can then handle cleaning up if the process fails and then start the process again. So Erlang is very unique in that there's this philosophy of let it fail. Let a process fail and let that error propagate so that then the supervisor can hear about it and handle it appropriately. So consider this example. You have the supervisor, you have some work that needs to be done, maybe in a function called do stuff. And so the supervisor spawns a process to do that work. And say this function do stuff calls another function called sings. And for some reason, the sings function fails. Maybe there's bad data, maybe a database was corrupted, or maybe the machine just died, or maybe there was a network outage. Something went wrong, and we don't catch the error. So the error's not caught in sings, don't catch it there, but then the error propagates up to do stuff, don't catch the error there either, let do stuff also fail, and eventually the process will fail, and the supervisor will hear about that failure, and then can clean up as necessary and try again. So that's one of the unique coding styles of Erlang. Another advantage of Erlang is hot swapping code, which is really cool. It's not done that much in practice, and I'm not going to talk about it more in depth today because it's a bit more high level. But consider why you would need to do that. Erlang was developed by Ericsson, which was developing a telephony platform. And I mean, consider the phone networks. There are millions of people having conversations at the same time. That means like millions of processes. And say Ericsson needs to upgrade some code. They can't just turn their system off, upgrade the code, and then turn the system back on. That means these millions of people that are having conversations on the phone are gonna have their conversations die. That's a terrible experience. So instead you can hot swap code. Code in Erlang is broken up into modules. Modules are just files. And you can swap in a new module version, and the processes that are currently running that need to use that module will finish running, and when the newly spawned processes will then use a new module. So this is really useful, especially when you're considering the application of telephony, which is phone networks. All right, we're gonna go back to looking at some code. One of the strange things about Erlang is that data is immutable. So let's go back into the interpreter. I assigned the value 1 to 1, but what if I did something like 1 equals 1 plus 1? That's an error because 1 is already assigned to something. You can't reassign a variable. And this might seem really annoying, but it has its advantages. Consider the fact that you have all these processes. I don't know if you've ever done threading with Java or another language, but usually you have to deal with locks. But you don't have to deal with locks if no one's mutating data, right? You're not handling the same data. Or if you are handling the same data, you're not gonna mutate it. So the pro of data being immutable is you don't have to deal with locks. But you might be wondering, how do you then maintain state, right? Like usually when you program, you have some sort of object in memory that's being updated to maintain the state. So another unique practice in Erlang is, since these processes are so lightweight, you can have a special process just to maintain state, like a state machine. And you can have your supervisor also responsible for making sure that state machine doesn't die, or if it does die, catch the state that it was storing and spin up a new process to continue handling that state. And a lot of times you'll have this process maintaining the state, and then when other processes need to access whatever information is in that object, the state process or the server process responsible for updating that object can pass information as necessary. We'll go into pattern matching later, but Erlang is really fun because thinking functionally is really fun. And when we dive into live coding, we'll get into that more. All right. So let's look at syntax. In my repo, I have a file named demo_syntax. And as you can see, it ends with .erl. Files where you put in code that does real logic end in .erl. And when you compile them, I'll compile right now from the interpreter. A .beam file is generated. .erl files are compiled into .beam files. There's a one-to-one correspondence. You also have .hrl files, and those are analogous to how you would have .h files in C. You can define things there and then include them in other files, like my demo.erl file includes demo.hrl. So syntax. Comments are preceded by a % symbol, just as you can see that this line is. Variable names have to start with uppercase letters. You have a type called atoms, and atoms start with lowercase letters. Like, I'm going to assign the variable some atom to the atom. And booleans are just the very specific atoms, true and false. You also have tuples, like 1 or 2, or you can put anything in your tuple. You have lists, and I'll talk more about these later. And strings are just syntactic sugar for lists of characters. And then you have these things called binaries, which we won't talk about here. So each .erl file, each module is a .erl file. And you have to have a statement at the top of your module file that defines the module. And the name of the module is always the name of the file. So this is the demo syntax module. And any public function you have to export in an export statement. And so here are all my public functions. So I compiled demo syntax, so now I can use it. So I can do demo syntax and test export. I got the value 1. So when you export a function, you have to say what arity you're exporting as well. And arity refers to the number of arguments that a function takes. Since you can have multiple function names, or the function name with multiple arities, you have to define which arity you're exporting here. So for example, test export, as you can see in my example using it, it takes no arguments, so its arity is 0. So this is what a function definition looks like. This is a function that simply returns the value 1. I assign a variable to 0. I increment that variable, but when I increment that variable, I have to assign it to a new variable, right? Because data is immutable. And then the last statement is just returning that variable. And this period indicates the end of the function. As I said, a period is the end of a statement. When I have statements in my function that aren't ending the function, they end in a comma. It's a lot like English grammar, in my opinion. So here's an example of a private function. As you can see, it's not exported in my export statement. And if I try to call it from the interpreter, I get an error because it's not defined past this module. But I can have another variable, another function name called public function, which I do export in my export statement that calls private function. And so this is an example where this is just a wrapper around the private function. So I could call public. Oops. So I don't know if you guys caught on to the syntax that's happening here, but I have defined this public function. It takes no arguments, and the first and only thing it does is just call another function called private function. So let's go back to talking about arity. So as I said, arity refers to the number of arguments a function accepts. And you can have the same function name with multiple arities. And you can export all, none, or some of them. So here's a function that just has arity 1. It's just the identity function. It returns the value that's passed to it. And here's a function named arity multiple, where I define it with multiple arities. So if I just call demo syntax arity multiple, with no arguments, it goes into this function. But if I were to call it with some value, like 1. Oh, I don't think I exported that one. Nope. I defined it but didn't export it as a point of you can export some or all of them. All right, well, I'm gonna call the one that has arity 2. That just returns the list 1, 2, or it returns the list of the 2 arguments that were passed. So as you can see, if we look at what this function is doing, it takes 2 arguments, value 1 and value 2, and then it calls the same function of arity 1, which is the private function that I wasn't able to call from the interpreter. And the 1 argument it passes is the list of the 2 values that were passed to it. And so, all right, so we then call arity multiple, where some value is that list, and then arity multiple returns that list. One way of documenting your code is providing specs, and I think I'm a little behind schedule, so I'm going to move past that. All right, so let's talk more about coding. So remember how I talked about .hrl files? Here's an example where I'm in demo.rl now in the next module, where I'm able to use that value that I defined in the .hrl file, because it's included here. So I'm going to compile the demo.rl file, and I can call demo, get favorite number, so another cool thing about Erlang is pattern matching. You don't see a lot of if-else statements in Erlang code. Instead, there's a lot more use of pattern matching. So what do I mean by that? You can use patterns to unpack tuples or unpack lists. So for example, I have the tuple some atom and then 1 here. And then I can later unpack it here. You can also use pattern matching to define the same function multiple times, but it's that function head is only executed if the pattern matches. So as you can see, I have this function named pattern matching function clause with arity 1 defined twice. But the first definition is only going to match when the passed item, the passed parameter, is a tuple of 2, a 2-item tuple. And the second one is going to match when I have a 3-item tuple. And if I pass a parameter that is neither a 2-item or a 3-item tuple, I'm going to get an error because there wasn't a definition for that. All right, so I'm going to pass a 2-item tuple. And now I'm going to pass a 3-item tuple. In the first example, they're very different functions. One just passes the second item of the tuple back, and the second one passes back a list. If I try to call it with something else, like some other value, like 1, that's an error. It didn't match any of the function clauses. So one thing to notice syntactically here is that when I define a function twice, right? I have 2 function definitions, one for the 2-item tuple and the 3-item tuple. Only the last definition ends with a period. All the other ones have to end with semicolons because you're not done defining the function. So let's talk about lists. So what is a list in terms of the data structure? A list is really just the concatenation of nodes. It's really just a concatenation of the node you're looking at, that first node, and then the rest. and the rest will always be another list. You just have a node that points to another list. And the syntax around Erlang lists really speak to that data structure and how expensive it can be to traverse that data structure because you have to look at each specific item. So 2 empty brackets, that's the syntax for an empty list. And other than that, the syntax for a list is the first node that you're looking at, which is the head of the list, and then bar, and then the tail, which is another list. So you can represent the same list in multiple ways. You can pick out the individual items. So I have this list 2, 1, 0. Or I could also represent it as the head of the list, which is 2, and then bar the rest of the list, which is just another list of 1 and then 0. And the definition is recursive. So then this list 1, 0 could be broken down further into the syntax of the list 1 as the head, and then another list of just the item 0, which could be broken down further. How? There you go. All right, so let's do something with lists. Let's write a function that makes a list of positive integers up to a digit that was passed as the argument. So for example, I want the list of items up to 5. And there I go. So let's look at what this does. Let's really get to you thinking about recursion, and the cool thing about Erlang is you really gotta think in recursion rather than iteration. All right, so in recursion, you always have the base, right? The base situation of when does this recursive function stop? And for our example, it's 0. When you encounter the digit 0, you're done, right? You don't want to go any further. Right, like when I pass in 5, I want the list 5, 4, 3, 2, 1. So here, that means I'm going to return the empty list, right? Because the end of a list is just the empty list. There's no more to point to. That last node doesn't have any other more nodes to point to. It's just pointing to the empty list. And this is an example of pattern matching, right? So I'm pattern matching on the value of the digit being 0. And otherwise, it could be any digit. So here's the function clause that matches on anything else. And what does this function do? It returns a list where the head of the list is the digit that was passed, and then the rest of the list is a recursive call to the function again. So let's go through this if I had passed in 1, right? It should just return one item 1. So digit, we get integers list 1. And what this returns is the list 1, right? And then we're going to call integers list with 0. And then we're going to hit the first function clause, which is just going to return the empty list. So then what we end up with is 1, which is the same as just the list with 1 item in it being 1. So you guys are list pros now, right? So we can do something a little more interesting. Let's write a function that doubles each of the items in a list. So this is really just a mapping function where I want to map each of the items, which are going to be integers, in my list to double that value. So if I pass in, there you go. So I have the base of the recursive statement, which is when I got to the end of the list, I'm done. I just want to return an empty list. And otherwise, I have a head and a tail of my list that hits the double function as an argument. And I only care about manipulating one item in the list at once, and that one item being the head of the list. So what do? I return a list where it's the same list that I received, except I'm doubling the head, and then saying, okay, continue doing this by going on to the rest of the list. So in terms of if I did a smaller example, which is the list 1, 2, let's look into how we're going into this function. Well, this isn't the empty list, so we pass this function definition, or function clause. So we go into the second function clause, where the head is the value 2, right? Because what hit here is 1, 2. So value is 1, and 2, or tail, is the list with 2 in it. And what we pass back is that value times 2. And then we call the function again with just that list. So the list with just the item 2 hits the function. It doesn't match the first function clause. It matches the second function clause, where the value is 2 and the tail is the empty list. And so we return 4, and then we call double on the empty list. This time we do hit the first function clause, and just the empty list is returned. So what have we created here? This value, or this empty list, replaces this. And this list replaces this. And that's exactly the list we ended up, because that's equivalent to the list 2, 4. All right, you guys should really get it now. How am I doing time-wise? I'm running low on time, so I'm just gonna put the statement out there that in practice, for commonly used functions like mapping, we use the OTP library that Erlang is generally downloaded with. Using this library makes code a lot more readable, and it's common practice. So that function double we wrote, we could rewrite it using the OTP library by calling the map function on the list map function. I think I'm out of time. I hope you guys will look at this further, play around with it, download Erlang, call it from my modules from the interpreter, and if you want some more resources, there's some great ones out there. The creator of Erlang, Joe Armstrong, wrote a really awesome, also pretty humorous book for a getting started guide. He's creator of Erlang, and he wrote a really funny book that's really well done. And then there's Learn You Some Erlang, and both of these are free resources on the internet, or you could buy them if you wanted. Thank you.
Hello everyone, thanks for having me. My name's Keon Ebrahimi. Right now I'm a master's student at NYU studying computer science, and I'm going to be talking to you guys today about Scheme. It's a little intro to Scheme. And yeah. So, here is my slides. Intro to Scheme, the greatest language that ever was. I am very in love with Scheme. I think you guys will also fall in love with it too. It's really cool. So what is Scheme? Scheme is a functional programming language. I'm sure you guys have heard a lot about those. Scheme's a really cool one. There's two dialects of Lisp, and Scheme is one of those. There's CL, which is Common Lisp, and then there's Scheme. So Lisp was like one of the very first programming languages, like higher programming language. Like it was the second one right after Fortran. So it's really old and super hipster, really cool. And so Scheme is a dialect of that. And it was actually invented to help people like learn how to use functional programming. It's very bare bone. It's like made very simple. The syntax is like pretty easy to understand the flow of things. And I'll go over more reasons why it's so nice to learn functional programming with. But yeah, it was made to learn like how to code functionally. And so this talk I'm going to kind of go over like a lot of the functional programming basics because that's what Scheme was made for. So I feel like that's the best way to get into Scheme. So in Scheme, there's a bunch of expressions, and all expressions are either an atom or a list, so a single element or multiple elements. The way you evaluate these lists is by applying this very first element of that list to the rest of the arguments. The way we iterate as well in Scheme is we don't actually use for loops, we use recursion. You'll see that in, that's what functional programming, that's the power of functional programming. In all these functional programming languages, you're going to see a lot of recursion. And also in Scheme, all these different expressions will be, held in parentheses, and we'll see that here. Cool. So like I said, Scheme everything is an atom or it's a list. Here's how you define and create lists. So as you can see, we start the very first expression with a parentheses, and we say parentheses list 1, 2, 3, 4. Simple as can be, and that returns a list. 1, 2, 3, 4. We can also do the same thing with the apostrophe. 1, 2, 3, 4 gives another list, or quote. Cool. Another cool thing about Scheme is lists can be nested. So as you can see here, we have a list that has, integer 1, 2, another list, and then 5, 6. So some languages, if you have a list, every single element in that list has to be the same type. Like, for example, if you have a list of integers, everything has to be a number. You can't have a list that has single numbers and then also a list inside there. But in Scheme, don't worry about that. You can have a list with single elements and a list has a different element. And so, yeah, it's super basic and easy that way. Whoa, something's going on outside. Cool, so here's how we define variables. So once again, we have these parentheses, and that starts the expression, and we say, we have the keyword define. The next thing it takes is the name of the variable and then what it should store. So here I put, parentheses define x5. That'll store, 5 into x. Then when I run x, it returns 5. Simple as can be. Now with functions, pretty similar as well. We have, parentheses define, and then we give, right here, this next expression is going to be the name of your function and then all of your arguments after that. So I could have, one thing here, 10 things here, and so forth. So here's the name, f, we're taking in x and y, and then here's what we do with that. The next expression here is, we take, we do an addition, and so as you can see, everything, like all our expressions, we're gonna do parentheses and then the name of whatever expression we should run. And so you're used to seeing like x plus y, but in Scheme you do plus, which is, we're doing the addition operator, and then all of its arguments come after. So you're always going to see that. You see the name of the expression and then all of its arguments come afterwards. So here we do, plus x, y. And then here's what happens when we run that. We start our expression, we give the name, which we defined up here, and then our next arguments. X is going to be 5, y3 gives us 8. Cool. Yeah, here's how we do conditionals. And I'm going to go over like all these like basic things and kind of show a couple cooler, applications of this later. But here's how we do conditionals. So first you can do either an if, or if there's more expressions, conditional expression. So the way if works is So the very first expression is going to be something that evaluates to a Boolean. So here we say, okay, if equals x3, so this will give us a true or false. If it's true, we're going to run the command that happens right after, which would be just a string yes, just print that out. And if it's false, it'll run the expression after that first one, so run the second next one, which would be no. So here we define x as 5. We then say, okay, if this, if equals x and 3, which it doesn't, so it'll go to the second expression and return no. So that's for basic ones, you can do that. Conditions with like multiple branches that you can go down, you do it this way. So you have the condition expression, and then you give it multiple expressions after that. So here's the first expression, then second, then third. Cool. The first expression, kind of like the if, what happens is, for each of these expressions, you will start with something that will give you a Boolean, so true or false, just like the previous example. So equals x3 will return s is 3. If that doesn't work, we'll go to the next line. So if it works, it'll print out that x is 3, and we'll end this entire expression and kind of come out. But if that doesn't, if this true is not satisfied, we'll go to the next one, which is this. Cool. So we look at the expression and say, all right, the first element of this expression has to give us a true or false. And so it says, okay, the first element is now this. And so as you can see in Scheme, there's a lot of parentheses, and at first it seems a little jarring, a little kind of busy. But the cool thing about it is you can really very easily tell the order of things that are happening. You're never wondering when each thing is happening. You can easily tell what's first, what's next, and so on and so forth. So cool. So this expression will give us a true or false. We have equals x, and then the second thing that x has to equal is this expression, which is 6 minus 1. So if x equals 5. And then if that's the case, we'll get out of this Boolean and we'll return whatever comes next, which is 5. And what's cool about this example too is, as you can see, here we compare the x's to a number. Here we can also do the exact same thing, but instead we are comparing that x to a whole other function. It's another function call to a subtraction. So as you can see, things get really nested with like functions and functions and calls, and that's kind of how functional goes down. So cool. So this happens, we return 5 if this is true. In our case, we defined x as 5, and so it will actually return this. And after all your conditionals though, you can always have an else, and then if none of the previous ones happen, this will always return true, and then it'll run that. So in our example, we get 5. That is conditionals in Scheme. So as I said earlier, Scheme is, deals with either atoms or lists. Here are different things we can do with lists. Here are little operations. So the first is car. So let's say you have an entire list, and as I said earlier in this little workshop, the way we kind of deal with a list of data is we will take the very first element of that list and kind of use that and recurse through the entire list, and we'll use these operations. So first we have car. And car, if you've done functional before, I'm sure you've heard of like head or things like that. Car is the same thing. It just returns the very first element of your list. So here we start this car expression and we give it a list, 3, 4, 5, 6, and this returns 3. Simple as can be. And then Gitter is pretty much the opposite of car, where car is the head, Gitter is the tail, meaning it is everything excluding the very first element. So it returns a list of all your elements that does not include the head or the very first element. So as you can see, we give a Gitter right here, we give it the list 1, 2, 3, 4, and it returns a list excluding that first car element. So then it gives us 2, 3, 4. Returns a list. Cool. Now here's a cool, functional programming, a little code snippet where we're using car and Gitter to kind of see the power and the beauty of functional programming. So we have a little function that will access the nth element of a list. So if you give it, 5 and then an entire list of a bunch of elements, it'll return whatever the 5th element is in that list. So how do we do that? So as you can see, we have this define, we have this function, and it's going to be called nth, and then everything else after that is going to be the arguments. So n and l. And then, to skip a little bit ahead, we have more calls to nth. This is going to be a recursive call, as we have said earlier. Functional programming, it's all about recursive calls. So this is going to be recursive, and in all recursive calls, you want to have a base case where you return out, and so you don't infinitely go. And so for our base case, we're going to make it so if they want the first element of the list, we'll just return the car, because we know car already does that. Car just gives the first element of the list, and so if n is 1, return that first element. Cool. And for our next expression, because our base case is 1, we're going to try to work our data to get our initial argument down to 1. Because once we hit that 1, we'll hit our base case and we'll finish. So we're going to try to work down. And so if n equals 1 is our base case, we're going to want to make n be smaller and smaller and smaller until we hit that base case. So we'll do the base case, and then if we're not there yet, we'll run this. Else is always true, and then we'll do, cool, we'll have a little recursive call into nth, where the first thing we give, the first argument for nth will be this expression, which is cool, a little function that we're gonna put inside of the call, which is pretty sweet. But yeah, this expression is gonna take our n and minus it by 1. So if our initial n is 5, we're gonna minus by 1 here, and recursively call and give it 4. Cool. And then we're gonna, every time we do that, we want this list to be smaller and smaller and smaller, because we're dealing with the very first element and the rest of the elements. And so so I should rewind a little bit. So in our base case, actually, when we do hit that 1, we'll return the very first element of our list. And so we're going to want to change what the first element of our list will be. As we know, Gitter is going to constantly give us the entire list, but it'll take off the very top element. And so if we are taking off the very first element 5 times, then our next element will be the 6th element, right? And so we want to run this until our n is, so n is going to be minus every single time by 1, and we're going to give it a list that's smaller and smaller and smaller, taking off the first element, first element, first element. And so when we give it here, so we give it 4, right? We say nth, we're going to give it the number 4 and give it this list. And so if we look at the code here, what's going to happen is we're going to say, okay, cool. Does n equal 1 yet? No, it equals 4. Well, then we're going to come in here and see, okay, we're going to recursively call. N is now going to be, 3, because we're going to minus by 1. And the list that we're going to be giving it is now this list. So we'll give it this list, n is 3. We'll do the same thing one more time. Now n is 2 with this list. Okay, cool. Then we'll run it again, and then n will be 1 with this list. Now that n is 1, we're going to say, well, that's our base case, n is 1. Return the car of this list, which is the very first element, which is 8. Awesome. So here's how we find the nth element of a list using functional programming. Yeah, awesome. So then another list operation we can do. So we have car, we have Gitter, and the last one is const. So car and Gitter kind of reads from the list, and you kind of grab an element from the list. Const is how you add elements back onto a list. And so what's going to happen is you're going to give it a single element and a list after that. And const will return an entire list where the first element is kind of added onto the list that you're giving it. So here we say, cool, const, so this expression starts with const. The first argument is our single element, 3. And then our second argument that we're giving it is going to be a list, 4, 5, 6. Const takes the first element, adds it to the list, and we return 3, 4, 5, 6. Sweet. Now we're going to go to a little more complicated, some more cool code you can do. So Scheme has a append where you can give it 2 lists now, and it'll make 1 list, which is pretty close to const, but instead of adding a single element to a list or adding two lists together. So you can use the scheme append, but just to kind of show you how functional programming works and the power of car and Gitter and cons, we're gonna show you our own example of append. Sweet. So here is the define call. We're gonna start a new function. Then we have it called append app, and then L1, L2. So we're gonna have these contain lists. So like in the previous example, we're given the nth item. What we're doing is we're taking off one element of a list, and then kind of recursively taking off another first element, another element, another element, another element, one by one. And so in our append, what we're gonna do is we're gonna have two lists, and we're gonna one by one place things that were in list one and put them into list two. So by the end of this, we're gonna want list two to have all of our elements, and list one will be empty. Cool. Now knowing that, we'll check out our base case. So our base case is this. So we start a condition, so a bunch of ifs, and the first one is right here, and this null question mark tells you if this list is empty or not. And so we'll say, okay, we'll run this little expression, and then the argument is the list. So if this evaluates to true, so as you remember, the conditions, the first thing has to be a Boolean. So if this evaluates to true, we will return the next element, which would be list two. So that's our base case. So if the first list is done, then we'll just return the second list. Now we will actually go into what happens when we're not done yet. So else, so if we're not adding the base case, we will first look at the innermost parentheses, which is right here. So we're gonna take the first element of our unfinished list, and with this, we're gonna run cons. So as you remember, cons will take at a single element and we'll add it onto another list. And so we're doing cons. Car will return a single element, and so this will give us, one element, and then we will append that to the remainder of our first list, and then our list two. So, and I can kind of go over that with this example here. We'll give it 1, 2, 3, and 4, 5, 6. Base case won't hit first. And then what's going to happen is we're going to take the very first element of this list, 1, which we know from here. We'll take this 1, and we're going to add it onto this expression, which is going to be a recursive call of another append call with this being our first list and this being our second list. And so little by little, this is going to empty out. And once that's empty, that'll return, it'll put the 3 there, 2 there, 1 there, and you'll get your appended list. Awesome. We have so map is actually really powerful as well in functional programming. You'll see it a lot, where what a map does is it applies a function to every element of a list. And so now instead of just like taking the list out and adding, or taking an element out of a list and putting it in a new list, you can now do things to those elements in your list. You can, so here's an example where, so map is going to apply a function to every single element of a list. So we're going to just make a simple function. So here we define the function name is f. It's going to have one argument, which is x, and then it's going to run this operation. It's going to add this argument as x, and it'll add it by 3. Cool. So you see we do map, and what map will do is it'll take a function, it'll take a function as its first parameter and a list as its second parameter. And so the function it's taking is this. So it'll add, so here's a list, and it'll take the very first element of this list, 2, and it'll put that into f. So it'll get, okay, 2 plus 3 is 5. Then I'll do next one 4, and so on and so forth. It'll give us a list that'll add 3 to every single element. Cool. And now we can do, oopsies. Here's lambda. Now lambda is a way you can, all lambda is, you hear it a lot, but it's just kind of an in-place function where instead of like defining, a function outside, you can just find it in one line, and it's really cool. So in this map example, we define this function and we ran it here. But instead of just putting the name of a function here, we can just define it in that same line with lambda. And so map, the first thing it takes is a function, which will be right here. Cool, so let's go over what lambda does. Lambda will take, the first expression after lambda will be the arguments, and everything after that will be what it does with those arguments, like what the expression will evaluate to. So it'll say, okay, here's a function that takes an x, it takes an x right here, and then it'll run x times 3. Cool, so here's the function, right there, inline function, lambda. And then our map takes that function, and then it takes a list, and as you can see, this will return that same list where we multiply by 3 on each of those elements. Sweet. Also, here's let. And what let does is it lets us actually use local variables. So let's say there's you have a really complicated function that's going to be using the same data multiple times. You don't want to constantly write out a 10 nested, expression within there. You can just use let, so you can define it once and then keep on using that variable within that function. So we have this, here's an example of that. So we have, define, so we create this function foo, and then, as you remember, after the name comes the variables, and here are the variables for this function. It's going to be this expression. So instead of just being x and y as an individual argument, we're going to define multiple things right here. Anyway, okay, never mind, I didn't mess that up. No, so this function actually has no arguments. It's just called foo, and then within there we're going to define our own little local variables. So it starts with let. Here's going to be everything within the let. The first one will be here. We'll say, okay, x is 3, and then here we'll say y equals, 7 plus 4, so it'll be 11, and then let's see where this ends. So let it should go all the way to here. Awesome, perfect. And then the function will just run this, which is x times y, x is 3, y is 11, so it gives us 33. So that's let, local variables. There's also a let star and a let rec, and all let star does is, let's say you wanted your y, instead of being 7 plus 4, you wanted 7 plus x. If you did a let, it would crash, it would not run. And so instead, you put a let star here, and it knows, okay, there's a recursion going on here. Evaluate this completely before you start setting what y is. So then there's let rec. So as you saw, inputs can also be not just little variables in data, but it can be functions too. So if you're gonna have recursive functions, instead of this little variable here, if you want a function, the lambda function of some sort, you would use let rec here instead. Let rec, and then you could run functions there, so on and so forth. So these are the very basics of functional programming. And yeah, so Scheme was made to help people learn how to functionally program. So hopefully this has kind of helped understand how functional program works. Thanks for having me. I also have something cool I can show you guys. I don't know if I have enough time, but yeah, cool. So here is a little Scheme. Oh, it's kind of small. So here's my Scheme REPL, right? And then I can let's see here. And I can do things like define x and cool, little Scheme REPL, great. There's this thing called Dr. Racket, which I really suggest people to look into if they enjoy Scheme. So Dr. Racket is this cool little IDE, which it's a little debugger for Scheme, which is pretty cool because it's kind of hard to have debugging tools for functional programming and functional code. And so another reason why Scheme is a great tool to learn how to code functionally is it has this debugger and it has this cool IDE that helps you out. So for example, to show you how this works, let's say we'll run a little Fibonacci. I'll show you guys Fibonacci real quick and kind of just show you how the debugger works. So I think, how much time do I have? I can go
like a minute or two.
Okay, so I probably shouldn't go over all this, but I'll just define the n, and we'll just do add. Add 3, add 2, it takes in x and y, and then we'll do plus x, y. Awesome. And then we'll do add. This is a very basic function, but 4 and 9. Awesome. So as you can see in the top right up here, we have a run, which is run it, and it gave us 13 as we see. But let's say for some reason something was not going as we thought. We hit this little debug button up here, and then once you're in debug mode, you can kind of hover over parentheses, and then as you can see when I go over this one, it goes red. I can right click at that point, and I can pause. And so when I run it, it'll actually hit that breakpoint, and it'll say, okay, now here's the stack. So it shows right there, we're in at 2, and then it also should show the variables as well. So first we went into add 2, then we went into addition, and now that we're in addition, which is right here, we have 2 variables, x and y, right here. So add 2, then plus with these variables. And so that can be really nice if you're functional programming and you're like, not sure what's happening. Here's a cool little debugger that'll help you out, and it's called Drucker it. And yeah, thanks so much for having me.
How's it going? Intertubers that are surfing. My name is Jameis, and I'm going to try to teach you a little bit about OCaml today. It's going to be an exciting time. So, I'm going to go over the history a little bit initially and kind of where it comes from and why we have OCaml, etc. But if you want to install it while I am doing that little intro, this is what you do. Hopefully you have a Mac. If not, there might be some other ways, like using Aptitude on Linux. I have no idea what you would do if you have Windows. You probably have bigger problems if you're running Windows. So yeah, and UTOP, so OCaml will install the compilers for OCaml and the byte the bytecode interpreter, and so on and so forth. And OPAM is a package manager for OCaml, and you will use OPAM to install UTOP, which is a wonderful REPL that is far superior to the default OCaml REPL. So I would definitely suggest downloading those. Hopefully you guys got all those commands written down somewhere, because I'm going to keep going. Okay. So OCaml is a functional language, but the O means objective, meaning that it's object-oriented, and it is a functional language while still having imperative paradigms included. It would like you to be functional, and I think it strongly pushes you towards a functional language, but if you want to do something like implementing a doubly linked list, which is pretty hard with a purely functional language, or relatively difficult, you can use their imperative methods for implementing difficult data structures. OCaml stands for Objective Categorical Abstract Machine Language, and apparently abstract machine is no longer part of the language. I don't even know what that part means. It's a derivative of ML, which then became Camel, then Camel Lite, and then Objective Camel, or OCaml, in 1996 by a bunch of French dudes whose names I'm not even going to try to pronounce. It's still run by INRIA, and the French are kind of controlling the language, so yeah, there you go. Which is kind of interesting. You don't get many French programming languages. They're always from like Denmark or something. So the highlights of the language is it is a static typed language, which will make runtime type mismatches impossible unless you're doing I/O and so on and so forth. But it's really convenient, whereas a dynamically typed language like Python or JavaScript, you're constantly running into these typing errors during runtime. Typing errors are pretty much impossible with something like OCaml and Haskell, which is really, really nice for the programmer. But if you're programming in shitty languages like C++ or Java, it's just horrendously ugly, and the syntax is like rough, and you always have to do type declarations. But OCaml has type inference, which gives you the same feel of a dynamically typed language. It's really easy to read. It's terse, really compact. Not quite as terse as Haskell, but very terse, very powerful, really flexible syntax and grammar. It's a pretty fun language. Haskell's, in my opinion, a little more beautiful, but OCaml provides the imperative functionality that Haskell has chosen not to provide, and that's, I believe, why a lot of industry, it's starting to be popular in industry. Actually, probably not as much as Haskell, but you get the point. Parametric polymorphism aids in writing really expressive functions, similar to something like generics in C++. And then exhaustive pattern matching. It'll warn you, if you're not familiar with functional programming, I'm going to show you what pattern matching is, and it will warn you if you have not exhausted all of your options, kind of like saying you need to cover every case so that you don't shoot yourself in the foot. And it's got a ton of compilers, bytecode interpreter, it can compile a bunch of different platforms, so they provide a lot of tools with OCaml. It's pretty wonderful. So we're going to do some example code. I want to thank Professor Stephen Edwards of Columbia, because I kind of yanked this from his slide. He teaches the programming languages and translators course that I'm enrolled in right now, and he uses OCaml because OCaml is awesome, and Edwards is awesome. Therefore, you get the point. So this is, right here is a typical function declaration. Functions are first-class citizens, so you would basically declare a variable in the same way. This rec, just ignore it. It just means that map is a recursive function. If it was not a recursive function, we could just remove it. So let map is the name of the function that we are creating, and f is a function that we are passing in. It's a parameter. Now imagine that there's another parameter right here that's missing that we're passing in, and it basically gets matched on these cases. So these vertical bars are for pattern matching. And what we're going to be doing is we're going to be passing map. We're going to be passing map both a function and a list. And it's going to apply that function to every element in the list. So we're going to be pattern matching on a list. And this first pattern is kind of like the short circuit case for recursion. It's basically saying you're done. You're not going to make any more recursive calls. And if you're familiar with functional programming, the end of a list is the empty list, essentially. So this is saying once we've mapped over every element in the list, the next element we pass into map will be the empty list, and we will just return the empty list. So this is the short circuit, which will become more clear as I explain the next case. The next case is basically doing a pattern match on the list with the head of the list and the remaining elements of the list, known as the tail. And this is the cons operator. Basically, it's concatenating, it's prepending to a list. Like I could do one and then a list, and that would prepend one to the list. But this is how you pattern match, and it will store the head of the list and the tail end of the list in these variables. And then I can say locally I can scope the variable r and say let r be the function applied to the head element in r prepended to the recursive call. So at one element at a time, we're going to apply f to one element at a time, and we're going to recursively call map while appending it to the list. And you can start to get the feel of how terse this language really can be. You know, we're doing the short circuit in one line, or the base case, same difference. We're doing pattern matching, setting the variables, and taking care of a certain case, local scoping, and we're doing a recursive call and appending to a list all in one go. It's extremely terse. If you try to implement this in something like Python, it'll probably be 10, 15 lines. This is also clarifying what is happening here. List.map is OCaml's implementation of map. And if I just call it in the REPL, this is shorthand for just putting it in the REPL, it will output the type of map. So map takes a function whose type is A, which means it can be any type, and whose output type is B. So this means take a function that takes in one parameter and outputs another parameter of different types. They could be the same, they could be different. And also take in a list as the next argument, and then you will eventually output a list of type B. So list of type A, list of type B, and this is the function you're going to apply to every element in the list. And then last of all, this little apostrophe means that once something has been applied to the function, that function now has a specific type. So I'll explain that in just a moment. But if I do list.map and I define a anonymous function right here, this is the syntax for defining an anonymous function. This states take in the element, take in one parameter, and then add 3 to it. And then this is the syntax for a list. So, and if you're not familiar with functional languages, you'll notice that there are no parentheses surrounding the inputs to this function list.map. That's just how it is in a lot of functional languages. But basically I'm passing, this is the first parameter to list.map, and this list is the second parameter to list.map. And the output is 4, 8, 12, it's added 3 to every element. Now we can do something called currying of functions. And so I'm going to use a function, and I'm going to partially apply the anonymous function to list.map just to the first parameter. And the second parameter is still not going to be applied yet. So we're currying a function, we're applying one of the parameters, and the other parameter hasn't been applied yet, and it will return a function that we can now use in the future. So I create a function called add5. Oh, I have an error. This is supposed to be 5. I'll change that later. But basically, I wanted to create a function that will add 5 to a list. So I've curried the function list.map with an anonymous function, And then later I can use add.5 and I can apply it to any list I want. And it will add 5, or in this case 3. Right, moving forward. I think I got everything. Okay. So this is kind of, OCaml's used a lot for compilers because it's really powerful with typing, just like most functional languages like to be, and statically typed languages, and so on and so forth. And this is kind of the basic syntax for defining types. And you can imagine defining a type in something like C, and how many more lines you would have to have, or something like Java, like an object-oriented language, how many more lines you would have to have just to do what is done here in one line. But I created a type called op. Let's call that an operator. And an operator can have type add, subtract, multiply, or divide. So, right, pretty self-explanatory. And these are just, they're not strings, they're just a type. And then an expression can be either a literal, which is of type integer. So int is inside of OCaml. Literal is something we're defining as a name. And these are all names we're defining. But lit has a specific type of integer. Or it could be a binary operation and this is a tuple. This is how you define a tuple. And it can be a binary operation of an expression, an operator, and an expression. Now you notice that this type is self-referential. So while I'm defining the type expression, I am simultaneously using it in the definition. It's pretty fucking awesome, if you ask me. And it's just so terse, it's just wonderful. And just as an example, I say let one equal the literal. So this is the constructor essentially for the type. I believe that's the right term, constructor. So I create one, and forever an operator is bound to, an expression is bound to this variable 1. And then I can say 2, literal 2. And then we know that the constructor for the other constructor for an expression is using binary operator. So now I can use 1 because it's an expression, and I can use 2 because it's an expression, and I use the constructor add for the op type, and I can create a new expression of named 3. So you can kind of, this is really, really small example, but you can kind of see the power of typing in OCaml. It's pretty wonderful. So here's a simple example of memoization. Actually not too simple, but it's just a cool example. I grabbed it from the really, really wonderful book, Real World OCaml by O'Reilly. It's free online. It's pretty similar to something like Real World Haskell. But we're going to create this this memoize function. I guess it's a function. And basically it's going to take any function and it's going to make it memoizable. So if you're not familiar with memoization, basically the first time you put in parameters, you'll calculate a result, and that might take a long time. But the second time you put in those same parameters, it's going to be constant time to access that that return type, or that return value, because it has stored it in a hash table. And this is just, it's sort of like a Python decorator, in that you can take any general function, pass it to memoize, and now that function will be memoizable, or it memoizes. I don't even know how to conjugate memoize, but you get the point. So we create a new hash table, and essentially we use this optional type called sum or none, which is probably just what the hash table find function returns, is sum or none, meaning null, or you have some bucket with a value in it, like 1 or a string. And you just run a match and check first if it's in there, in the hash table. If it is, just return the value. Otherwise, run the function on X. And then once you've run the function on X, you will add it to your hash table. See? And this is just a named parameter, the tilde. You can also do optional parameters, Very cool. And then we just define a slow Fibonacci, recursive Fibonacci function for calculating the nth Fibonacci or the ith Fibonacci in the Fibonacci sequence. Right, one-liner, bam, may not be efficient, but it's pretty cool. You can do that just right there, one line. So in our REPL, just to show you the memorize type, it takes a function, just like before, and then it just takes a parameter, a single parameter of type int or type string, and it'll output a parameter of int or type string, and that type will be decided upon the first application because of this little apostrophe, remember. But this is wonderful because this is polymorphic, really simple polymorphic, parametric polymorphism. It's really, really simple as opposed to something junky like C++ or Java. It's just a nightmare. Then we see the type fib, which is int, right, which matches this type signature.
Your screen cut out.
Good?
Unplug it, replug it.
Unplug it. Sorry, folks. Give us 1 second. Go now.
Nothing.
Can you go to the desktop real quick?
Any luck?
No. Why did it cut out? Try your laptop to make sure it's not Look at yours either.
Okay.
When I go up a card, it says
You want to put on the pause music?
technical difficulties. Please hold.
Great.
Sweet.
Okay, you are.
You're good.
Wait like 30 seconds. We're gonna go live.
No, you're good. Wait, 5.
There you go.
Good?
Yeah, all right.
Okay, cool. Technical difficulties, no problem. Okay, so we got this wonderful polymorphic memorize function that will memorize other functions. And this is showing the type signature of Fibonacci. It takes an int, returns an int. And so you'll see here, we're just going to rebind the term fib to be memorize fib. And you see it still returns the exact same type signature. And it has decided to no longer be polymorphic. And has decided to be take an int and return an int. And you will time the lookup for 40. Bam, it takes 5 seconds, pretty slow, inefficient. It's a pretty big Fibonacci number. And then we run it again, fib 40, and it's pretty much instantaneous, the lookup. It's pretty fun. Good example of wrapping functions. Here I've got one more code example, a little more complex pattern matching. So this is code for removing sequential items that are sequential that are the same value. Really messing that up. Items in a list, if they're neighbors, they're adjacent and they are the same value, it'll remove them and just turn it into one value. So you can see this is super, super compact. And this is saying, it's basically going to take in a list and it's going to pattern match on, this first case is saying, pattern match on either the empty list, which is the last value while you're iterating through the list. Again, this is the base case. Or match on the second to last value, because since we're looking ahead one value, we don't want to look past the end of the list. And we're just going to rename this match as list. Just, nice little syntax. they have. And then just return, in this case, just return what you just matched on. It's pretty much the identity for two separate cases. Otherwise, match the head, and then this whole thing is matching on the tail, and we do a sub pattern match within that, where we match the second element in the list, or the head of the tail, and then we match on the remaining part of the tail, which we don't need, that's why we use underscore. And then we rename this entire thing. We could just name it tail, or we could name it X's, or whatever, right? I can't type for some reason. Dang it, well, that's too bad. That's supposed to be X's. And then you just say if X is equal to X2, if the head is equal to the next element, then don't include the first head element and just keep going with unique. Keep recursively calling unique with the tail, the entire tail. Otherwise, do append the element because it's not the same as its neighbor and continue with the recursive call on the tail. I mean, this is so unbelievably terse. 4 lines. It's so ridiculously terse. It's just wonderful. I love it. And you can see the type signature again. Show you an example. We're calling unique on this long list, and it just removes all of the values who are the same value next to each other. And we could. This is also polymorphic, so we could use this unique function on a list of strings right here. Pretty clean, pretty sweet. That's it for the code examples, but just want to talk about the ecosystem really quick. They've got tons and tons of tools. You can run OCaml dep on a project and it'll generate a make portion of your make file for dependencies. It's really slick. And then OCaml opt, native code compiler for tons of different native environments. There's a bytecode compiler. I've never used OCaml debug, but they've, because the compiler is so robust, I can see all the errors anyway. But it's supposed to be really nice. OPAM, the package manager, utop, we already talked about that. You gotta use utop, don't use the built-in OCaml REPL. Core is a library that re-implements OCaml's standard library. It's what they use in real-world OCaml, and it's used, I'm sure, all over the place. I haven't used it that much. We didn't use it in our class. We just used the built-ins rather than core. Merlin is a code completion tool for Vim and Emacs, and you can plug it in with Syntastic if you are a Vim user. And OCaml Lex and OCaml Yak. These are tools for building grammars, for building parsers and building scanners. We're using it in my compiler class right now. It does all the dirty work of, building all the automata to handle scanning and parsing your code. And you can define compilers really easily. It's really cool. And that is why Facebook used OCaml to create Flow, which is their new static type checker for JavaScript. Really slick. JavaScript, a lot of runtime errors due to passing in a string where it expected an integer. And you don't like runtime errors, and so this, with Flow, you can do a static analysis. You can do type annotations in your JavaScript, or it can also infer the type. For example, right here, we just have a little decorator that says Flow, and it says, hey, I recognize the fact that this is going to return an integer. And then in our code, we're calling hello world, and it's saying, hey dude, Flow, this type is incompatible. So it analyzes your code and can, help prevent you from shooting yourself in the foot. If you want to install Flow, just download the OCaml package manager, OPAM, install Flow type. Simple as that. Jane Street is also the second big company that uses OCaml. They're the biggest, largest industrial user of OCaml. They're a quantitative trading firm here in New York City. They build core, and this is their wonderful blog. The link is in the slides, but you are watching this on YouTube, so you can't click on that link. But just Google it if you want to read more about OCaml. And then the last thing I wanted to say is, if you want to learn OCaml, seriously, all you need is real-world OCaml. I mean, you'll need more later, and you'll need Stack Overflow, and maybe ocaml.org is a good resource too. But real world OCaml is gigantic, and it's got everything in there. And it uses core, and it does everything. Just read that book, and you'll be an OCaml god. That's all you really need. You probably need some love too. And last, I just want to thank Major League Hacking. You guys are sweet. And thank you, Shy, especially, for working hard. Thanks to everyone else at MLH who's working hard, whose name I don't know. And last, I just want to plug Hack and Y. I love Hack and Y. So if you're out there, apply for the Hack and Y Fellowship. I did it last summer, and it's just the greatest experience you could ever have. As long as you like New York City, you're gonna love it. So I think that's it. Thanks.
John says that.
Thanks. I hear you guys now on the screen. I still don't hear them.
Yes.
Can you guys talk? Any of you?
Why are you not speaking?
What is that sound?
Is that Leo?
No, it's gotta be me.
Oh.
Maybe. Can't tell.
Hello? I don't hear anything. I hear like really distorted sound. What the fuck?
Yeah, where is that coming from? Alright, my microphone is now muted.
What do you want to tell
You can talk to the world, I can hear you.
Hello,
we're having technical difficulties.
Hello, we're experiencing technical difficulties.
Hi.
Welcome.
Hello, this is the stage meetup.
Definitely scratches like messed up, dude. Someone should like do a spiel or something.
Oh, are we still on stream?
Oh, yeah.
Oh.
We're gonna fix technical difficulties. You guys hang out and do your thing.
Yo, this is the LSH meetup. Sort of. We're experiencing technical difficulties right now. And we'll let you know what's going on as soon as we do too.
Okay, who am I calling here? Ashley and Taylor?
Yes.
Do you guys have any jokes to tell?
Oh, I have so many jokes.
John, tell us some jokes.
What do you call Emilio Estevez getting fancy?
What?
Emilio Vestevez.
Ayo!
Not that good, not that
It's
good.
got real. Okay, wait. This is loading. Why is it working?
I don't know. I feel like a fool, but we're gonna roll with it.
Wait for it.
My Skype shit.
Yeah, dude, something is messed up right here.
John's Skype is just
Fucked
I'm
up.
just sitting here
Just like hang,
pretending
like,
that I'm
tell
doing
more
something.
jokes.
Let me Google them.
You need to Google.
How appropriate.
Do we have any announcements for Lady Scrum Hackathon? This will be the best opportunity to
You guys are so loud, by the way.
Yeah,
Oh,
I
we
know.
are? Okay.
Good.
So
Skype is like
something that would be really that's pretty exciting is I think in December we're going to start the website, so that's pretty fun.
There's gonna be a website?
Yeah. that's
What?
exciting.
What's gonna be on this website?
Whatever people want. It's going to be like very community driven. So whatever the community does, then that's what's gonna happen.
Nice.
And I'll just kind of like sit behind the scenes and be like, what's going on? And
But it's gonna have all the resources, right? We should.
it'll have the resources, maybe like put up a calendar or something, and then definitely there's some girls that wanted to run a newsletter, so that'll be definitely related.
Well,
So-
this is a good time to do like a call to action. Tell them to get involved. Why should they help?
Pitch me.
Because the community is awesome, and a lot of the momentum isn't even like from anyone here. It's just the community that just pushed this all, and it's really fun. And networking is awesome, and making friends is awesome.
What
So
are
what's-
some features in the website?
So I mean, it hasn't like started yet. We're just I just know that there's interest. So probably what's gonna happen is that there's gonna be like a newsletter-esque sort of thing. So
So what do you need help with? Or what do you want people?
Research building on our research park campus. So
if you did a Halloween theme, that would be so awesome.
That's pretty much where YHack is. Like in an abandoned building.
Nice. Texas, you guys go.
Okay. Hey, I'm Taylor Barnett. I'm a senior computer science major. Business minor. I organized Hack Texas the last 2 years, and yeah, I'm really happy this happened, even though technical difficulties. And yeah.
I'm Kelly Wilson. I'm a senior computer science major, and I'm just here hanging out and doing stuff.
I'm Peyton Sarmiento. I'm a sophomore, and I'm CS Washington, and I'm just here working on school and stuff.
Awesome. I guess we can go around too. Brynn's here.
Hi. Sorry, this is the awkward position. I'm Brynn Claypoole. I'm a senior at the University of Pennsylvania, and I was the director of Pen Apps for a year ago.
Awesome.
Hi, I'm Megan. I go to UNC, that's the University of North Carolina, and I organize Pearl Hacks, which all of you should come to in March, and I'm a senior, I guess. That's a thing.
Awesome. Hi guys, I'm Amy, and I troll the internet, and I'm a junior studying computer science. I did organize a hackathon before, but now I just do internet things. Your turn.
Hi everyone, I'm Nicole. I'm a student at Southern Connecticut State University, and I love web development. So, yeah.
You love JavaScript too, right?
I do love JavaScript.
Hi, I'm Francesca. I'm a freshman at Stevens Institute of Technology, and I'm studying CS.
I'm really glad that Megan brought you along because
Nothing interesting. I don't really have anything to say.
No,
She's the coolest.
She's pretty cool. Lee, come in and say hi.
Can they all see me?
Hey guys, I'm Lee from
MLH. I graduated already, so I don't have that information to share. I do a lot of stuff here at MLH. We wear many hats. If you have any questions about your hackathon, I've recognized some faces, but if you just want to email me at lee@mlh.io, feel free to come and say hi.
He's pretty awesome. But yeah, cool. So, John, did you want to, because you're in the call, did you want to say hi? Hi, John. Oh, okay. Sorry, that's awkward. Say hello to the world, John. Also, so I mean, so something like that. I guess I wanted to come from, like, for us to all sort of be able to like feel like we can reach out to each other and like share information. For instance, Leo, like we have what? So Taylor's an organizer, Ashley's an organizer, Brynn was an organizer and still like leading, and Megan was an organizer. So for instance, like if you need any help for your hackathon, like there's so many.
Boom.
Yeah. So like Emily doing it. So yeah. So that's one thing. And also, I guess we could talk about like hacks we've done. Is that cool with everyone, or like this is pretty casual? So just whatever people wanted to talk about.
I'm good with whatever.
So we're actually. So I came with Nicole, Jessica, and Megan, and we came to the Google Hackathon, and we're doing a hack right now.
Yay!
Hack for humanity! Yeah, well, because you're the newbie, so I'm picking on you.
It's also your idea. No, it's not. No, I'm pretty sure you were the one
Oh yeah,
recording
this is
that.
your first hackathon, so it's
Oh, nice. Congrats.
Yeah. So we're creating a tool that can be used in sort of emergency situations because we found that during a lot of emergency situations, such as, I don't know, like hurricanes or other natural disasters, there's a lot of information on Twitter and a lot of people tweeting, and this information is really valuable to governments, especially when they need to deploy resources or, you know, kind of figure out what's going on. But there's really no way for them to kind of access this information. So we're creating a tool that bridges this gap.
This is my friend Nick. He goes to a lot of hackathons.
I like your cat too.
Ricky, do you want to say hi? Hold on. This is my friend Rick. Yeah. Ricky, do you want to... Ricky, you're embarrassing me in front of my friends. Wait, how'd they get an MLH banner? They're at some Google thing.
Because we're badass, yo.
Word.
Yeah, cool.
Do you want to finish?
Yeah, that's pretty much it. Cool. We're gonna be up all night.
Yeah.
I have a timer going. We have 20 hours and 1 minute. Please send it.
I'm sorry, we're doing a lot of dumb stuff over here.
Awesome. I mean,
Damn it. Hold on, so I'm...
Mute yourself.
Are you having a moment there? Like,
Having a moment.
He had to mute himself.
Another thing that would be cool to talk about, I guess, is like the website. If people want to talk about it, like.
Oh yeah.
We can also talk about what we worked on today too.
Oh, awesome! Yeah.
I'll go first. Yeah. So today I had a few things I needed to do, but one of the things was I took one of my Flask applications that I wrote like over a year ago when I was very, very first learning like Python and Flask, and I did a lot of things horribly. Like I didn't have a config file and a lot of other ugly things. And I'm working on improving it, and then I'm going to try to add to the application. It was a really simple one. I'm shocked it still works on Heroku. Like I went to the website that it's at, and it's actually up. But yeah, so that's what I worked on, and helped a few other people work on a few things. Yeah.
And then I guess I kind of worked on the same thing. I worked with like learning Flask and Python and like learning to make web apps and stuff. So yeah, Taylor helped me.
Awesome. So what was the premise of the app that you were working on?
So like mine was like one of my first using the Twilio API, and so it was like super simple. It was just basically me being able to see like in 5 minutes can I like use this API that I had never used before, and so it would just like you typed in your name and your phone number and it just texted like hello to you. But I'm kind of working on like what else I can like actually add to it, and probably I'm gonna add like a bunch of other APIs just to make it like a mass like tester app of APIs. I can also like show to people as examples for those APIs. But yeah, that's what I was working on.
Awesome.
And I guess I was working on just like using templates to like make forms and stuff.
Good.
Oh, so did you see John's message to you, Taylor? Or maybe Mike's?
Like, I'm hot right now. Like, I don't think I, like, if I wear a hat, like, I'm gonna, like, start sweating. But I
It's still not
It's 32 degrees the other day, but it's like
Did you get the
75.
email about the new homework?
Yeah.
Oh, by the way,
Remember those mod techniques? I don't.
I have to comment about, like,
Say hi.
because this is the softest sweatshirt I've ever owned in my entire life. Like,
What are they showing off?
it's like the best freaking snack ever. And also, this is the first hackathon that I've ever had a shower at. Pretty cool.
Yeah.
Neat.
But yeah, it was interesting.
That like needs to be a thing at every house. Like you have nail clippers.
It was like unbelievable, but it was
And blankets.
the blanket.
Socks.
Yeah. Basically, we're just like in awe with like the snack that they just dumped on us, and we're just like.
There's gonna be more. We have to get back. We might miss
It's just
Are they really?
That's the solution we've been waiting for.
I have to take Are you kidding, Ron?
Wait, shit. Is it like?
So, I mean, did you work on anything today?
I don't know how you can tell.
Wait, me?
Yeah.
Oh yeah. So today I spent the day messing around with Haskell. I'm making a small game with it, but the code's pretty janky. But I'm learning a lot of stuff. It was pretty cool.
Also, I was kind of curious, like in terms of like the scene at your school, like are there a lot of people interested in hackathons and like traveling and things?
At Wisconsin, there's kind of like a core group of people. Not like a huge hacker school like I don't know, like pretty much every other Big Ten school, which kind of sucks. But yeah, this is like the room we're in tonight. There's not a lot of us here, but I don't know. We're having a good time.
I mean, seed the group and then hackers will come.
Yeah, we're trying to do some stuff next semester.
So, yeah.
I talked with some guys at Wild Hacks. James Mishra, he was supposed to be in this chat, and then Halal at Illinois, and they gave me some good tips. Like they said that we should start doing like bi-monthly like micro hackathons, kind of like 100 people, even if we can get that and just get a couple companies and kind of to sponsor pizza or something.
I mean, do you guys do like workshops and things?
Wait, like workshops, or is that what you said?
Yeah.
Not really. So I'm one of the chords for the undergrad lab, and every Friday night we work on games, but that's kind of the only thing that our department really does.
I mean that's cool. I mean, because it's just like whatever people are interested in, I guess. But for
Do you guys want to demo what you guys want to do?
all the workshops, so I guess doing some of this.
Mm-hmm.
Honestly, digital hats equal less warm than the hats.
Nice.
Oh.
Wait, how did is that like
Recording.
Like, can you like throw your head to the left and see if it like throws over?
Try it.
Yeah.
Well, it has to be able to detect your face, so like get your face there.
Oh, nice.
Oh, cool.
Oh my god, that's great. Daniel.
Wait, it does like This is really entertaining for some reason.
No, but actually though.
Oh, someone joined us. Wait.
Hello.
Oh, it's Needy. I think. Oh no.
He's gone.
All right. I mean, was there anything anyone wanted to add, or we're good? I want to show my shirt.
Oh, the heck.
Ashley!
Yeah?
Alex!
Yay!
Thank you so much. It's so cute. We gave out.
I kind of want to know how to do like 2D stuff first. You have that.
Awesome. I mean, I think today went well. We should definitely do more of these in the future.
Yeah, absolutely.
I think next time, definitely what's going to happen is
We should do it. We should do it like in between schools. That'd be pretty cool. We should do it in between schools. Like for example, like Duke and like UT Austin. Like we can do like kind of like
one of them was
you
know, yeah, like workshops together or just like asking each other questions or like whatever.
This is actually also an awesome opportunity to get like your feedback on things because like sometimes it's just like doing sort of like admin things, just like once in a while like posting things on our pages. Like what kind of things do you guys want to see happen and like how can we get more people to step up to like do these things instead of it just being like one like a few dominant voices all the time. You know what I mean? Like that's something I kind of want to happen because I'm gonna be a senior next year and like gonna graduate soon. So at some point, the leadership needs to be like passed down. So I was just wondering like what kind of things you wanted to see like, in the group. If anyone had any suggestions.
So reach out to Amy if you want to start helping out.
Yes, please. I'm begging you. Like I'm throwing away responsibility.
She's not organizing, so you got to do something else. No, I'm just kidding.
What?
Ouch. No, I'm kidding.
But I mean, yeah, like honestly, like if any of you guys want to do anything, just like reach out to me and I will make admin. Honestly, like if you guys like are pretty active and I'll gladly take you active. And that's like something that I really want to see like for this next year is to like transition to another main voice to be able to. That is so distracting.
Sorry.
No, it's wonderful. You like clicked on your icon explicitly because you guys had the hat. So we can.
Is that a cowboy hat?
Yeah.
Stereotypes here. Come on.
Hey,
howdy.
Okay,
Nice.
I'll delete that one.
Nice. So, okay, is that it? We're gonna get back to.
Sounds good.
And my computer's about to die. So, yeah.
All right. Bye, everyone.
See you guys. Bye.
Bye.
you. If you live at home with your mama, oh yes, son, I'm talking to you. If you have a shorty that you don't show love, oh yes, son, I'm talking to you. Wanna get with me with no money? Oh no, I don't want no scrub. No scrub. No, no. Scrub. No, 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 no. Scrub. No, no. No, I don't want no scrub. The scrub is a guy that can't get no love from me. Hanging out the passenger side of his best friend's ride, trying to holler at me. I don't want no scrub. The scrub is a guy that can't get no love from me. Hanging out the passenger side of his best friend's ride, trying to holler at me. I don't want no scrub. The scrub is a guy that can't get no love from me. Hanging out the passenger side of his best friend's ride, trying to holler at me. I don't want no scrub. The scrub is a guy that can't get no love from me. Hanging out the passenger side of his best friend's ride, trying to holler at me. I don't want no scrub. The scrub is a guy that can't get no love from me. Hanging out the passenger side of his best friend's ride, trying to holler at me. I don't want no scrub. A scrub is a guy that can't get no love from me. Hanging out the passenger side of his best friend's ride, trying to holler at me. I don't want no scrub. A scrub is a guy that can't get no love from me. Hanging out the passenger side of his best friend's ride, trying to holler at me. I don't want no scrub. A scrub is a guy that can't get no love from me. Hanging out the passenger side of his
Hookah chaka, hookah, hookah, hookah chaka, hookah, hookah, hookah chaka, hookah, hookah, hookah chaka, hookah, hookah.
I can't stop this feeling deep inside of me. Girl, you just don't realize what you do to me. When you hold me in your arms so tight, you let me know everything's alright. I'm hooked on a feeling. I'm high on believing that you're in love with me. Lips as sweet as candy, its taste is on my mind. Girl, you got me thirsty for another cup of wine. Got a bug from you, girl, but I don't need no cure. I just stay a victim if I can for sure. All the good love when we're all alone. Keep it up, girl. Yeah, you turn me on. I'm hooked on a feeling. I'm high on believing that you're in love with me. All the good love when we're all alone. Keep it up, girl. Yeah, you turn me on. I'm hooked on a feeling. I'm high on believing that you're in love with me. I'm hooked on a feeling, and I'm high on believing that you're in love with me. I said I'm hooked on a feeling, ride. Best trip, always. I know you'll be at my show, watching, waiting, commiserating. Say it ain't so, I will not go. Turn the lights off, carry me home. Late night, come home, work sucks, I know. She left me roses by the stairs. Surprises let me know she cares. Say it ain't so, I will not go. Turn the lights off, carry me home. Say it ain't so, I will not go. Turn the lights off, carry me home. Keep your head still, I'll be your thrill. The night will go on, a little windmill. Say it ain't so, I will not go. Turn the lights off, carry me home. Keep your head still, I'll be your thrill. The night will go on, the night will go on, a little windmill.
One, two, get down. Paid the cost to be the boss. Paid the cost to be the boss. I paid the cost to be the boss. Look at me. You know what you see. You see a bad mother. Look at me, know what you see? See a bad mother. Paid the cost to be the boss. Paid the cost to be the boss. Look at me, know what you see? See a bad mother. Told you so. Having fun, got money to burn. 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 'Cause he paid the cost to be the boss. Paid the cost to be the boss. Paid the cost to be the boss. Cross the tracks, turned my back. Cross the tracks, turned my back. Paid the cost to be the boss. I'm a bad mother.
works! Oh my god, that's amazing. It's never worked. Who is watching videos?
Hey everyone, we're live. We're going live in just a little.
Everyone else. So we had about 21 people register and only 8 show up.
Hey TJ. TJ, you there? Hello. It's TJ. What school are you? Yes, I'm here. Can you hear me? Yeah. Can you not hear me? Shh. Hello. I can hear you fine. I'm used to the volume. What school are you? Yes. I can still hear you. What school are you from? We are San Marcos High School. San Marcos High School. What school are you from? San Marcos High School. Oh, this is so laggy. All right, we're going live. That is so laggy.
Oh my god.
All right, we're going. Make sure that the audio is turned off on your live stream. I'm trying to fix the internet so it's not so laggy. Make sure that the audio is turned off on your live stream. Yeah, it is. Yeah, I already turned it off. Tell my dad to stop playing TF2 for now. Guys, stop playing TF2.
Okay.
Turn off TF2 right now.
Shutting down.
Turn off TF2.
It's off.
Yeah.
No, I'm just gonna have Steve right there. No, do not. I swear to God, Pierce. I will ban you.
Pierce, don't you dare you speak on that.
No! Pierce, get back in here. No!
Show your brother.
Pierce, get back in here.
We're live? It's chaos here. Hey, TJ. We're live?
Here.
Hey, TJ. Hi. Hold on. Let me guess. We have San Marcos High School here. TJ, do you want to walk us around your house? So it's basically. TJ, do you want to walk us around your house? Sure, hold on. Let me get to the Skype call because it's being back. There we go. Oh, there we go. Okay, can you still hear me? I can still hear you. Yeah, it's live. Can you hear me?
Yes.
Okay, good.
Can you see anything?
I can, yeah, you can probably see. Where's your hat? Oh, there we go. There we go. I can see now. There. You're missing a hat. Sorry, technical difficulties. So, hi. And oh, we got hot dogs. So we're having hot dogs for dinner right now. That's awesome. This is the main lobby for everyone. This is where we cast the music, have coffee, and put the food and drinks. It's where everyone comes out. We're taking breaks. Is that your high school? No, this is Cyber Hive. It's a different venue. Makerspace? Yeah. That's awesome. So, here we have our office where we hide the hats so nobody takes them all. You should put one on. What? Put a hat on. Okay, let's put our hat.
Okay. We all have our hats on.
I have my hats on.
Okay.
Yay!
Hats.
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 Here's his hat on.
It's Team Fortress 2 all over again. Oh my god.
Hats.
It's hats for
CF2 going wild.
Actually, we nobody here is actually from San Marcos High School. Wait, Luke, are you from San Marcos High
Yeah,
School?
he's from San Marcos.
What's up?
I'm
This
the
is
only
the-
one from San Marcos Technically, me High. and TJ are from Cal State San Marcos.
Technically, yeah.
Yeah.
So, we're going down the hall.
Everywhere.
Of the main hack space here, which everyone just comes sit down and shows each other projects. And we usually have the live stream going on that TV. So. What's your favorite talk been so far today? Node.js.
It's a good choice.
It's actually my roommate who gave that talk. Fun fact. Don't erase Maggie's stuff. Dante, okay. Guys, what was your favorite talk?
My favorite talk was probably the well, they were the only ones they really paid attention to was the one I thought
the Oculus Rift.
Yeah, the Oculus.
Yeah, everyone liked the Oculus Rift talk.
Yeah.
It's a good one. Yes, Scott is a great programmer. He's really good. So.
Microwave.
And
We got something. We got
what?
a high quality microwave right here. Yeah, I haven't really used yet.
So James, what are you working on?
I am working on a map actually.
So he is working on a Team Fortress 2 map.
Yeah, that's pretty cool.
Yeah.
Can we see it? Can you zoom in?
Yeah, James.
Yeah, here.
Can you
It's
see it?
not nearly finished. It's got lots of. It needs to be smaller and also better in every way.
Try playing it while me going like this.
It's gonna take an
Oh,
hour.
it's gonna
take hours to load. Trust me. So just.
Okay, I guess we'll
next time. Hey, thanks, TJ. It was great checking in with you. We're gonna call our next venue.
All right, bye.
Project that we're showing.
Hold on, I don't think we're. Oh, so we are now live with Penn State. Albert, give us an update.
Awesome. Okay, so this is Dan. Dan can't see you guys because he is.
There's a mountain where you guys are.
Yeah, that's basically why. There's a mountain. But he made like a little trick on his Oculus Rift headset such that you don't need like a power source and you don't need it connected to a well, you need it connected to a laptop, but you can carry it around with you, which is
Well, so the Rift and your computer separately need power sources, which kind of limit your experience using the Rift. So I have made it so the Rift does not need a power source.
How have you done that?
It still needs a power source, but the power source is portable. And if I had a laptop charger, that I could just basically, I mean, you can see I have full versatility of motion.
Yep.
Which adds to the experience. And I mean, I don't know if Albert can move the computer around, but like there's no, sorry, I just hit off.
Goddamn.
There's no laptop that I have to have anywhere here. And I can actually, if I had like a pad, then I could, or I don't even know if you can do it with leap motion, but basically the only thing left really is the movement of your legs to, go into the game.
Mm-hmm.
Otherwise, I mean, you are free to walk around to your heart's content, which is something that I'm also afraid to do in real life, because here I see what's going on.
I feel like you should be more afraid to be in virtual reality while you're in real life.
Oh yeah, no, it honestly does.
How close has he gotten to hitting walls?
He's hit walls.
I've hit walls.
Yeah. Yeah.
Oh my God, Jesus Christ.
Yeah, he's like about to trip over something.
Oh my God. Oh.
Dan, you should just stay entirely still.
All right,
okay,
so the bungee jump was, I've never done it. Holy crap. Oh my God. I had to close my eyes there for a second, sorry.
We were playing with it earlier and we pushed someone who was currently.
I pushed Albert.
Yeah, they were I was falling, and at the moment I was falling, he decided it'd be funny to push me. It feels really real, by the way.
It's very odd.
Oh gosh.
Is it like a trust fall?
Do it.
Did someone catch you?
No, I just basically got back up. Yeah.
But so yeah, now I'm like, I definitely feel like this is definitely a lot more real.
Yeah. The power source that we use for the Oculus is actually just, you know, those like Facebook swag, like battery packs that they give out? That's what's running the Oculus right now. So, yep.
But yeah.
Did anyone else build anything exciting?
Not really. A lot of people were like working on homework. People cycled in and out, etc., etc. So this was about it.
Also, you're not wearing a hat.
Something over
What's up?
there. Wherever Charlie is.
Oh, I'm not wearing. I keep
Am I
on forgetting
pointing
the
to
damn
Charlie?
hats. Okay, I'll just.
Listen to the little seminar.
Okay.
So did you catch any talks? What was some of your favorite talks?
I liked Sam's talk on APIs, and then I got a bunch of and so there were a bunch of like bio majors, and
are they still here?
No, they cycled out too.
There's a volleyball game.
Yeah, it's a Saturday night. People get. But so yeah, they were hearing Brynn's talk and they thought it was really cool.
Thank you.
And yeah.
Oh, Brynn, your talk on bioinformatics was really cool.
Thank you, Dan.
I think I might actually go into it.
You've inspired him to learn bio stuff.
Oh no, I know bio stuff. I
You've
am a
inspired
chemical
him to
engineer.
learn bio CS stuff.
I just need
Go
to learn
push.
Python.
He needs to learn Python.
Like more than I know it now. Oh my god, this is so freaking ridiculous. I'm not okay with how real this feels.
I feel like I should push you, but
God.
I'd feel like a dick if I just like came and pushed you.
Albert, I will hit you over the head with this keyboard so hard. You don't even know.
Yeah, I feel like that would help. You can't see me. I can be
No,
completely
I'd like
silent.
to run Minecraft using this.
That'd be cool.
That would be terrifying.
Oh
Well, now he knows where I am.
Well, no, I mean, like, I can move.
Especially with the spiders, if you tripped,
Oh my gosh.
running away from a creeper.
The thing is, like, we also have headphones with it, so like, yeah. So like, there's headphones attached, so like, you could theoretically sneak around Dan, and he wouldn't be able to notice.
That's true. No, honestly, the beauty of it is that, you know how when you're using Oculus Rift, if you ever have, that when you turn, if you're sitting in your chair, whatever your setup is with the computer, if you turn into a direction, like you're technically looking to the side, but you have to move forward. I wanted to give like the user the freedom to just completely just, you know, go in whatever direction they want.
Pretty much basic code.
And this power cable is still stopping me.
You should stop tripping on the power cable, dude.
But given a wireless power source for the computer, you know, I don't know. I could have 3, what are they called? The iBeacons?
Mm-hmm.
Colin was talking about this. Using iBeacons, you could just then have the beacons send back a signal to your computer to tell you where you are in the room, which could relate distance within the game. And then you don't even need like a pad on underneath your feet. You could just literally walk through the room, and that is, yeah.
That's pretty
So-
sweet.
So we're gonna call one more school. Thanks for talking to us, Albert.
No problem. See ya.
See ya.
live.
Hey, so you guys are live on the stream right now.
Hey! Hey guys! How are you doing? Super.
They're putting us on the giant screen. This is intense. So can you walk us around the venue?
Is that Nicholas? Is that Nicholas?
Or that was.
Are you sure? I thought so.
I can't tell. All I see is torsos.
So, I like those T-shirts. Would you show me show off the T-shirts?
That's Nicholas right there. Isn't it? It sounds like our live stream.
I really like the design of those T-shirts. Those are pretty cool T-shirts.
What are they?
But they're not wearing
Should we
hats.
young hackers? I don't know why they killed all of that one. I think they're getting echo back from the live stream.
What are they doing?
Hey, just walk us around the venue. Walk us around the venue. Tell us what's going on.
Everybody else is watching this action here.
Oh, we're on the screen now.
That's so funny.
We can see you, yeah.
Wow, there's a lot of people over there. Damn. The biggest local hack day.
How many people do you have there? So can you guys tell us about your event? Oh gosh, big screen.
What are they doing?
Do you have the volume turned down? This is really great. Can you guys hear us yet? Hello.
Okay.
Maybe we should,
Alright, let's get
Hey, so we're gonna move on to the next school. It was good seeing your venue though. Bye guys.
Wait, what are they doing?
Bye.
Bye.
Bye. Can you call him?
Any words of wisdom?
We like. So I want to hear. Go to someone in the crowd with a hat and have them tell us what they made.
So wait, you said crown them with a hat?
Someone in the crowd with
Someone random wearing a hat.
Oh, that guy.
That guy. I see a hat.
This guy. Let's see what he made.
I don't see. Those are those our hats?
Yeah, those.
You gotta spin them around.
Go, dude.
Oh wait, I need the hat. On the back
No,
of the hat.
go fix yourself.
Well, I need the Phil hat, guys. Who has the Phil hat?
Let's go fix. No, it must be. It must. Emily,
All right,
it must.
tell us what you built really quickly.
Go explain your project real quickly.
So it's a game where you can control someone's bodily functions. Specifically.
Talk loud.
Press the buttons.
Wait, you should start over.
Who started?
What is it? Sure, so.
They're frozen. We're not though.
Yeah, mind control. Let's.
What's really happening?
Yeah, this is really happening.
Alright, so the goal is to keep the heart rate between 100 and 170.
Is that a high heart rate?
Bro, people are wondering why. Are we gonna start presentations again?
Yeah.
All right.
So if the heart rate's not in the normal range, you lose health right here. I don't know if you can see anything. But...
Can you guys
see it?
Oh, you can see it.
So yeah.
So you click away and you either kill. Can you kill the person? Is this technically killing the person?
Yeah. If it gets out of hand.
Yeah. That's
Too low or too
awesome.
high.
That's a cool project. What was your favorite talk?
What'd you say?
What was your favorite talk?
My favorite talk?
Did you guys go to any talks?
We briefly looked at the JavaScript one, and that was pretty interesting. In fact, we went to another hackathon, Code Day, and we were looking at JavaScript, so it was pretty cool.
They freeze sometimes, but they're still there because they come back right back.
That's awesome. Thanks, guys.
All right, thanks to you guys.
And this.
Exchange.
There they are. Bro. John, you want to come on for this one?
What is going on?
Hold on, we're bringing John here. John has some questions about this.
I don't know what's there.
All right. This is dance.
Oh, you're on.
Okay, turn it on.
Hey guys,
Hi.
how you doing?
How's it going?
It's going great. Can you tell us about that dance?
No.
We've been listening.
Naturally.
We've been listening to Black MIDI all afternoon, and we put on some Sandstorm because obviously we needed that at 8:30 at night. So here we are.
It seems appropriate.
Yeah.
So what did you build?
Me?
Find someone in the crowd with a hat and ask them what they built.
Hey Max, you're beside me and wearing a hat. What did you build?
I built a visualizer for MIDI and MP3s.
That sounds exciting. Can we see it?
Sure.
Where's your laptop?
It's over there.
Oh.
Yeah, I like that MLH sticker.
Woo!
Actually, let's see the back of your laptop. Let's see if I like that sticker.
Pen ups? Woo!
McGill.
Yeah.
That's a good one.
That's where we decided to do local hack day. Was at McGill.
That was a good one.
Yeah. So, what was your favorite talk?
Well, we liked the Git one quite a bit. I think we all saw that one twice, and that was fun. Yeah. What else?
Why did you watch it twice?
What was that? Oh,
Why twice?
What?
Oh, here's Max's thing. Here we go.
did not write that song. All right. I like it. Thanks, guys. And thanks for talking to us.
Yeah, great
for
to
having
see you.
us.
This has been really fun.
Yeah, I'm glad you enjoyed it.
Bye.
Bye.
So now you're live.
Yeah, I'm coming.
Oh, look, it's the Eastern Seaboard, America, and Canada.
Oh, hello there, America. Hi.
So this is Local Hack Day HQ coming at you live. It's almost 9 p.m. John is in front of the camera. It's almost 9 p.m. And America, we just wanted to wish you, and Canada, we just wanted to wish you a good night. Now watch us fold some papers. Anyway, in serious business though, hopefully you guys got a lot out of Local Hack Day. We had a lot of awesome talks. I want to thank our sponsors one more time. We had DigitalOcean, Keen.io, and OrderIn. Without them, obviously none of this would have been possible. Hopefully you guys are staying warm in your wonderful hats, which got a lot of love on the air today. Hopefully you made some new friends, met some new people.
Learned something.
Learned a thing or two. Maybe tried something new. And hopefully you got a lot out of Local Hack Day. And we're really excited to have you on board with us. And I guess we'll see him again next time.
Yeah, as you guys leave, make sure to say thank you to your organizer that made this possible. We really appreciate all the organizers who helped us. So I guess that's it, Eastern Seaboard. We'll see you later. But for
1,500 stream players.
We've had 1,500 people watch this stream in the course of the day. That's fantastic.
Damn.
And we're not done yet. If you're in California or even Texas, we definitely have more content for you. So stay tuned. We've got a Rails talk coming up, and then Swift is doing how to be a badass hacker, which is one of the best talks that I think I see him do.
Really? Wow, that's high praise right there. Yeah, so lots more coming at you guys. Stay tuned. Good night, Eastern Seaboard, or maybe you'll stay up the rest of the night and keep hacking as well.
Feel free to keep up with us.
Yeah, peace. All right. Good night.
Night.
Ow! Oh! Woo! Shred that! Yeah. I'm back! I know it! I'm back! I know it! Yes, sir! I'm back! I'm back! I'm back!
Start spreading the news. I'm leaving today. I want to be a part of it. New York, New York. These vagabond shoes are longing to stray right through the very heart of it. New York, New York. I want to wake up in a city that doesn't sleep and find I'm king of the hill, top of the heap. These little town blues are melting away. I'll make a brand new start of it in old New York. If I can make it there, I'll make it anywhere. It's up to you, New York, New York. wake up in a city that never sleeps and find I'm a number one, top of the list, king of the hill, a number one. These little town blues are melting away. I'm gonna make a brand new start of it in old New York. And if I can make it there, I'm gonna make it anywhere. It's up to you, New York, New York, New York. Oh, she may be weary. Them young girls, they do get wearied wearing that same old shaggy dress. Yeah, yeah. But when she gets weary, try a little tenderness. Yeah, yeah. Oh, man, that. You know she's waiting, just anticipating for things that she'll never, 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 never possess. Yeah, yeah. But while she's there waiting, and without them, try a little tenderness. That's all you gotta do. It's not just sentimental, no, no, no. She has her grief and care, yeah, yeah, yeah. But the soft words, they are spoke so gentle, yeah. It makes it easier to bear, yeah. You won't regret it, no, no. Young girls, they don't forget it. Love is their home, happiness, yeah. But it's all so easy. All you gotta do is try.
light we've seen. No, I won't be afraid. No, 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 I won't be afraid. Just as long, just as long, just as long as you stand by me. Now, darling, darling, whenever I'm in trouble, darling, won't you stand? I need just a little heaven here right now. And darling, darling, won't you stand by me? If the sky you look upon should tumble and fall, all of the mountain may crumble to the sea. I won't cry, I won't cry. No, 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 I won't shed no tears. Just as long, just as long, just as long as you stand by me. Now, darling, darling, I said I need somebody right now. I need just a little helping hand. Need someone to come pick me up and let you stand by me. Come on now, baby. Yeah. My baby. Whoa, whoa. Come on and stand by me. And darling, darling, stand by me. Come on, pretty baby, stand by me. Come on and help me, baby. I need a little love. Come on and stand right by me. Whenever I'm in trouble, won't you stand? Come on and stand by me. My baby. Come on. I've been loving you too long to stop now. You were tired and you want to be free. My love is growing stronger as you become a habit to me. Ooh, I'm loving you too long. I don't want to stop now. Oh. With you, my life has been so wonderful. I can't stop now. You're tired, and your love is growing cold. My love is growing stronger as our affair grow old. I've been loving you oh too long to stop now. Oh, oh, oh. I've been loving you a little too long. I don't want to stop now. Oh, oh, don't make me stop now. Oh, baby, down on my knees, please don't make me stop now. I've got sunshine on a cloudy day, and it's cold outside. I've got the month of May. Oh, I guess you say what can make me feel this way. It's my girl talking about my girl. I've got so much loving, oh, the bees into me. I've got a sweeter song that I can sing, the new birds in the trees. Oh, I guess you will say, ooh, what can make me feel this way? It's my girl talking about my girl.
Hey, I'm Jason with Major League Hacking, and tonight I'm going to talk about Ruby on Rails. So, what is this Rails thing that everyone's been talking about? Rails is a web framework based on the Ruby programming language. This is a really important distinction, as it turns out, because when someone writes a web application in Ruby on Rails, they might say that they're writing Rails, and